For this section of the course, we will be discussing Excel's pivot tables. And pivot tables are one of the most powerful features inside of Microsoft Excel. Pivot tables allows us to extract significant data from a large detailed data set. So basically, we can create a summarized list of our data that we have interest in. And pivot tables come with many great features such as building reports, sorting, filtering, grouping, and the list goes on. And in the next few videos, we will cover some of these features, but for this lecture, we are going to focus on how we can create and insert a pivot table inside of our worksheet. So before we begin, I want to point out that we are working inside the Pivot Tables Sheet tab. So make sure that you have this tab selected. And just a quick tip, I know we have a lot of sheet tabs inside this workbook, and it might be tedious at times to use this arrow to scroll through the sheet tabs, but if you give this arrow a right click, it will give us a list of all the sheet tabs inside this workbook, and we can select the sheet that we want to activate. Our pivot table sheet is already selected, so I'm going to click OK. Now in order to create a pivot table, the first thing that we have to do is select our data. So what we can do is click any cell within our data set and then use the keyboard shortcut Control A or Command A if you're on Mac. And this will select all the data within our data set. And then we can come up to the Insert tab and select Pivot Table. And if we look inside this pop-up window, we can choose the location where we want to place our table. In this first box, shows the range of cells that include our data, so that's good. And then down here, we could either choose to insert our pivot table on a new worksheet or an existing worksheet. For this example, I'm going to select Existing Worksheet, and for the location, we can click inside this box and select a cell on this current worksheet. So that way we can have our data set and our pivot table on the same worksheet. So I'm going to select cell J2 and click OK. Now that we got our pivot table inserted into our spreadsheet, we have two new tabs within our ribbon, which are Pivot Table Analyze and Design. And we also have a Pivot Table Fields window pop up on the right side of our screen. And here's where we can select and rearrange our data for our pivot table. And if you noticed, these labels right here are the same as our column headers within our data set. So it's important to have headers within your data set when you're working with pivot tables. So let's start to create our first pivot table report. Let's say that we want to sum up all the cells for each product ID. Well, we can come over back to our fields window, and down here we have four different areas: filters, columns, rows, and values. And this is where we can drag our fields to rearrange our pivot table report. So let's just check cells and see what happens. Excel automatically put the cells within the values area. And up here in our report, it says that the sum of cells is $51,526. So automatically, Excel summed all the cells within the cells column. But we want to see the total cells for each product ID. And if we take a look at our product ID column, we can see that we have a product ID of D104, A101, D104, D104. So there's multiple product ID numbers, but they also get repeated. So what pivot tables can do is group these product IDs together and then sum the cells for each unique product ID. So if we select product ID, it automatically put it in the rows area. And now if we look at our report, we can easily tell that the sum of cells for the product ID of A101 was 10,470. And for the product of B102, the cells were 18,901, and so on. And then it also gives us a grand total of all the cells combined. So that's how you can create a pivot table. It's very quick and simple to do, and it can give us a lot of detailed information about our data. And over the next few videos, we'll start to discuss how we can modify, group, filter, and other neat features that pivot tables come with to reveal the advantages and benefits when it comes to utilizing pivot tables to build sophisticated reports. Alright, now that we got our pivot table in our spreadsheet, we can start to apply some modifications to our report. So in the previous video, when we checked cells, by default, Excel automatically added to the values box, and then summed all the values to get the total amount of cells. Well, the reason why it did that is because Excel knows that the cells column has numeric data. So Excel assumed that we wanted to sum those values. But let's say that we dragged one of our fields in the values box that only included text values. What will Excel do then? Well, let's try it out. Let's uncheck the cells and the product ID, and this time we can drag product ID to the values box. So instead of Excel automatically applying a sum, it applied a count, because we can't sum text values. And up here in our report, it shows that the total count of all the products combined is 99. And if we wanted to see the count for each unique product ID, we can drag the product ID to the rows box as well. So let's do that. Now in our pivot table, we can see the count of each product ID. Now let's change this pivot table back to where we could see the total cells for each product ID. We can remove the product ID out of the values box by just clicking and dragging up. And then to get the cells back in there, we can click cells and drag it to the values. And once again, since the cells column has numeric data in it, Excel automatically applied a sum for our cells. So currently in our report, our cells column has no formatting applied to it. So it's a little bit hard to read these values. But luckily, we can apply number formatting to our report just like how we can format cells within our worksheet. So to do that, we can come down to the sum of cells in our values box, give it a left click, and select Value Field Settings. And in our pop-up window, we can select Number Format. And since we are dealing with money, I'm going to select the currency format. And then we can click OK. OK again. Now in our pivot table, the sum of cells column has the currency format. We also have the option to change what this report does to the cells column. Currently, it's summing all the cells for each product ID. Well, instead of using sum, what if we wanted the average of the cells for each product ID? So to change that, we can left click our sum of cells in our values box, go back to Value Field Settings, and in our pop-up window, we have the choice to sum, count, average, max, min, and so on. So if we wanted to average our cells, we can select average and click OK. Now our pivot table is averaging the cells for each product ID. I'm going to press Ctrl Z on my keyboard to undo that action to get back where our pivot table is summing the cells for each product ID. Now let's take a look at our data set. We have this units column that shows how many units were sold for that product ID. So if we wanted to make our report a little bit more detailed, we can include the total units sold for each product. So what we have to do is click anywhere back inside of our pivot table, and then we can select our units and drag it to the values box. Now our pivot table shows the total cells and the total amount of units of each product ID. Well, if we wanted, instead of summing the amount of units for each product, we can show this value as a percentage of the grand total. So if we left click the sum of units in our values box, go to Value Field Settings, and then we can click the Show Values As tab, And then within this dropdown, we have multiple options to choose from. And for our example, we can select % of grand total. Then click OK. Now our pivot table is showing the percentage of how many units were sold for each product ID. And currently in our pivot table, it is sorting by the product ID alphabetically. But if we wanted to see the largest cells to the smallest cells, we can select our sum of cells column, come up to the Data tab, and select the descending sort, which is largest to smallest. Now we can easily see that the product B102 has the highest amount of cells, and product A101 has the lowest. So those were a few options how we can modify our pivot tables. Play around with it, drag different fields to these quadrants down below, and see how your pivot table changes. And in the next video, we will talk about how we can group and filter data within our pivot table. Alright, now that we have seen a few ways how to modify our pivot table, now we are going to discuss how we can group and filter within our pivot table. Okay, so within our report, let's say that we want to see some date values so we can see when these products were sold. So over here in our fields window, we can check date. Alright, so a few things have happened here. Even though that we selected date, Excel created a new field called date parentheses month. Now depending on what version of Excel you have, it may do this automatically, but if it doesn't, I will show you how to get this field here shortly. So Excel created this new field to try to be helpful, because Excel knows that we have a bunch of different date values within our date column in our data set, and if it included every date value, this report would be very congested and hard to read. So it automatically took all of our date values and grouped them into months. Now our report is a little hard to read at the moment because we are getting the sum of sales and the percentage of units for each month. So for now, we can deselect units so that way we can see the sales for each product for each month. And since that we have more months than we do products, I think this report would look better if we switched our column labels with our row labels. So we can drag the date month field over to the rows area, and then we can grab the product ID and move it to the columns area. Now this report is a lot simpler to read. We have our months in our row labels, and then we have our product IDs in the column labels. And we can see for each month what the total amount of sales were for each product, and the grand total of sales for that month. So like I said before, if your version of Excel doesn't automatically group the date values into months, it might look something like this. I'm going to drag the date field down to the rows area and deselect the date month. So if your report looks like this, with each individual date value in the row labels, you can select any value within this column, give it a right click, and select Group. And then we can tell Excel what to group it by, so we can select Months and click OK. Now you should have the Date Month field, and Excel put it in the rows area. And the reason why our report is bold now with a bunch of little plus signs next to our months, since we manually grouped our date values into months, if we click one of these plus signs next to our month, it will expand and show every date value within that month. So if you are interested in seeing the total sales for a specific date, this would be a good option. But if you were just interested in the total sales for the month, you can just collapse all the months, or you can deselect the date value and just keep the date month field in our rows area. Now if we wanted to see the total sales for each quarter instead of each month, we can do that by just clicking a cell within the column that you want to group, give it a right click, and select Group. And instead of months, we can select quarters. And I'm going to deselect months and click OK. So once again, now Excel added another date field, but this date field is by quarter. And it added it to our rows area, and now our report just shows the total sales for each quarter. So that's how we can group data inside of our pivot tables. We can also filter data as well. So let's deselect the date by quarter and put in the date by month again. Now, one way to filter is that pivot tables automatically come with a drop-down arrow, and if we click this, we can select which months that we want to filter. For example, if we only wanted to see January, February, and March, we can deselect all the checkboxes and just select January, February, and March. And if we click OK, now our report only shows those 3 months. Now we can clear that filter by clicking the filter button and select Clear Filter. Now another way to filter inside of our pivot tables is to drag one of these fields into the filter area. So once again, if we wanted to filter by the month, we can select our month field and drag it down to the filters. Well, if we look at our report, we can tell that this didn't work. It's because it removed the month field that was in our rows area and put it in our filters, because we can't have the same field in our rows area as we do in our filters area. What we could do to still be able to filter by month is to leave the months field within our filter area and then drag our date field into our rows area. And now what we can do is come up here to the top to where our pivot table added this new filter section, select this drop down, and expand all, and then we can choose which months to filter. And this time, if we wanted to see April, May, and June, we can deselect all and just select April, May, June. And click OK. Now we can see the total sales for each date value within those 3 months. So depending on your needs and how you want to view your data, you have multiple options to choose from to how you can filter or group your data to your liking. Another feature that pivot tables have that I want to discuss with you really quickly is the drill down feature. And we can use the drill down feature to see the details that were used to come up with a total. So when we created this pivot table to summarize our data, each of these numbers in the values area represents one or more records in the pivot table source. So within our pivot table, we can select any of these numbers and drill down to see the details of these numbers. So for example, let's take the total sales of product A101 for the month of January. To drill down, all we have to do is double-click this cell. Now Excel created a new sheet and named it Sheet 1, and it also provided us with this table. And these are all the records that make up the total for the product A101 for the month of January. And if we select our sales column, we can see that this sums up to 1909 in our status bar. And if we go back to our pivot tables tab, the sum of sales for A101 for January is 1909. So this drill down feature can be really helpful if you want to see the details of a specific value. Now, one thing to keep in mind, if our data source updates and then we update our pivot table, this drill down sheet doesn't get updated. So in order to have the most recent changes, you have to make sure that you update your pivot table and then create a new drill down sheet. So once again, drilling down to see the specific details of a value inside of our pivot table is very easy to do. All it takes is a double click and it automatically filters the data for that value. So as we can see, using pivot tables allows us to create really organized and sophisticated table form reports. But another neat feature that comes with pivot tables is pivot charts. So not only can we see our data in table form, but we can present our data in chart form as well. So to insert a pivot chart, we can select any cell within our pivot table, then come up to the Pivot Table Analyze tab, and then select Pivot Chart. And then from here, we can select any chart that we want, but for this example, I'm just going to use the clustered column chart. So if we click OK, now we have inserted our pivot chart. Now the difference between pivot charts and regular charts that we have worked with earlier in the course is that if we change anything in our fields window, it will not only update our pivot table, but it will update our chart as well. And vice versa. Anything we change in our pivot chart using these filter buttons, it will update our pivot table as well. So our pivot table and our pivot chart are always connected. And let me show you what I mean by that. So let's say in this column chart, we want to have the different product IDs on the x-axis, and then show the amount of total sales for each product. So if we come over here to our fields window, we can select the month and drag that out. And then to get the product ID on the x-axis, we can move the product ID out of legend and move it to axis. So now our chart shows the total sales for each product ID. And the same goes for our pivot table. So both our pivot table and pivot chart updated. Now let's mess around with our different fields and see what ways we can view our data in chart form. So let's say that we wanted to see the total sales for each product by region. Well, all we have to do is select our region field and drag it down to our legend. And this added the legend to our chart that includes the regions, and then it also added the regions to our column labels in our pivot table. Now let's try to get our chart to show the total sales for each product for each quarter. So we can deselect region and then select the month, move our product ID to the legend, and then we need to group our months by quarter. And to do that, we need to select a month in the row labels, give it a right click, and select Group. And then we can select Quarters and click OK. Now we can see the total sales for each product by quarter. And if we wanted to apply filters to this chart, we can either apply a filter to the product ID or the quarters. For example, if I click this drop down, I can select which quarters I want to filter. So let's say we only want to see quarter 1 and 2. We can select those and click OK. And if we want to apply a filter to the product ID, we can select its filter button and then select the products that we want to show in our chart. Now our chart is showing the total sales for product A101 and B102 for quarters 1 and 2. And by applying these filters to our chart, it also applied the filters to our pivot table. And if I change the filters in our pivot table, it will do the same for our pivot chart. So that's one option we could use to filter data inside of our pivot table and pivot chart. Another option is to use slicers. Now before we insert a slicer, I do want to mention that slicers are only available for Excel 2016 and newer. And slicers can be located underneath the Pivot Table Analyze tab. And then we can select Insert Slicer. And then from here, we can select which slicers to insert. So if we want to have an option to filter by region, we can select Region. And if we want to filter by the month, we can select Month. And if we click OK, now Excel has inserted these slicers. So slicers allows us to easily filter data inside of our pivot table or pivot chart. For example, in our chart, on the x-axis we have the quarters, and then we have the product IDs in the legend. So the month or a region is currently not in the chart or the pivot table, but we can still filter by the month and region because that data is still resting in our source. So for example, let's say I only want to see the total sales for the North region. I can click North, and now our table and chart only shows the data for the North region. And if I want to select multiple regions, I can click the Control key or the Command key if you're on Mac and select another region. So let's say that we want to see the North and South region. Now we're only seeing the data for those two regions. Another neat thing with slicers is that we can apply multiple filters at the same time. Right now we're seeing the data for the North and South region, but for all the months. So in our month slicer, we can select which months that we want to show in our chart. So let's say that we want to show January, and I can press the Control key or the Command key to select more months. So let's just select February and March. Now our table and chart only show data for the month of January, February, March for the North and South regions. And the reason why our chart only shows quarter one is because we only have January, February, and March selected, and all the other months are filtered out. So if we add April, May, and June, now it's showing quarter one and quarter two. And to clear these filters, all we have to do is click on the red X at the top right-hand corner of the slicer. And this will clear the filters. Slicers also come with a lot of formatting options as well. We can resize these slicers by clicking and dragging one of the endpoints. And underneath the Slicers tab, we can apply different styles to these slicers as well by clicking this drop-down underneath Styles and then select the style that you prefer. So let's say that we want a dark blue color instead of a light blue. It's totally up to you. So that's how we can view our data in our pivot table in chart form. And within our chart, we can use the filter buttons or add slicers to filter our data. And whatever changes we make to the pivot table or the pivot chart, they will always be connected to each other, making our spreadsheets more dynamic. Alright, so for this section of the course, we will be discussing Excel's Power Pivot add-in. And before we jump in and start using this add-in inside of Excel, I briefly want to discuss what Power Pivot is and what it can allow us to do. And hopefully, once we start using the Power Pivot tool within our spreadsheet, you will have a better understanding of what we are trying to accomplish. So first, let's define what Power Pivot is. Power Pivot is a data modeling technology that lets you create data models, establish relationships, and create calculations. So what is a data model? Well, a data model allows us to integrate data from multiple tables, meaning that if we have multiple tables of data, we can create relationships between these tables to create a more sophisticated report. And using data models within Power Pivot enables us to work with larger sets of data. For example, in an Excel spreadsheet, we are limited to just a little bit over 1 million rows of data. And depending on the size of our data, Excel can really struggle and slow down once it gets over a certain amount of rows. But with Power Pivot, we can work beyond this limitation. So we can have even more than 1 million rows of data. And even then, we will still be able to produce smaller, leaner, and faster workbooks. Because with the data model, our data is not actually on a separate Excel worksheet. Instead, we are loading this data into the internal data model of the Excel Power Pivot tool. So with all that being said, I'm going to explain what the Power Pivot tool can allow us to do. So in the next few videos, we will be working with 3 separate data sets. We have the sales data, the customer data, and the product data. And inside these data sets have different types of data inside them. And if we tried to build a single report off these three data sets, we would manually have to combine all the data into one data set. And sometimes that's impossible to do. But with the Power Pivot tool, we can create relationships between these data sets. And to create these relationships, these data sets need to have unique identifiers, meaning that somewhere in our data sets, they share a similar column. And if our data sets have these unique identifiers, we can establish links between these data sets to create a relationship. And if we are able to link these data sets together, we can create a more detailed and sophisticated single report without merging these three separate data sets into one. So for example, if the sales data shares a unique identifier with the product data, we can pull data from both of these data sets and then use that data in our report. Well, this may or may not make sense at the moment, but hopefully once we start working with the Power Pivot tool, you'll get a better understanding of how we can create these relationships and analyze data from multiple tables. So before we actually start using the Excel Power Pivot add-in, the first thing that we have to do is activate this add-in so we can access the Power Pivot tool. And I also want to point out for the rest of this section, we are going to be working inside a new Excel workbook. So if you haven't done so, you can go ahead and open up a new workbook. But make sure you save the current progress we have made in the other Excel practice file, because we will be returning to that practice file when we get to other sections of the course. So what we have to do is come up to the File tab and then click Options at the bottom of your screen, and then we can select Add-ins, and down here in this Manage box we can select this drop-down, and then we need to click on COM Add-ins. And then if we click Go, we can check the box labeled Microsoft Power Pivot for Excel. And then we can click OK. Now if you notice, we have a new tab in our ribbon labeled Power Pivot. And if we give this a click, now we have access to different Power Pivot tools. So now that we have the Power Pivot add-in activated, we are ready to start creating our first data model and create relationships between our data tables. Alright, now that we have the Power Pivot add-in activated, it's time to create our first data model. And if you haven't done so already, please make sure to download the Power Pivot Data Tables Excel file from the resources, because that's the file we are going to create the connection to for our data model. So to import data into our data model, what we have to do is come up to the Power Pivot tab, and we have a few options. For example, if we had a list of data within this workbook itself, we could click anywhere inside the data set and then select Add to Data Model. But since we are going to connect from another source, what we have to do is click Manage. And this will open up the Power Pivot window. And within the Get External Data group, we have multiple options on how to retrieve our data. We can import our data from a database, like Microsoft Access, or from other sources. So if we give this button a click, we can see all the sources that we can choose from to connect our data. And since we are trying to connect to a different Excel file, we can scroll down this list and select Excel file. And then if we click Next, we need to tell Excel where this file is saved on our computer. So we can come up to Browse, then locate where you saved the Power Pivot Data Tables file. Mine is just on my desktop, and then we can just click this file and select Open. Now within that Power Pivot Data Tables file, there are three separate sheet tabs. and each sheet contains a separate table. And in those tables, we do have column headers. So we want to make sure that we select Use the first row as column headers. And then we can click Next. Now our import wizard can see that there's 3 different sheet tabs within that Excel file that have data in it. And we want to select all these tables, so we can select this checkbox at the top to select all the tables and click Finish. And then if we close out of this, now we successfully loaded these tables into our data model. So we have our customer data, our product data, and then our sales data. Now that we have these tables within our data model, it's time to link these tables to create relationships. And the easiest way to establish these connections is to change our view. So if we come up to the top here, we can see that we are in the data view. But let's change this to the diagram view. Now it shows us our 3 separate tables and the column headers within those tables. Now the sales data is a little bit cut off, but we can select this table and drag down to resize. So really quickly, let's go back to our data view and take a look at the data within these tables and see what we are missing from one table that we could get from another. So let's go back up to data view and select our sales data. So in our sales table, we have order ID, the date, the customer ID, product ID, the unit sold, and the total sales. So what if we wanted to get the name of the customer that bought a product? Well, in this sales table, we have a customer ID. And if we go to our customer table, it also has a customer ID, but then it has the customer name, city, and the phone number for that customer. So these 2 tables share a unique identifier, which is the customer ID. So let's go back up to our diagram view. And I'm going to move these tables around a bit by clicking on the name of the table and dragging it to where we want it to be placed. So to connect the sales table to the customer table, we need to grab that unique identifier, which is the customer ID, and we can just click and drag to the customer ID in the customer table. And that's it. Now we have established that connection. Now let's establish a connection between the sales table and the product table. Let's go back to the data view and then click on the sales table. And then we need to find a unique identifier that the sales table and the product table share. So in the sales table, we have this product ID column. But what is this product? We just know that it's P801 or P301. What's the name of the product? What's the unit price for this product? Well, if we select our product table, we have the product ID, the product name, and the unit price. So the unique identifier that these 2 tables share is the product ID. And if we go back to our diagram view, we can select the product ID in the sales table and then click and drag to the product ID in the product table. Now that we have established these connections, we can go back into Excel and create a pivot table to build a report that can include all the data from these 3 separate data tables. Okay, so now that we have our 3 separate data tables connected inside of our data model, we can report off this data model by creating a pivot table. So inside of our Power Pivot window, we can select Pivot Table. And then we can either insert this pivot table on a new worksheet or an existing worksheet. I'm going to click Existing, and then we have the option to select the cell within our worksheet of where we want to insert our pivot table. So instead of cell A1, we can click this little graphic off to the right and select a different cell that we want to insert our pivot table in. I'm going to select cell B3 and then click OK. OK again. And now we have inserted our pivot table. And then over here to the right, inside of our pivot table window, it's a little bit different than what we're used to. Because previously, when we were just working with one data set, we could only select the fields within that data set. But now that we have 3 different data tables, we can select different fields within each one of these. So for example, if I click the drop down for sales data, we can see all the columns within that table. And then if we expand the product data, we can select those columns as well. So let's pretend we only had one data set in our pivot table. And let's say that we only had the sales data. And if our goal was to see the total amount of sales for each product ID, we could select the total sales, which it automatically put in the values area and sum those cells because this column has numeric data in it. And then to see the sales of each product ID, we can grab product ID and click and drag it to the rows area. So we have done this before when we were just creating standard pivot tables. But let's take a look at our report here. We can see the total sales for each product ID, but we don't know the names of these products. For example, let's take a look at product ID P101. If we go back and open up our Power Pivot window, and then go to our product data, we can see that the product ID of P101 is a pencil, and P201 is tape, and so on. But you might not know that just by looking at the product ID. But since we have created the relationship between the sales data and the product data, and using product ID as the unique identifier, we can add the product name to our pivot table. So let's get back into Excel. And over here in our pivot table fields, underneath product data, we can click and drag the product name to our rows area. Now we can see that the product ID P101 is pencil and P201 is tape. But if you don't want to see the product ID and just see the product name, we can just uncheck product ID. And now our pivot table shows the total sales for each product name. But the only way we can make this happen is to create a data model and establish relationships between these two tables so we could grab data from both of these tables to include them in our report. So this was a basic example of how we can create a pivot table based off our data model. And in the next video, we'll see a few more examples and also add KPIs, which stands for Key Performance Indicators, to our pivot table. So for this video, we will be discussing what are key performance indicators and how they can benefit. So key performance indicators, KPIs for short, are just a visual measure of performance. So basically, they gauge the performance of a value against a target value. And KPIs just help with the visual representation when it comes time to measuring data. So to start adding KPIs to this pivot table, the first thing that we have to do is create some measures within our data model. And to create measures, we have to go back inside of our Power Pivot window. So let's click the Power Pivot tab, and then we can select either Measures or Manage. I'm going to select Manage because I think it's a little bit easier to see and understand which data we are applying the measures to. So if we click Manage, we can come down and select the sales data, and then any cell that's below this line is where we can insert calculations or measures. For example, let's say that we wanted to get a distinct count of all the product IDs within this data table. So if we select this cell that's underneath this line, but still within the product ID column, we can insert a calculation. And we can do that by coming up to the calculations group, and if we click this drop down next to auto sum, we can insert the calculation that we want to perform. So in this case, we want to count how many unique product IDs are within this column. So what we need to do is select distinct count, and then up here in our formula bar, it shows that it inserted the function of distinct count for the product ID. And if we move our cursor between the product ID column and the units sold column, we can click and drag to increase the size of this column. So down here in our calculation, it shows that we have a total of 10 unique product IDs. Although that this measure is valuable to know, we can't really apply KPIs to the distinct count of product IDs within our pivot table. But a good measure to track would be the amount of units sold per product. So let's select the cell within the units sold column, and then we can apply a calculation here to sum the amount of units sold. So we need to come back to our calculations group, and we can just click auto sum. And if we expand the width of our column, we can see that the total amount of units sold is 1,055. So that's how we can create measures within our data model. And measures are needed to create KPIs. So now we can go back to our Excel workbook, and if we look at our pivot table fields, we will see two new fields added to our sales data. We have distinct count of product ID and sum of units sold. And this FX icon symbolizes that this field is a measure. But we can use these measures inside of our pivot table. So let's uncheck total sales and then check sum of units sold too. So now we are using that measure inside of our pivot table. And now we are ready to apply KPIs to this measure. So if we come up to our ribbon, we can select KPIs and then click New KPI. In the first box, we need to select the measure that we want to apply the KPI to, and since we have sum of units sold within our pivot table, we need to click this drop down and select sum of units sold to. And then in the next section, we can define a target value so we can see how well the units sold for each product is doing in relation to our target value. Currently, our target value is measuring in percentages. If we want to specify a certain amount for our target value, we can select absolute value. So let's say that our target value for the amount of units sold for each product is 100. We can select this box and type in 100. Now in our little thresholds diagram, we can see that our target is placed in the green. So if the units sold for our product is above 80, it will be in the green, and if it's between 40 and 80, it would be in the yellow, and anything below 40 will be in the red. And then we can select any icon style that we want to place inside of our report. I'm just going to keep the default selected, and then click OK. Well, our pivot table just put 1, 0s, and -1s inside of our report, instead of the green, yellow, and red indicators. So to fix this, we can come over to our pivot table fields, and then we can select the drop-down next to this stoplight icon, symbolizing that this is a KPI, And then we can just uncheck status and then check status back again. So now we have these indicators inside of our pivot table. And it's very easy to tell how our products are selling in relation to our target value. So we can come over to our report and instantly tell that the calculator sales are good, the Ethernet cables are doing okay, and then the keyboard sales are down quite a bit. So let's do another example. Let's track the sum of units sold by the city instead of by the product name. So if we come over to our pivot table fields, we can deselect product name, and then we need to select the city within the customer data table. Well, if we scroll down, our customer data is not there because currently we are only displaying the active fields. If we select all fields, now we are able to see our customer data table. And then we can select our city and drag it to our rows area. Now the reason why I wanted to do another example is to show that our KPI values remain the same. So if we come up to our ribbon and click KPIs, Manage KPIs, and then select Sum of Units Sold To, and if we click Edit, we can see that our target value remained at 100 and our thresholds remained at 40 and 80. So if you ever change the fields inside your pivot table, like what we just did, we went from summing the units sold by the product name to summing the units sold by the city. And you might have different target values depending on the fields that you have in your report. And if that's the case, you would want to open up this KPI window and edit your values. So that's how we can add KPIs to our pivot tables to easily visualize and gauge the performance of our data. Alright, so for this section of the course, I'm going to be introducing some of Excel's conditional functions. And conditional functions are used when we want to perform a calculation when a cell contains a specific value. So by using conditional functions, we can make Excel return one value if the condition is true, and another value if the condition is false. And one of the most commonly used conditional functions is the if function. So that's the function we will be working with first. And I want to point out that we will be working inside the if function sheet tab for this video. So to begin, make sure that you have this sheet selected. So what the if function does is that it runs a logical test and then returns one value if the test is true, and then a different value if the test is false. So let's take a look at our example in this worksheet and see how we can apply the if function. So in the first column, we have names, and then in the second column, we have each person's score. And let's say that our goal for column C is to insert a certain value depending if that person's score is a passing grade or a failing grade. So to insert the function, we can type in the equal sign and then start typing if. And then we can give the if function a double click. And then we can open up the function arguments window. And the first argument is the logical test, which is any value or expression that can be evaluated to true or false. So what we are testing is if that person's score is above or below the failing grade. So for our test, we can select that person's score, and let's say that the failing score is 65. So any score above 65 is passing. So we can say if B2 is greater than 65, then return this value if it's true, or return another value if it's false. So for our second argument, if the value is true, we can return a text value saying pass. So we have to type in open quotes, then pass, and then close quotes. So keep in mind, anytime you're working with text values inside of Excel formulas, you have to put quotes around the text. So if the person's score is above 65, return true. And if it's below 65, so if the value is false, we can return fail. And we can see that this function will return pass. Because B2, which is 89, is greater than 65, which is true, and if the value is true, return pass. And if we click OK, now pass is inserted into that cell, and if we move our cursor to the fill handle and give it a double click, it will copy this formula down for the rest of our data, and since we use a relative reference B2 in our formula, that B2 will get changed to B3, B4, and so on. So if we double click our fill handle, it fills the formula for the rest of our data, and if we take a look to see which values got returned, well, we know that 76 is a passing grade, 93 is a passing grade, but for cell C5, the formula returned fail, because 62 is below 65. So if the score is not above 65, that means it's false. And if the value is false, we told the function to return fail. So that's how you use the if function. Now within our formula, we told the function to return the text values of pass or fail. But the if function is not limited to returning text values. We could have put cell references inside of this formula. So if the test was true, return the value that's in this cell, and if the test is false, return this other value in this other cell. So we can customize the if function to return the values that you want depending on your needs. Okay, so now we are going to expand the if function by combining it with other conditional functions. So the first function that we are going to combine with the if function is the AND function. And let's see what Excel defines the AND function as. So if I type in AND, and this function checks whether all arguments are true and returns true if all arguments are true. So basically, in the previous video, when we just used the if function by itself, we could only test one condition. But combining it with the AND function, we can test multiple conditions. And if all the conditions are true, then we will return a true value. But if one of those conditions is false, let's say one of them's true but another one is false, then this function will return a false value. So to get a better understanding, let's put it to action and see what happens to our results. So I'm going to delete this. Now this time, instead of going into the function arguments window, I'm just going to type the formula straight into the formula bar. So first, we have to start off with the if function. So we can type in equals if, then open parentheses. And our first argument is bold, which is the logical test. Well, this time, instead of testing one condition, we want to test multiple conditions. So for this example, we have score 1 and score 2. And our goal is to see if the person passed both tests. So if the person passed both tests, then we want our value to say pass. But if a person failed either one of the tests, we want our result to come out as fail. So let's see how that looks in our formula. So for the logical test, we are wanting to test multiple conditions. So this is where we will place the AND function. Then add another open parentheses. And you can see that our first argument is bold, and it's asking for the first logical condition. So the first condition that we want to test is to see if that person has a higher score than 65 for score 1. So we can use a cell reference and select the first score, and then we can type in greater than 65. So that's the first test. And then if we type in a comma, now we can put another condition inside the AND function to test. And for our second condition, we want to see if this person got a higher score than 65 for score 2. So we can select score 2 and then type in greater than 65. And since those are the only two conditions we are going to test, we could put a close parentheses and close out the AND function. So if we put a comma, now we're back inside the if function, and the argument that the if function is asking now is what value we want to return if both of our conditions are true. So we can do the same as before, open quotes, pass, comma. Now the if function is asking for the false argument, and we can put fail. And then close the parentheses. So let's click enter and see what we get. Well, our formula returned pass. Because the way this formula reads, if score 1 is above 65, which it is, and if score 2 is above 65, which it is again, return pass, because both of these conditions are true. Now let's double click the fill handle and see what we get for these other people. Alright, so for Megan, we got fail. While on score 1, she got a 76, which is above 65. But on score 2, she got a 63, which is below 65. And remember, the AND function, both of the conditions have to be true in order to return the true value. So that's how we can combine the if and function together. Now let's take a look at another conditional function, which is the OR function. So let's see what Excel defines the OR function as. If I type in $, then OR, it says that OR checks whether any of the arguments are true and returns true or false. And then it says that it returns false only if all arguments are false. So with the AND function, both of the conditions had to be true in order to return a true value. But with the OR function, only one of the conditions has to be true to return a true value. So let's combine the OR function with the if function and see what we get. I'm going to delete this out and then come up to the formula bar and start typing in our formula. So we got to start with the $, and then if, open parentheses, and the first argument is asking for the logical test, and this is where we're going to place our OR function. So let's type in OR, and then open parentheses. So once again, we are going to be testing multiple conditions. So for the first condition, we are going to see if this person scored higher than a 65 for score 1. So we can click score 1 greater than 65 and then place a comma to test the second condition, which again is seeing if this person scored higher than a 65 on score 2. So we can put greater than 65. And since those are the only two conditions we are going to test, we can put close parentheses to close out our OR function and then put comma to get back into our if function. Now our if function is asking, what value do we want returned if just one of these conditions are true? So once again, we can put pass, surrounded by quotes, comma, and then fail if neither of these conditions are true. Then we can put close parentheses and click enter. So our formula returned pass because Corey got an 89 for score 1, which is higher than 65, and he got a 77 for score 2, which is higher than 65. So let's double click our fill handle and see what happens to these other results. Our formula returned pass for every person. So let's do a little investigating here. For Megan, she got a 76 on score 1, which is higher than 65, so that's true. But for score 2, she scored a 63, which is lower than 65. So why did our formula still return pass? Well, again, with the OR function, only one of the conditions has to be true in order to return a true value. So since the score 1 condition was true, it returned the true value. The same thing goes for Brittany. She has a failing score of 62, but then she also has a passing score of 81. And since one of these conditions are true, our formula produced the true value. But let's say for score 2, we change this 81 to a failing grade of 60, and if we click enter, now our formula return fail. And the reason why, because neither condition is true, so it returned the false value. So since neither one of these scores is above 65, our formula is going to return the false argument of fail. So that's how you can combine the OR function with the if function. Now for a quick recap, if you are combining the AND function with the if function, both of the conditions have to be true in order to return the true value. So if one of the conditions is false, it will return the false value. But if you are combining the OR function with the if function, only one of the conditions has to be true in order to return the true value. And if neither of the conditions are true, then it will produce the false value. Alright, so for the past few videos, we saw how we could combine the AND function or the OR function with the if function to test multiple conditions. Well, we could also combine multiple if functions together, so that way we can test further than just one scenario. For example, let's say that we want a formula that returns the value of a letter grade depending on that person's score. So for Corey, he got an 89, so for our grade, we want to return a B. And for Megan, she got a 76, so for the letter grade, we would want to return a C. So we can combine multiple if functions together to make this possible. So let's click inside the first cell within the grade column, and then come up to the formula bar to start typing in our formula. So we need to start off with the equal sign, and then use the if function. Open parentheses. So for our first logical test, we want to see if this person's score qualifies to get an A. So we can select Corey's score for the cell reference. And let's say to receive an A for your grade, your score has to be greater than or equal to 90. So we would put the greater than sign, then the equal sign, and then type in 90. So that's our first logical test, And then we can put a comma and put a value if this condition is true. So if the score is greater than or equal to 90, we would want this formula to return an A. So we can put open quotes, A, close quotes. And then we can put a comma to move into our false argument. So if this person's grade is not greater than or equal to 90, what do we want to return? Well, depending on that person's score, it can vary of what we want to return. Because if they have a score that gets them a B grade, we want to return a B. But if they have a score that has a C grade, we want our formula to return a C. So we can't just put one value for our false argument. So this is where we start to nest if formulas together. So for our false argument, all we have to do is start another if function. So we can put if, open parentheses, and then start this whole process over again, but this time we are going to test to see if this person's score gets them a B grade. So we can take the same cell reference of B3, then greater than or equal to, and since we are testing for a B grade, we can say that this person's score has to be greater than or equal to 80 to get a B. So we can put comma, and if this condition is true, we need to return the letter B. So that's basically how we can nest if functions together. But we need to do this for each letter grade, because we have A, B, C, D, and F. So really quickly, let's finish out this formula for each letter grade. So we need to put a comma for the false argument, and then type in another if function. Use the same cell reference. Now we are testing for a C grade, so we can put greater than or equal to anything above 70. We'll get this person a C, comma, another if function, same cell reference. And now we are testing for a D grade, so greater than equal to, so let's say anything above 65, but still below 70, will give us a D. And then for our last argument, how can we write this formula to return the value of a F grade? So let's say if a person scores anything lower than a 65, they will receive an F. Well, we could put another if function here and state that if B3 is less than or equal to 64, return F. But since we already have the values in place for A, B, C, and D, and if none of those conditions are met, we can just produce the false value of the letter F. And that's it. And all we have to do now is close our formula. And since that we have 4 different if functions nested together, we need to put 4 close parentheses. And Excel will automatically help you close these parentheses if you forget to put them on there. But now if we click enter, let's see what this formula will produce. So for Corey, he scored at 89, which is greater than or equal to 80, so he received the grade B. So let's copy this formula down for the rest of our cells and see what the formula returns for these different scores. So we can click in the cell with our formula in it and double click the fill handle. So for Megan, she scored a 76, which is greater than or equal to 70, so she received a C. And Ryan received an A because his score was greater than or equal to 90. Now remember, we didn't have to include another if function to return an F value. Because if the person didn't score anything greater than or equal to 65, they automatically receive an F. And that's what happened here with Brittany. She scored a 62, which is lower than a 65, so she received an F. So that's how we can combine or nest if functions together to test multiple conditions. And instead of just returning one value if the condition is true and one value if the condition is false, we can keep expanding the if function to return multiple values. Another conditional function that I want to introduce is the COUNTIF function. And it's very similar to the SUMIF function, but instead of summing, we are counting. And I do want to mention that the SUMIF function is a conditional function, but the reason why we used it earlier in the course is because when we were working with our data sets and using the dsum function, I just thought that the dsum function and the SUMIF function kind of went hand in hand. But for this video, we are going to be using the COUNTIF function to count the total amount of each letter grade within this range. So let's click in the first cell underneath the count column and insert our function. We can type the equal sign and then counts and find the COUNTIF and give it a double click. Now let's open up the function arguments window to see what Excel defines this COUNTIF function as. So the COUNTIF function counts the number of cells within a range that meet the given condition. So in order for this function to work, it only requires two arguments, the range and the criteria. So for our first argument is the range of cells from which you want to count non-blank cells. Well, the range of cells that we want our count function to look in is the grade column. And for our first cell in the count column, we want to count how many A's are within this range. So for our criteria, we can select grade A. And if we click OK, our function returns 4. Because if we look at our grade column, we can count there's 1A, 2, 3, and 4. So now let's fill this formula down the rest of our list and see what we get for the other grades. So we can give the fill handle a double click. And our formula counted 2 B's. So let's count the amount of B's in the grade column to make sure this is correct. We got 1, 2, oh, there's a third B down here. So why is our formula only producing 2? So let's click inside this cell and investigate. Well, if we look in our formula, now our range is C4 through C16, which is this range. So it's leaving out this B at the top. And the reason why our range shifted down one row is because we used a relative reference for our range. So when we copied this formula down, it also moved our range down. So to change this range to an absolute reference, we can highlight the range in our formula bar and then press F4 on your keyboard. Now we should have the dollar signs in there, symbolizing that this is now an absolute reference, and we can click enter. And now if we fill this formula down, we should get the correct answers. Give this fill handle a double click. Now our function returned 3 B's. So this is definitely something to keep in mind when you are creating or copying formulas throughout your spreadsheet. So this is how you use the COUNTIF function to count cells within a range that meet a certain criteria. Okay, so before we move on to the next section, I would like to discuss some of the key benefits of using named ranges. And earlier in the course, when we were applying Excel data validation to our worksheets and creating drop-down lists, we saw a little preview on how to create a named range. And then we were able to use that named range in our Excel data validation. But I also want to show you is how we can use named ranges within our formulas. So let's select the first cell underneath the count column that contains our COUNTIF function that we created in the last video. Well, if we take a look at our formula, it says COUNTIF C3 through C15, which is our range, and then our criteria is E3, which is our letter grade. Well, instead of using C3 through C15, we can define a name for this range, and it will make our formulas easier to read and understand which data that this function is using. So to create a named range, we first have to select the range that we want to define a name for. So since we are trying to replace C3 through C15, we can select the grade column. And to give this range a name, we could come up to the name box and start typing in a name. Or we can go to the Formulas tab and select Define Name. And we can name this range Grades. And we can tell that it refers to C3 through C15. And if we click OK, now if we go back to the cell that contains our COUNTIF function, so if we come up to our formula and delete this range and then start typing in grades, our named range automatically pops up and we can give this a double click. And we can see that it selected our range, and now this formula is a lot easier to read. So instead of having column letters and row numbers, we can see that this function is using our grades range. Click enter. So if we double click this fill handle, now every one of our formulas is referencing the grades named range. And one of the great things about named ranges is that if we add a new row that's within our named range, our range will automatically update. For example, if I come between Kate and Grace and add a new row, and let's say that John scored at 85, he would get a B for his grade, and within our count column, instead of counting 3 B's, it has now counted 4. And if we come up to our Formulas tab and then click on Name Manager, we can see that our grades named range is now referencing from cells C3 to C16 instead of C15 because we added one more row within this range. And if you ever needed to change the range of cells within this name range, we can clear this box and then highlight a different range of cells. Here I just selected the same range because that's what our count function is referring to. So we can close out of this and click yes. And that's how you use name ranges inside of your formulas. Okay, so for this section, we are going to be looking over a few different Excel lookup functions. And lookup functions help us find certain values within our data set. So the first lookup function that we are going to discuss is the VLOOKUP function. Now the VLOOKUP function is one of the most popular functions used in Excel. And the best way to demonstrate what this function does is to apply it to our example and then explain what the function is doing along the way. So before we begin, I want to point out that we will be working inside the VLOOKUP Sheet tab, so make sure you have this sheet selected. And for our example, our goal is to be able to search by student ID number and then have the VLOOKUP function return the name and the score associated to that ID number. So let's try to retrieve the name of a student ID first. We can click in the cell next to name, and then also I'm going to zoom in into our sheet a little bit. Alright, so to insert our function, we need to type in the equal sign, and then start typing VLOOKUP. And then you can select Tab on your keyboard to insert this function. So let's open up the function arguments window and see what Excel defines this function as and what arguments is needed for this function to work. So let's click this FX button next to our formula bar. And we can read here that the VLOOKUP function looks for a value in the leftmost column of a table, and then returns a value in the same row from a column you specify. So for our first argument is the lookup value, which is the value to be found in the first column of the table. So for our lookup value, it will be the ID number that we put in this cell, G2. And this value can be found in the leftmost column of the table. And this is a super important piece of information, because if your lookup value is not in the first column of the table, this function will not work properly. And I also want to mention that the V in VLOOKUP stands for vertical lookup. So it's looking at the top of our list down to the bottom of our list. And then for our next argument is the table array, which is a table of text, numbers, or logical values in which the data is retrieved. So we need to specify the range of cells that our value lives within. So for our table array, we can select our whole table. Now currently this range is A1 to D14. But if this range of cells was a table, or we defined a name for this range, we can use the table name or the name range for our table array. But since our list is not converted into a table and we didn't define a name for it, we will just stick with A1 to D14. And for our third argument is the column index number, which is the column number in the table array from which the matching value should be returned. Okay, so for this function, what we are trying to achieve is to search for an ID number and return the name associated to that ID. And our name column is the second column within our list. We have 1, 2. So for our column index number, we would need to type in 2. And then for our last argument, the range lookup, we have a few different options. We can either find the closest match in the first column or find an exact match. Now usually when you're dealing with VLOOKUP functions, you want to find an exact match. And down here it says that we could put false to find an exact match, or you can type in 0, which equals false. You can do either one. I just like typing in 0 because it's quicker and the formula is a little bit shorter. So if we click OK, currently we are getting ANA. Now this might look like an error, but it's really not. It's just that this function is not finding anything because we haven't specified an ID number. So if we type in an ID number, our VLOOKUP function should return the name of that ID. So if we type in 110, our function returns Corey. Because over here in our list, if we search for the ID number of 110, we can see the name associated to this ID is Corey. And then if we come back over here and change the ID to 117, we get Jake. If we come back to our list, search for 117, the name is Jake for that ID. So let's use this VLOOKUP function to return the score as well. Now I want to be able to just copy this formula down a row. But before we do that, we need to make sure that within our formula, we are using the correct cell references. So if we come up to our formula bar, we have G2 as our lookup value. Now that lookup value will always remain the same. So we need to make this cell reference an absolute value. So we can press F4 on our keyboard to make it absolute, so that when we copy this formula down, our lookup value still remains in the ID cell. We also need to make our table array an absolute reference, because our range will not change when we are copying this formula down. So we can press F4 again and click enter. So now if we come to our cell and drag the fill handle down, well, we are still getting Jake for our score. Well, that's because we haven't changed the column index number yet. So for score, that's in the third column of our list, 1, 2, 3. So what we need to do is come up to our formula bar and edit this 2 to a 3. And if we click enter, now for the ID number of 117, we have the name Jake, and then we can see that his score was 74. And if we come over to our list, 117 is Jake, and he scored a 74. Now there is one more thing about the VLOOKUP function that I want to point out, is that the VLOOKUP function always returns the first match. And let me show you what I mean by that. So if I add a row between Trevor and Kate, and Trevor has an ID number of 114. Well, if I put in another ID number of 114, and let's say this person is John, and he scored an 85, if I come up to the ID cell and search for 114, let's see what our function returns. It returned Trevor, and he scored a 90. So even though that Trevor and John both share the same ID number, the VLOOKUP function will always return the first match. So when you are working inside your spreadsheets and using this function, it's always a good idea to make sure that your table doesn't have any duplicated values, or you can sort your table and double check that what your VLOOKUP function is returning is the correct value that you want. And remember that your lookup value always has to be in the leftmost column of your table. So if we move this ID column around in our table, our VLOOKUP function would not work. So that's how you use the VLOOKUP function. It's one of Excel's most powerful functions, and it gets used every day. Alright, currently we have our VLOOKUP function in our name cell and our score cell. And it returns the name and the score associated to this ID number. So let's say that we put in an ID number that doesn't exist in our list. For example, if I put 125 and click enter, now our VLOOKUP formulas are returning NA. Now you might be thinking that there's something wrong with your formula. But there's actually nothing wrong with the formula. It's just that it can't find 125 within our ID column. So to handle these types of errors, we can expand our VLOOKUP formula to make this error more descriptive. So if our VLOOKUP formula can't find an ID, instead of returning NA, we can tell it to return a different value. And to do that, we can combine the VLOOKUP formula with another conditional function called the ifError function. So if we come up to our formula bar, and at the beginning of our formula, we can type in ifError and press tab to insert this function. Now the ifError function requires two arguments, which is the value, and then another value if the value is an error. So currently, in our values argument, we have our VLOOKUP function. And we know that this value returns the name. But if we come to the end of the VLOOKUP function and type in comma. Now our value if error is bold within our if error function. And here's where we can return a different value if our VLOOKUP formula produces an error. And for this argument, we could either put a cell reference or a text value. So for this example, we can put open quotes and say ID not found, close quotes. And then we can put close parentheses to close the if error function. Now if we click enter, let's see what our formula produces. So instead of our VLOOKUP function returning NA, with combining it with the if error function, now it says ID not found. Now this is a lot more descriptive than just NA, because one, it actually tells us what the error means, and it makes our spreadsheet look a lot nicer because it doesn't have actual errors in them, and possibly making users think there's something wrong with the formulas when there's really not. So let's click the name cell, drag our fill handle down, and then make sure for the score cell, we change the column index in our VLOOKUP function back to 3. And we can click enter. So now when we put in an ID number that doesn't exist, our formulas are returning more descriptive values. And if we change our ID to a number that exists in our list, let's say 115, now our formulas are returning values associated to that ID number. Okay, so another lookup function that we will be going over is the HLOOKUP function. And the H is short for horizontal. So it's very similar to the VLOOKUP, but instead of searching vertically, we will be searching horizontally. So depending on how your data is set up, can decide on which lookup function you need to use. And before we begin, I want to point out that we will be working inside the HLOOKUP sheet tab. So make sure you have this sheet selected. So let's take a look at our example and see how our data is set up. We have the course numbers in our column headings, and then we have the weekdays that this course is available in our row labels. And then we have the amount of students that are in each class. So our goal is to be able to search by the course number and then return the amount of students in that class for Monday, Wednesday, and Friday. And since that our lookup value is the course number, we have to use the HLOOKUP function because our course numbers are laid out horizontally in our table. So let's insert the HLOOKUP function in our Monday cell by typing in the equal sign and then HLOOKUP. Press the tab on your keyboard to insert the function. And then let's open up our function arguments window and see how the HLOOKUP compares to the VLOOKUP. We can press the FX button at the top of our formula bar, and we can read here that the HLOOKUP looks for a value in the top row of a table and returns the value in the same column from a row you specify. Let me cancel out of this really quick. And so before with the VLOOKUP function, we were searching our list vertically. Then we specified a column number to retrieve a value. But this time around, it's going to be in reverse. The HLOOKUP function will search horizontally first, and then we are going to specify a row number to return a value. So let's go back into our Monday cell, insert our function, open up our function arguments window, and once again, our first argument is the lookup value, which is the value that can be found in the first row of our table. So we can select cell C8 because we will be searching by the course number. And then for our second argument is the table array again. So for this, we can just select our whole table. Now instead of a column index number, we are specifying a row index number, which is the row number in the table from which the matching value should be returned. So for this formula, we are trying to return the amount of students that are in Calc 101 for the Monday class. And Monday up in our table is the second row, 1, 2. So for this argument, we need to type in 2. And then for the range lookup, we are specifying if we want to find the closest match or an exact match. So let's put a 0 in here to find an exact match. And then also, I'm going to make these cell references absolute references, so when we copy down our formula, our lookup value and our table range will remain constant. And if we click OK, our formula returns 50. And if we come up to our table, look at Calc 101 for Monday, there are 50 students. So now let's copy down our formula for the rest of our list. And the reason why our formula is returning 50 for each day is because we haven't changed the row number yet. So for Wednesday, instead of the row index number being 2, we need to change this to 3. Because Wednesday is in the third row, 1, 2, 3. And if we click enter, now we have 45 students in Calc 1 for Wednesday. And then for Friday, we can change the row index number to 4, because Friday is in the fourth row of our table. 1, 2, 3, 4. Click enter. Now our HLOOKUP function is returning the amount of students that are in Calc 101 for each day. And if we change our lookup value to Econ 101, I created a drop-down list for this example to make this a little bit more dynamic. But if we choose Econ 101, now our formula returns the amount of students in this course. We got 100 for Monday, 125 for Wednesday, and 75 for Friday, which are the same values that are up here. So that's how you use the HLOOKUP function. And once again, depending on how your data is set up, will decide on which lookup function that you need to use. I personally use the VLOOKUP function way more often than the HLOOKUP because usually data sets are set up vertically, so we would need to use the VLOOKUP function. But the HLOOKUP function is still important to know how to use, just in case you need to search your data horizontally rather than vertically. Although the VLOOKUP and the HLOOKUP are very powerful functions within Excel, they do come with some limitations. For example, within the VLOOKUP and HLOOKUP functions, we had to specify the column number or the row number to return a matching value. But let's say in our list, we add a column or delete a column. Then we would have to go back inside our formula and change the column index number. Same thing goes for if we add or delete a row. Another limitation to the VLOOKUP is that it can only look up values in the leftmost column. But we can overcome these limitations by combining two different functions, which is the index function and the match function. And you may or may not have heard of this already, but when we combine these two functions, we can look up and return matching values within our list using index and match. And what it basically does is combine the VLOOKUP with the HLOOKUP, because the index and match combined can search vertically and horizontally. So it overcomes a lot of these limitations that the VLOOKUP and HLOOKUP have. Now before we jump in and combine the index and match functions, it's important to know what the index function does and then what the match function does. So when we combine the two, we know what values that these functions are retrieving. So for this video, we will be going over the index function. And I also want to point out that we will be working inside the Index and Match Sheet tab. So make sure you have this sheet selected. So let's click inside the name cell underneath Index and insert the index function and see what Excel defines this function as. So we can type in the equal sign, then index. Then we can press tab on our keyboard to insert the function. And if we open up our function arguments window, now this window is just saying that the index function has multiple argument lists. We can just select the array, row num, and column num. Click OK. And it says here that the index function returns a value or reference of a cell at the intersection of a particular row and column in a given range. So let's start to fill out these arguments to get a better understanding of what this function does. So for our array argument, we can just select our entire range. Now for our row num and column num arguments, this is where we tell the index function the intersection of a particular row and column. So just for example, let's put 4 for the row number. And then for the column number, let's put 2. And if we click OK, let's see what our index function returns. So our formula produced Ryan. But why? Well, the intersection that we specified was the 4th row and 2nd column. So if we come over to our list and we go down 4 rows, 1, 2, 3, 4, and then for our column number, we specified 2. So 1, 2, and there's Ryan. So this is the row and column intersection that we specified. And if we go back up to our formula bar and change the row to 6, and then change the column to 3, click enter, we get 90. Well, if we come back to our list, count down 6 rows, 1, 2, 3, 4, 5, 6, and then in the 3rd column, 1, 2, 3 is 90. So that's how the index function works. And to summarize, the index function returns a value at a given location in a range of cells based on numeric positions, meaning that we had to use numeric values for the row number and the column number to specify the location of a cell and return that value that's within that cell. Alright, so we saw how the index function works. Now let's take a look at what the match function does. And over here in our example, our goal is to specify an ID number and have the match function return the position of that ID number. So next to the position cell, this is where we'll be inserting our match function. So we can type in equals, then match. Tab key to insert the function. And then let's open up our function arguments window to see what Excel defines this function as. We can click the FX button, and it says that the match function returns the relative position of an item in an array that matches a specified value in a specified order. Now sometimes these definitions can be a little bit confusing, so the best way to learn these functions is to apply them. So for our lookup value, we can select the cell that we are going to put our ID number in, which is cell J2. Now for our lookup array, which is a contiguous range of cells containing possible lookup values. So within the match function, this array can only be a single row or a single column. So the range of cells containing possible matches is our ID column, because our lookup value is the ID number. So let's select our ID column. And then for our match type, it accepts the number 1, 0, or -1. Well, if you're not really sure what these numbers mean, we can select Help on this function to open up the Microsoft support page for this function. And if we scroll down to the syntax, we can see that 1 finds the largest value that is less than or equal to the lookup value, and -1 finds the smallest value that's greater than or equal to the lookup value. But for our case, we need to put 0 to find the exact match of our lookup value. So let's go back into our Excel workbook and put 0 for the match type. Click OK. And the reason why our formula is producing NA is because we haven't specified an ID number yet. So we can click in this cell and let's put 114. So for our match function, it returned 6. So why is that? Well, if we go to our ID column and count down until we find our ID number, so 1, 2, 3, 4, 5, 6, our ID number is in the 6th position of this range. So instead of returning the value of the cell, like what the index function did, instead it returned the position of our ID number. And the match function can look vertically or horizontally. For example, if I copy our ID column, and if I select another cell, give it a right click, and then for our paste options, I can select transpose to paste it horizontally. Now if I go back to our match function and change this range from A1 through A14 to A17 to N17, click enter. For the ID number of 114, the match function is still returning the 6th position. Because if we count left to right, 1, 2, 3, 4, 5, 6, 114 is still in the 6th position. So as long as your range in your match function is a single column or row, it can search vertically or horizontally. I'm going to undo those actions. So that's how the match function works. And to summarize, the index function returns a value and the match function returns a position. And the reason why I wanted to show you these two functions separately before combining them is so we have a good foundation of what these functions do, and it can help us understand how our formula is calculating when we put these two functions together. Alright, so now that we know how the index function works and how the match function works, it's time to combine these two together. And the biggest benefit of combining these two functions is to mimic the VLOOKUP function without your lookup value being in the leftmost column. So similar to our example when we use the VLOOKUP function, we are going to combine the index and match to look up an ID number and return the name, score, and grade associated to that ID number. So let's click in the cell next to name and start building our formula. So we need to start with the equal sign, and the first function that we are going to use is the index function. Now the first argument within the index function is the array, and the array is the entire table. So when you see index, just think of selecting your entire table. I'm going to make this range an absolute reference by clicking F4 on my keyboard, and then comma to move on to our next argument. So now our index function is asking for the row number. Well, we're not actually going to know which row number that the ID that we're searching for is going to be in. So this is where we can include the match function. Because remember, the match function returns a numeric position, and the index function uses those numeric positions to return a value. So for our first argument in our match function, we need to select the lookup value, which is the ID cell. Then let's make this an absolute reference because this lookup value is going to remain constant. Then put a comma. Now the second argument for the match function is the lookup array. And remember, for the match function, the lookup array can only be a single column or a single row. So we want to tell this function to look for the ID number within the ID column. And then we can also make this an absolute reference. Then insert a comma. And for the match type, we want an exact match, so we can put in a 0. So that's the end of the match function. So we can put in close parentheses. And now we're back in the index function. And it's asking for the column number that our value is in that we want returned. So since we are trying to return the name associated to this ID number, we can put 2, because the name column is the second column within our table. And then we can put close parentheses. And if we click enter, and then search for an ID number, we can select 119, and our formula return Jack, because in our list, Jack is associated to 119. So now let's copy this formula down to retrieve the score and grade for this ID number. So if we click our cell that contains our formula, drag down our fill handle, what we need to do now is go into these formulas and change the column number. So for score, we need to change the column number of 2 to a 3. And then for grade, we need to change it to a 4, because the grade column is the 4th column in our table. Click enter. So now we're able to see that for the ID number of 119, the student's name is Jack, he scored a 95 and received an A. And if we change this ID number, the formulas will update. So like I said before, the reason to use the index and match functions combined, because it overcomes the limitation of the VLOOKUP function that requires our lookup value to be in the leftmost column. And this is just the beginning of the potential of the index and match function. In the next video, I will show you how we can edit this formula and show how we can make this formula more dynamic so we don't have to come into each cell and change the column number. So in the previous video, we learned how we could combine the index function and the match function together to mimic the VLOOKUP function, but allowing us to overcome the limitation of the VLOOKUP function of requiring our lookup value being in the leftmost column of our table. Because currently in this index and match formula that we created last video, this formula would still work if we changed the ID column to the 2nd, 3rd, or 4th column. But to retrieve the name, score, and grade using the index and match, we still manually had to go into each of these formulas and change the column number. Well, luckily, we can edit this formula to include another match function to make our column num argument dynamic. And usually when you're dealing with data sets, you might be inclined to move columns around. And if you just use the VLOOKUP function or use the regular index and match formula, we would have to come back into each cell and edit the formula. So to overcome that, we can use another match function to return a numeric value for the column number argument within the index function. So let's start editing this formula so you can get a better understanding. So we need to delete this 2, and still within our column number argument for our index function, we need to insert another match function. And for our lookup value for this match function, we are going to select the cell that says name. Because for this formula, we are trying to return the name associated to this ID number. And we already have the ID number as the lookup value for our first match. But what our second match is doing is trying to match and locate our column headings within our table. So for our lookup array, we can put comma, we can select our column headings within our table to match our name label over here. And I'm going to press F4 on my keyboard to make this range an absolute reference, since our column labels are going to remain constant, and then put comma 0 for an exact match. Then we can click enter, and Excel is saying that there's a typo in my formula, and it's just because I left out one last parentheses. So do you want to accept this correction? Yes, I do. So now in this formula, we have an index function and two match functions. So now if I copy this formula down the rest of our cells, we are still getting all the correct values without having to go in and change the column number. So if I change this ID number to 118, we can see that this ID refers to the name of Colby. He scored a 67 and received a D, which is right here in our table. So with combining all these functions together, we overcame the limitation of having the lookup value being in the most left column, and we didn't have to change our column number for our name, score, and grade. Because you can see in our second match formula, the lookup value is L5, which is grade. And then for our score formula, it is L4 for our score, and it's matching our column headers within our table to produce the column number. So I know this formula is a little bit more confusing, but it's very important to learn because it's a lot more efficient and dynamic if we make changes to our table. Alright, so for this section of the course, we will be going over multiple text functions within Excel. I know we use Excel mostly for numeric data, but being able to manipulate strings of text can be very useful for extracting only certain parts of the string for reporting purposes. And before we begin, I do want to point out that we will be working within the Text Functions Sheet tab. So make sure you have this sheet selected. So to start off, we will be working with this top example up here. And over here to our left, we have different SKU numbers. Now within these SKU numbers, each part of the SKU means something. For this example, let's say that the first two letters within every SKU symbolizes the brand name. And then it's followed by three numbers, which tells us the part number for this product. And then the last three characters tells us the type. And this is the same for every SKU. The first two letters are the brand, then the three numbers is the part number, and then the last three characters are the type. So our goal over here is to extract only the characters for the brand, the part number, and the type by using Excel's text-based functions. So first, let's extract the characters for the brand. Well, to do that, we need to use the left function because the brand is on the left side of our string of text. So let's type in the equal sign and insert left. And then let's open up our function arguments window to see which arguments are required for this function. So let's click the FX button here at the top next to our formula bar. And we can read that the left function returns the specified number of characters from the start of a text string. And for our first argument, it's the text string containing the characters you want to extract. So our goal is to extract BA from this string of text. So we can select cell B3 for our text argument, and then for our next argument, we are now specifying how many characters you want left to extract. So if we are trying to extract 2 characters from the left, we can put 2. And we can see here that our result is BA. We can click OK. Now we have extracted the first 2 characters of that string of text. And to do this for the rest of the SKUs, we can just come up here and then click and drag our fill handle down for the rest of the cells. Now we have the first 2 characters of each SKU. So now let's try to extract the other parts of these SKUs. Let's skip part number for now and move on to type. Now remember, for the type, it's the last 3 characters within the SKU. So for this first SKU, KTL would be the type. So to extract the ending characters of a string of text, we need to use the write function. Once you have the function inserted, let's open up our function arguments window. And we can see here that the write function returns the specified number of characters from the end of a text string. So once again, our first argument is just selecting the text that we want to extract from, which is cell B3. And then for our second argument, we are specifying how many characters we want to extract from the end of this text string. So we are trying to extract the last 3 characters of this SKU, which is KTL. So for this argument, we can put 3. Click OK. Then click and drag our fill handle down the rest of our cells. Now we can see that our write function extracted the last 3 characters of each SKU. Alright, so we extracted the brand characters using the left function, and then we extracted the type characters using the right function. Now to retrieve the part number, which is in the middle of this string of text, we need to use the mid function. So we can type in equals mid, and then let's open up our function arguments window to see what this function does. So the mid function returns the characters from the middle of a text string, given a starting position and length. So once again, our first argument is just selecting the string of text that we want to extract from, which is cell B3. Now for our start number argument is the position of the first character you want to extract. So our goal is to extract this number 154. And the starting position of this number is 1, 2, 3, because it's the third character within our string of text. So we would want to put 3 for our start number argument. And then for our number of characters argument, specifies how many characters to return from text. Well, we have our starting position, which is the third character, 1, 2, 3. So it starts on the 1. And then we need to specify how many characters we want to extract from this starting position. We are just trying to extract these 3 numbers, so 1, 2, 3. So we can put 3 for our number of characters argument as well. Then we can click OK. And then we can see that our mid function extracted those 3 characters within the middle of our text. And if we click and drag our fill handle down, we can see that it extracted the part number for each SKU. One thing to keep in mind is that these functions are working consistently only because our SKU numbers are consistent, meaning that they all start with the 2 first characters for the brand name, and then the next 3 characters is the part number, and the last 3 characters are the type. Alright, so in the previous video, we learned how to use the left, mid, and right functions. And using these functions worked out pretty well for our SKU numbers up here in our top example, because all of our SKU numbers had the same format. The first 2 characters symbolized the brand name, the next 3 characters were the part number, and the last 3 were the type. But sometimes you might not get so lucky. For example, if we take a look at the SKU numbers down below, the first SKU has 2 characters before a dash, and then 6 characters after the dash. And then this SKU has 7 characters after the dash, and the last one only has 1 character before the dash. So we can see that all these SKU numbers are a little bit different. And let's say that we want to extract all the characters before the dash, then all the characters after the dash. Well, for our first SKU, we could use the left function and only extract the first 2 characters. And then we could use the right function to extract the last 6 characters. But for our second SKU, we would have to change the left function to extract 3 characters. And then down here, we would have to change it again back to 2. And then for our right function, we would have to change it to 7. So if we used the left and right functions for this example, it wouldn't be very efficient. Because if we had thousands of different SKUs, we would have to change and edit the formula for each one. But luckily, we can combine the left and right functions with the len and search functions to automatically extract all the characters before the dash and then all the characters after the dash, regardless of how many characters are before or after the dash. So to start off, let's figure out what the len and search function do. So just to the right of the table, I'm going to make some dummy columns to help us understand what these functions do. So let's start with the len function. So in this cell, we can type in the equal sign and then len. And we can see right here that the len function returns the number of characters in a text string. So if we insert this function and then select our first SKU number, close parentheses, press enter, our function returns 9. And if we count the number of characters within our first SKU, we should get 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So all what the len function does is return the number of characters within a string of text. And then we can drag this formula down the rest of our cells. And we can see that some SKUs have 9 characters and others have 10 or 8 characters. Alright, so now let's introduce the search function. So I'm going to make another dummy column, title it search, and what we will be searching for is the dash within the SKU numbers. So let's insert the search function by typing in equal sign, then search. And we can read that the search function returns the number of the character at which a specific character or text string is first found, reading left or right. So basically, we are going to be searching for the dash, and the search function will return the position of where the dash is within that SKU number. So once we have the function inserted, the first argument is telling this function which character to find within a specific text. So we are searching for the dash. So what we need to do is put open quotes, dash, close quotes, because that's the character that we want to find. And then we can put comma, and the second argument is within what text. Well, we can just select our first SKU number. And then we can put close parentheses and click enter. And our search function returned 3 because if we look at our SKU, the dash is found in the third position of this string of text. 1, 2, 3. And then if we fill this formula down, we can see that our second SKU, the dash is found in the fourth position. 1, 2, 3, 4. Or for our last one is 2. 1, 2. So we have the len function just returning the total amount of characters within a string of text. And then we have the search function that finds the dash within our string of text and then returns the position of that dash. So now it's time to combine the left and right functions with the len and search functions to get the text before the dash and then get the text after the dash. So let's do before the dash first. So we can click in the first cell and then start to insert our formula. So let's think about this. We need to get the first characters of a string of text, but before the dash. Well, we know if we want to get the first characters of a string of text, we need to use the left function. So that's what we are going to start with. So we can type in $, then left. And then we can select the text that we want to extract from, which is our first skew, comma, and then we need to specify the number of characters that we want to extract. Well, for this first skew, we want to extract 2 characters, just to get the BA before the dash. But we can't just put 2, because the next skew has 3. So we need our formula to adjust accordingly. So what do we need to do here? Well, we know by using the search function, we can locate the position of the dash. And for the first skew, the dash is the 3rd character of this string of text. Well, for our formula, we can insert the search function to specify the number of characters that we want to extract from the left. So we can type in search, open parentheses, and then for our first argument, we need to specify the character that we want to search for, which is the dash. So we can put open quotes, dash, close quotes, then comma, and then we can select our first skew because that's the string of text that we want to search. Then we can put close parentheses to close the search function, and then we can close parentheses for the left function. And then let's click enter to see what we get. Well, we got BA dash and not just BA. Well, that's because within our formula, we are using the left function and telling it to extract 3 characters from the left, which is right down here. But we only want to extract 2 characters. Well, since we know that this part of our formula is 3, we can just go to the end of the search function and type -1, because 3 minus 1 is 2. And if we click enter, now we are just getting BA. And then if we copy this formula down the rest of our cells, you can see that the formula is only extracting the characters before the dash. Because for our second skew, we know that this part of our formula equals 4. And 4 minus 1 is 3, which gets us the first 3 characters of our string of text. Now let's see how we can extract all the characters after the dash. So let's click in our first cell, and we know that we can use the right function to extract a certain amount of characters at the end of a string of text. So for this formula, we have to start with the right function. And for our first argument, we need to select the text that we are going to extract from, which is our first skew, comma. Now we need to think about how are we going to extract all the characters after the dash. Well, for our first skew, we have 6 characters after the dash. And then our second skew only has 5 characters. Well, we can't just use the search function like we did when we extracted the characters before the dash, because for our first example, if we search for the dash here, our formula would produce KTL. Because since we are searching for the dash, we would be specifying to extract 3 characters from the right, which is KTL. And that's not what we want. We want to extract these 6 characters after the dash. Well, if we look at our dummy columns, how can we get 6 from these 2 functions? Well, 9 minus 3 is 6. And then for our second skew, we need to get 5 characters. And if we look in our dummy column again, 9 minus 4 is 5. So to specify the number of characters that we want to extract from the right, we need to combine the len and search function. So up in our formula, we can type in len, open parentheses, select our SKU to get the total amount of characters within this cell, which is 9, then close parentheses. And then we need to subtract the search function from the len function to get 6. So up in our formula, we can put minus, and then insert the search function, open parentheses. Then we need to specify what to search for, which is the dash. So open quotes, dash, close quotes, comma. And then we can select our first SKU because that's the text that we want to search in. Then close parentheses to close out the search function. And then close parentheses again to close out the right function. And if we click enter, we get the last 6 characters of this string of text. And if we copy this formula down, we can see that for our second SKU, we only extracted 5 characters from the right because 9 minus 4 is 5. And then for our fourth SKU, we extracted 7 characters from the right because 10 minus 3 is 7. So even though that our SKUs have different total amounts of characters before the dash and then different amounts after the dash, we can combine the len and search function with the right and left function to make our formula automatically adjust to how many characters to extract. And this is a lot more efficient than just using the left and right function alone and then editing the formula to extract a certain amount of characters for each SKU. So for this video, I will be showing how we can use the concatenate function to combine 2 separate strings of text together. And for this example, we will be working in the concatenate sheet tab, so make sure you have this sheet selected. So our goal within the concatenate column is to combine the first name and the last name into one cell. So we can click inside this cell and type in equals concatenate. And we can read here that this function joins several text strings into one text string. So if we insert this function, and then all we have to do is select the cells that contain the strings that we want to combine. So we want to combine the first name, comma, and then for our second argument, we can select our second cell, B2. And then we can close parentheses. So we are combining cell A2, Kelly, with B2, Adams. And if we click enter, our function returns Kelly, Adams, and one cell. Well, currently, there is no space between Kelly and Adams. And if we want the first name and last name separated by a space, we can go back to this formula, and instead of having our last name being the second argument within our formula, we can add a new argument between the first name and last name. So up here in our formula, right after the first comma, we can type in open quotes, then hit the spacebar on your keyboard, then close quotes, and then comma, and now B2 is our third argument for our last name. So now our formula is reading A2, which is the first name, then space, and then B2, which is the last name. And if we click enter, now we have a space between the first name and the last name. And then we can fill this formula down to make sure it works for the rest of the cells, and everything looks good. Now another way to combine values from different cells is using the ampersand sign. Let me show you. If we click the first cell underneath our heading column, and let's make this cell say, Kelly Adams, please register by this date. And to do that, we can start off by typing in the equal sign. Then we can select D2, because we are starting with the name Kelly Adams. Now instead of using concatenate, we can just type in the ampersand sign, and then open quotes, and then a space to separate the strings of text, and then we can type in please register by, and then another space, close quotes, and now we are trying to combine the date at the end of this sentence. So whenever you're combining, you have to use the ampersand sign, and then we can select the date. And if we click enter, we get Kelly Adams, please register by 44/140. Well, that doesn't look like the date value, but remember in Excel, date values are stored as numeric values. So this is actually a good time to introduce the text function. And let me show you what that does. If we come back to our formula, and right before C2, we can insert the text function. And we can see that the text function converts a value to text in a specific number format. So for this case, we are going to take our date value, convert it to text, but we can specify the number format that we want this value converted to. So let's see what our arguments are. If we put open parentheses, for our first argument is the value that we want to convert, which is the date, cell C2. So that's already in there. Then after that, we can put a comma. Now we can specify how we want this text formatted. So let's say that we want this date value to show as a 3-letter month, and then a 2-digit day and a 4-digit year. Well, what we need to do is put open quotes, then MMM for month, comma, DD for day, space, YYYY for the year, then close quotes, and then close parentheses. Now if we click enter, our cell says, Kelly Adams, please register by November 5th of 2020. So you can combine text values with date values by using the concatenate function or putting in the ampersand signs, and then using the text function to convert our date values to text. And then if we fill this formula down, now we get the full name of each person and the date that they have to register by. And this can be a great tool to use because let's say in our heading column, we will use this combined value for the subject line in emails. Or you can use the concatenate function for any other purpose you may have. But it's definitely important to know how to use, just in case you run into a scenario where you have to take multiple values from different cells and combine them together to get them in one cell. Alright, so before we move on to the next section, I want to take the time to discuss some quick tips and other text-based functions that are helpful to know how to use. And I provided some examples that you might run into often. And we will be working inside the Text Tips sheet tab, so make sure you have this sheet selected. So for the first example, I'm going to show you how you can keep leading zeros when you insert a number into Excel. Let's say that you want to create some invoice numbers, and every invoice number is formatted with 6 digits. So for your first invoice, you would want to put 000-001. If we click enter, Excel automatically deletes the leading zeros. So to keep those leading zeros, we have a few options. Let me create a few invoice numbers. So I'm going to put 2, then 3, then I'm going to select these cells, then drag the fill handle down, and Excel's catching the pattern that I want to increase these numbers by 1. So now I have 1 through 10, and then in the next column, we can insert the text function. And we saw in the last video that by using the text function, we can convert a value into text, but in a specific number format. So if we type in equals text, open parentheses, The value that we want to convert is this cell right here, A2, comma. And for our number format, we want our invoice numbers to be 6 digits and keep the leading zeros if there are any. So for the number format, we can put open quotes and then type in 6 zeros, 1, 2, 3, 4, 5, 6, then close quotes and then close parentheses. And if we click enter, now our formatted invoice number shows 5 zeros and then 1. And if we fill this formula down, now all of our invoice numbers are formatted correctly. Now creating this formatted column is great because we're not messing with the original data. But if for some reason you can't use the text function or don't want to, we can just apply a custom format to our invoice number column. For example, if we select these cells, come up to the Home tab, and then within the number group, we can select this dropdown, click on More Number Formats, go to Custom, and then in this box, we can type in the 6 zeros. And if we click OK, now our invoice number column is formatted correctly and put in those leading zeros. Now I want to show you another thing that you might come across that you can fix using text-based functions. For example, we have this name, score, and grade set up like you've seen before. And then over here, I have a VLOOKUP function that searches for the name and then returns the score. So up here in the name cell, if I type in Corey, we can see that his score was an 89. But now if I type in Trevor, it says that the name is not found. But over here in our name column, Trevor's right there. So why is the VLOOKUP function not returning 90? Well, if we take a look at this cell, it looks like the name is spelled correctly, but if we double click, we can see that there's a trailing space within this cell. And since that we typed in Trevor up here without the space, the VLOOKUP function is not finding a perfect match. So sometimes what I like to do, especially if I'm importing a text file from a different source, because sometimes text files come in weird from other applications, I like to make another column and trim all the leading or trailing spaces within these cells. So for example, if I insert a column between name and score, I'll title this trim. And to trim all the leading or trailing spaces, we can use the trim function. So if I type in equals, then trim, it says that it removes all the spaces from a text string except for single spaces between the words. So it's only removing the spaces at the beginning of the string or at the end of the string. So if I put open parentheses, select this text, close parentheses, then click enter, then fill this formula down the rest of our cells. Now if we go to Trevor in this column, there shouldn't be a trailing space. So if I come back to the VLOOKUP function and change my table array so it's looking at the first column, click enter. Now my VLOOKUP function is finding an exact match of Trevor. So that's how you can use text-based functions to get your cells formatted correctly. So for this video, I'm going to be talking about how you can audit an Excel spreadsheet. And before we get into the details of auditing an Excel spreadsheet, I do want to point out that we will be working inside the Cells 2018 Sheet tab. So make sure you have this sheet selected. So sometimes when someone sends you a spreadsheet, either a colleague or a coworker, it might be hard to understand how the spreadsheet is functioning. Since you didn't create the spreadsheet yourself, at first glance, it's hard to know which cells have formulas in them, and then it's hard to know which cells affect those formulas. But with formula auditing, Excel allows us to display these relationships between formulas and their cells. So if we come up to the Formulas tab, and within the Formula Auditing group, the two options I want to discuss first are Trace Precedence and then Trace Dependence. Now, Trace Precedence shows arrows that indicate which cells affect the value of the currently selected cell. For example, if I click this total here in cell G3 and then select Trace Precedence, this dark blue arrow starting from quarter 1 all the way to the total signifies that each one of these cells affect the value of this cell, because in this cell we have a formula that includes these cells. And to remove this arrow, we can click Remove Arrows. Now if we want to see which cells affect this percent of total cell, we can select this cell and then Trace Precedence. Now we have a thin blue arrow for this total, and then another blue arrow from the grand total to this cell. Because to get the percent of total, we have a formula in this cell that takes the total of the north division and divides it by the grand total. Now for a little bit more complicated one. If we remove these arrows and then click in this bonus cell and then trace the precedence for this cell, now we have multiple arrows pointing back to this cell. Because for this cell, in order to get a bonus of $2,500, the percent of total for this division has to be within 20% and 25%. And since the North Division got 23%, that division got a bonus of $2,500. But if the percent of total was between 26% and 30%, the bonus would have been $5,000. So all these cells are used within our formula. And these cells affect the outcome of this bonus cell. So that's tracing precedence. Now let's trace the dependence for this cell. If we remove the arrows and then select Trace Dependence, there are no dependents for this cell because this cell doesn't affect the value of another cell. But if we choose a different cell, for example this 2,500 in the bonus table, and we trace the dependence for this cell, we can see that these cells are affected by the value of this cell. For example, if I change this 2,500 to 3,000, we can see that the 2,500 changed in the North Division and in the South Division. And if I undo that action, those cells change back to the 2,500. Because the value of these cells depend on the value of this cell. And then we can remove those arrows. So by tracing precedence and dependence, we can easily see which cells depend on other cells and which cells get affected by other cells. Another feature that Excel provides to help us get a better understanding on how our spreadsheet is functioning and how the formulas within the spreadsheet relate to each other is being able to show formulas. So once again, let's say you're sending a spreadsheet to someone and have them check to see if your formula is correct, or if they're sending the spreadsheet to you and you want to take a look at the formulas. Well, instead of clicking through multiple cells to see if there is a formula in that cell, what you can do is come up to the Formulas tab, and then within the Formula Auditing group, you can select Show Formulas. And if you give this button a click, now instead of our spreadsheet showing the values that our formulas produce, it's actually showing the formulas written in those cells. And this view makes it a lot easier to read the formulas and see how these formulas are referencing other cells. Now I'm going to show you another trick on how to quickly find the cells that have formulas in them. So I'm going to undo these actions, and then if you come up to the Home tab, and then click on Find and Select, and then click on Formulas, Excel automatically selects all the cells that have formulas with them. And since these cells are selected, you can give them a fill color, and now it is easily noticeable which cells have formulas in them. So there's no need to waste time and click through each cell and find the formulas. You can either show the formulas or find and select the formulas and give those cells a fill color. So earlier in the course, we discussed how we could apply subtotals to our data sets. And if you remember, when we applied those subtotals, we were able to click and expand the rows that were within that subtotal. Well, Excel provides a similar feature, but instead of adding a subtotal, it allows us to organize data into groups to where we can collapse and expand rows or columns. So to group a column, we need to select the column that we want to group. Let's say that we want to be able to collapse and expand quarter 1. We would have to select the quarter 1 column, then come up to the Data tab, and then click Group. Now up here above our column headings, we can just click the minus sign to collapse the column. Now quarter 1 is hidden, and then we can click the plus sign to expand the column. And then if you want to do this for quarters 1 and 2, we can select both of these columns and then click Group. So now if we click the minus sign below, it will only collapse the quarter 1 column. And then if we click the top minus sign, it will collapse both of those columns. You can also click these number boxes over here to the left to expand and collapse columns. So if we want to expand all the columns within our grouping, we can select 3. And then we can do the same for quarter 3. So we need to select quarters 1, 2, 3, click Group. So now we have added a new level. Then we can select all the quarters, click Group once more. Now we have 4 different levels of grouping. So if we want to collapse all these quarters, we can click the top minus sign. So now we only see the totals for each division. And then we can just click the plus sign to expand all the columns. And now we see the totals for each quarter. So if your worksheet is very complex and it's filled with a lot of detailed information, grouping your data is very helpful because it organizes your data and you're easily able to hide or unhide data that you want to view. And this is a lot more efficient than hiding and unhiding rows or columns. Because with groups, we can just select these buttons to view the data that we want. So try it out. So for this video, we will be learning about 3D referencing in formulas. And what all 3D referencing is using cell references from different worksheets inside your formulas. For example, in our workbook, we have 3 different sales sheet tabs. We have one for 2018, and then we have cells 2019, and then cells for 2020. And within the sales summary sheet, our goal is to sum the total sales for each quarter from each year. For example, within our North division for quarter 1, we need to sum the quarter 1 sales for the North division from 2018, 2019, and 2020. But the cells that we need to use in our formula are on different worksheets. And that's what 3D referencing refers to. So if we type in the equal sign, and then we go to the cells 2018 sheet tab, and then click the cell for quarter 1 for the North division, in our formula, it says cells 2018 exclamation point C3. And this little section right here is what's called 3D referencing. So we can come to the end of our formula, click the plus sign, go to cells 2019 sheet tab, then select the cell for quarter 1 for the North division, plus sign, go to the Cell's 2020 Sheet tab, select the same cell, and click Enter. Now we have summed the total sales in Q1 for the North Division, but for all 3 years. So if you noticed, even though we inserted the formula on this summary sheet, we were still able to build on this formula even though we were selecting different sheets. But now I want to share a quick tip with you and show you how you can open up a new window to where you can stay on this summary sheet and then reference cells from other sheets while still being able to stay on this sheet. So if we come up to the View tab and select New Window, now Excel has created a copy of your current workbook. My workbook is called Excel Practice Copy. Yours should say Excel Practice. And then you should see a -2, because this is the copy of your original workbook. So if I click and drag this window to the right side of my screen, I can place this copy workbook here, and then I can select my original workbook. Now I have both of these workbooks opened up on the same screen. And you can see that your original workbook has a -1 for the name, and then your copy has a -2. So now let's do the same thing, but for Q2. So in my original workbook, I'm going to select Q2 for the North Division, and then create the same formula. So I'm going to type in the equal sign, and then instead of clicking on different sheets within this workbook, I can select different sheets in my copied workbook. So I can go to the Cells 2018 Sheet tab, and then click Q2 for the North Division, +, and then I can go to the 2019 sheet, and then select Q2 for the North Division again, +, then go to the 2020 sheet, and then select the same cell. And if I click Enter, now I have successfully created this formula using 3D referencing, but being able to stay on my summary sheet within my original workbook. Now I believe having 2 views of the same workbook can definitely increase your workflow, because now we are able to work in different areas of the workbook at the same time. And these 2 workbooks mirror each other exactly. For example, if I type something in one workbook, it will show up on the other workbook. So these 2 workbooks are mirroring each other. And you can save either one. It's totally up to you. And to get out of this view, all you have to do is exit out one of the workbooks. It doesn't matter which one. And now we are back to just viewing the original workbook. So that's using 3D referencing within formulas, and I just wanted to show you that quick view tip to help enhance your workflow. Alright, so for this video, I will be showing how you can utilize the watch window in Excel. And basically what the watch window allows us to do is to watch how a cell value changes as we make changes in other worksheets. For example, in our cell summary sheet, we can see that the grand total for all the divisions is 432,943. But let's say we go to the Cells 2018 Sheet tab, and then we make a change for the East Division for Q4, and instead of 14,785, we change it to 20,000. Well, now we have to go back to our Cells summary sheet to look at the change. Well, if we want to see that change happen simultaneously without having to go back to this sheet, we can add this cell to our watch window. And to do that, all we have to do is select this cell, come up to the Formulas tab, and then select Watch Window. Now we have the watch window displayed on our screen. And we can add different cells to this window that we want to watch. So if we want to watch this grand total cell, we need to make sure that we have this cell selected, and then click Add Watch. And then click Add. Now in our watch window, it tells us which workbook the cell is in, which sheet is it on, the cell location, the cell value, and the formula if there is one. So currently for our grand total, our value is 438,158. So now if we go back to the Sales 2018 Sheet tab and come up here and start to change values, and we change this 20,000 to 25,000, click Enter, and in our watch window, we can see the change happen simultaneously to that grand total cell within the cell summary sheet without having to click back and forth between sheets. And if you have different cells that you want to watch, you can add multiple cells to this watch window. And to delete a cell, all you have to do is select the cell that you want to delete and then click Delete Watch. So that's how you can utilize the watch window and save time clicking back and forth between different sheets to see changes to a specific cell. Alright, so when you are working with a large data set, like the one that we have on the Employee Data Sheet tab, it can be very useful to use Excel's Freeze Panes feature. And freezing panes allows us to keep rows or columns visible as we scroll through the rest of our worksheet. For example, we have our column headers at the top of our data set. Well, if we start to scroll down and then start adding a new row of data, we might forget which columns are which. Is this the first name or the last name? And then we have to scroll back up to know which column we're in. Well, we can freeze that top row, so when we scroll down our list, that top row will remain visible. So to do this, all we have to do is come up to the View tab, and then click Freeze Panes, and then we can select Freeze Top Row. And then this little thin gray line appears showing what we just froze. So now if we scroll through our list, our column headers remain visible. So we always know which columns are which. And to unfreeze this row, we can click Freeze Panes and then select Unfreeze Panes. Now that little thin line disappeared, and if we start to scroll, our column headers don't remain visible. We can also freeze the first column, because maybe you have a lot of data left to right. If so, you can select Freeze Panes and then select Freeze First Column. Now if we start to scroll to the right, that first column remains visible. We can also freeze panes of an intersection of a specific cell. For example, if we scroll all the way back to the left and then unfreeze our panes, and then select Atoms in cell C4, and if we come up to our Freeze Panes options and select Freeze Panes, now we have a vertical thin line and a horizontal thin line at the intersection of this cell. So if we start to scroll down, the first three rows of our dataset remain visible, and if we start to scroll to the right, our first two columns will remain visible. So that's how you can utilize Freeze Panes and keep certain rows or columns visible as you scroll through your worksheet. Alright, so for this section of the course, we will be going over a few what-if analysis tools that Excel provides. And what-if analysis is the process of changing the values in cells to see how those changes will affect the outcome of formulas on the worksheet. So basically, we can use different sets of values to explore various results. And the first what-if analysis tool that we will be going over is the Scenario Manager. And before we begin, I do want to point out that we will be working inside the Scenarios worksheet. So make sure you have this sheet selected. So before we start working inside the Scenario Manager, let's take a look at what our example is doing. In the first cell, we have the selling price of a product, which is $200. And if we sold 50 units, our total sales would be $10,000. And currently our expenses are zero, so our profit is $10,000. Well, in order to sell this product, we have to buy 3 separate parts from a distributor. And let's say that for part 1, it cost us $80. And then for part 2, let's say $55. Then part 3, $25. Now we can see if we sold 50 units, our total sales would be $10,000 and our expenses would be $8,000. So our total profit comes to $2,000. Well, what if we can buy these 3 parts from a different distributor and they offer us different pricing for these parts? Well, we could easily just change the price of each part and see what our profit comes to. And then we could write it down somewhere or save it somewhere else in the spreadsheet. But then we are losing the price for each part from our first distributor because we are entering new prices for this other distributor. And you can have several different distributors that you can buy these parts from with all different prices. And instead of building a table for each distributor, we can store multiple versions of data within the same cells using the Scenario Manager. For example, if we come up to the Data tab and select What If Analysis, and then click Scenario Manager, we can add multiple scenarios within this window. So let's add our first distributor pricing. So we can click Add, and for the scenario name, we can just put DIS for distributor 1. Select the cells that we will be changing, which is cells C10 through C12, and click OK. And now we can enter the values for each of these changing cells. So in cell C10, we have 80, C11 is 55, and C12 is 25. So we can click OK. Now our distributor 1 scenario is within our scenarios list. Now let's add another distributor. So if we click Add, and for the name, we could put DIS2. We are going to keep the same range for the changing cells because we're only interested in changing these cells. And then we can click OK. Now let's say that part 1's price that our second distributor is offering is only $70. And part 2 is only $50. But part 3, let's say it shot up to $38. We can click OK. And now we have distributor 2 in our scenarios list. So from here, if we want to change the values in these cells to the values that we have for our distributor scenarios, we can click on distributor 2 and click Show. Now our cells have updated to the new pricing, and we can see that our profit is $2,100. And if we click distributor 1 and click Show, it has updated the cell values, and now our profit's only $2,000. So we could easily change the values of these cells and determine which distributor to buy from that gets us the best profit. So in this case, we would want to go with distributor 2 because our profit has increased by $100. And you can save multiple scenarios within this manager, and you can always edit the values within these scenarios. So if distributor 2 ever updated their pricing, we can select the distributor and click Edit. Then click OK. And then we can change the price for each part. I'm just going to cancel for now. So that's how you use the Scenario Manager within Excel's What If analysis tools. And like we just saw, it's very easy to store multiple versions of data within the same cells and then choose different scenarios to see different outcomes of your formulas. The next what-if analysis tool that we will be going over is the goal-seek tool. And basically what goal-seek allows us to do is that if we know the result that we want to get from a formula, we can use the goal-seek tool to input a value into the formula to give us the result that we are looking for. For example, let's say in this monthly PMT cell, and PMT is short for payment, we are going to build a formula to calculate the monthly payment if we took out a loan of $300,000 with an annual rate of 6% for the next 30 years. And to calculate this monthly payment, we can use the PMT function. So we can type in =, then PMT. And we can see here that the PMT function calculates the payment for a loan based on constant payments and a constant interest rate. So if we insert this function and then open up our function arguments window, our first argument is the interest rate. So we need to select cell C2, which is 6%. But this is the annual interest rate, and we are trying to calculate a monthly payment. So we need to divide this interest rate by 12. And then for our next argument is going to be the total number of payments for this loan. So we can select cell C3 for 30 years, but once again, we are paying this loan off monthly. So we need to get the total amount of months within 30 years. So we need to multiply 30 by 12. And then for our last argument is the present value, which is the total amount that the series of future payments is worth now. So we can select the $300,000. And if we click OK, our formula returns $1,798.65, which is the total amount that we will be paying monthly for the next 30 years. If our loan amount was $300,000 and our annual interest rate is 6%. Well, let's say that this monthly payment is way too high, and we can only afford a monthly payment of $1,250. Well, we could come up to these cells and start changing the values and try to get our monthly payment to $1,250. For example, if I change the loan amount to $250,000, now our monthly payment is $1,498, which is closer, and then maybe I can change the rate to 5%. Well, we're getting closer, but not quite. And this is where the goal-seek tool comes into play. So let me undo those actions to get back to our original amounts. Now if we come up to the Data tab, select What If Analysis, and then click Goal-Seek. Well, for our set cell, we need to select cell C6, because this is the cell that will produce our desired outcome. And we want to make this cell have the value of negative $1,250. Now the reason why I made this a negative number is because our PMT function is producing a negative value. And that's why you see these parentheses surrounding this number. Because currently, this cell has the accounting number format applied to it. And the accounting format shows negative numbers by putting parentheses around the value. And then for our changing cell, we can select one of these values that we want to change to get our desired amount of $1,250. So let's change the loan amount. And if we click OK, now our formula is returning our target value of $1,250, but if we only want to spend $1,250 a month, we can only afford a loan amount of $208,489. And if we click OK, it will keep those values in place. And if you click Cancel, it will take us back to the original values. Now let's try another one. If we select our monthly payment, come up to the Data tab, click What If Analysis, then Goal Seek, our set cell C6, and we want this cell to have a value of negative 1250. And this time, instead of changing the loan amount, let's change the annual interest rate. So we can click in this box and then select cell C2. And if we click OK, now we can see if we only want to pay $1250 a month for a $300,000 loan for the next 30 years, we have to get an interest rate of 3%. So that's how you can utilize the Goal Seek tool. So if you know the result that you want from a formula, there's no need to waste time and manually change the cells to acquire the value that you're looking for, when you can use the Goal Seek tool to automatically change those values for you and get the desired result that you're looking for. The next what if analysis tool that we will be going over are data tables. And essentially, a data table is a range of cells that we can change the values of to come up with different answers to a problem. And for this example, we will be working inside the Data Table tab. So make sure that you have this sheet selected. And as you can see, this example is very similar to our Scenarios Manager example. With the Scenario Manager tool, we were able to change the distributor price for each part by assigning different values for these cells per scenario. Now, instead of those different values being inside the Scenario Manager tool, with data tables, our values are on the spreadsheet itself. And for our example, our goal is to be able to see what our profit would be if we changed the unit price. Well, we can do that by coming up to the price cell and changing this 200 to 205 or 210 and so on. But then we are wasting time having to manually enter these different values in this cell. Instead, we can use data tables. Now, if you use data tables, it's very important to know how to set up your data table correctly. So over here in our data table, we have the price column with all the different values that we want to insert into the price cell. And then in our next column, we'll show the outcome of our profit if we decide to use one of these prices. But for the first cell in our outcome column, we need to either enter a formula that will return our total profit, or we can just reference our profit cell in cell C6. You can choose to do either one, but for this example, I will type in the formula. So I'm going to type in the equal sign, and then click cell C4 for our total sales, minus C5 for our expenses, which will get us our profit. Now our data table is set up correctly, and we are ready to move on to the next step, which is selecting our table, then come up to the Data tab, select What If Analysis, and then click Data Table. Now data tables are only limited to one or two variables. One for the row input cell, and then the other is the column input cell. And since we are only changing one variable, which is the price in the price column, we need to select the column input cell. And then from here, we can select the cell that we want to change, which is our price in cell C2. And if we click OK, now our data table shows us our profit for each one of these prices. And then if your goal was to make $2,600 worth of profit, we can change our price to $210. And now our profit is $2,600. So with data tables, it's very easy to see multiple outcomes by changing the value of a different cell. And with data tables, you can see the outcome for as many values as you want. So this price column can keep going on and on. Whereas the scenario manager, where we can change the values of these 3 cells, although you can have an unlimited amount of scenarios, Excel only allows us to have a maximum of 32 different values. But both of these tools can be very useful for different situations and still be able to change the values in cells to see how those changes will affect the outcome of formulas. So for our last what if analysis tool that we will be going over is the Microsoft Excel add-in called Solver. And to put it simply, we can use Solver to determine the maximum or the minimum value of one cell by changing other cells. But the unique thing about Solver is that we can set limits or constraints on the variable cells and still have it produce the result that we want in our objective cell. Let me explain our goal for this example here, and hopefully you will have a better understanding of what we are trying to accomplish. We will be working inside the Solver tab, so make sure that you have this sheet selected. Now up here, we have 3 different products: monitor, laptop, and keyboard. And then it shows the profit and the cost of each of these products. So for a monitor, it cost us $50, but we make $35 worth of profit. And then down here, we have the order size, which specifies how many units we are going to order per product. And then down below, we can insert a formula to return the total cost and the total profit for all 3 of these products combined. I left the total cost and the total profit cells blank because I thought it would be a good idea to introduce another popular Excel function, which is the sum product function. So let's insert this function in our total cost cell. We can type equals and then sum product. Basically, the sum product function accepts arrays of cells and then multiplies and adds them together. So to get our total cost, we need to multiply our order size with the cost of the product, so 50 times 50, plus 100 times 450, plus 200 times 15. Well, we could write all that out with just a formula, but the sum product function allows us to just select the cells and it does the rest for us. So for our first array, we can select the order size, comma, and then we can multiply it by the cost. Then close parentheses and click enter. So our total cost is $50,500, which is 50 times 50 plus 100 times 450 plus 200 times 15. Let's use the same function for our profit. If we type in equal sign, sum product, select our order size, comma, and then select our unit profit. Close parentheses. So our total profit would be $23,250. Well, if we look over here to our right, we have some constraints. One of our constraints is the warehouse stock. The warehouse that we buy from only has 75 monitors, 50 laptops, and 125 keyboards. Well, over here in our order size, we can order 50 monitors because that's less than what the warehouse stock has. But we can't order 100 laptops because the warehouse only has 50 laptops. Same thing with the keyboard. We can't order 200 keyboards because the warehouse only has 125. So the warehouse stock is our first constraint. Our second constraint is our budget. And let's say that we don't want our total cost to exceed our budget. So in order to maximize profits, we would manually have to type in thousands of different scenarios for our order size while staying within these constraints. Well, if we did it that way, it would take us forever. Luckily, we can use the solver tool to change these cells that maximizes our profit while staying within these constraints. Well, like I mentioned before, the solver tool is an Excel add-in. So the first thing that we have to do is activate this add-in. And to do that, we need to come up to the File tab, go down to Options, click Add-ins, and for our Manage box, make sure it says Excel Add-ins, and then we can click Go, and then we can check the box for Solver Add-in, and click OK. Now if we go to our Data tab, and all the way to the right within the Analyze group, our solver command is now visible. So if we give this a click, it will open up our solver tool. Our first option is to set our objective cell. And our objective is to maximize profit. So we can select cell C10, and then we want to check max because we are trying to maximize profit. But if you find yourself in a situation where you are trying to find the minimum value or an exact value, we have those options as well. Our next option is to select our variable cells. So we can select our order size because these are the cells that we want to change. Now down below, we can start to add some constraints. Our first constraint is to make sure the order size doesn't exceed the warehouse stock. So to add this constraint, we can click Add, select the order size for our cell reference, and then we need our order size to be less than or equal to our warehouse stock. So for our constraint, we can select our warehouse stock. And if we click OK, now we can see our first constraint in our list. Now let's add our budget constraint. If we click Add, and for this cell reference, we need to select total cost, and it needs to be less than or equal to our budget of $15,000. And we can click Add. And there's one more constraint that I need to mention. When the solver tool starts to change the values for the order size, it can put in decimal values. And sometimes that might be okay, but we can't purchase 5.75 of a monitor. So we need our order size to remain as whole numbers. So we can select our order size again, and then we can click this middle drop-down button and select INT, which is short for integer. And we can click OK. Now we have all three constraints. And if we click Solve, it says that Solver has found a solution. And the best way to maximize our profit, staying within the warehouse stock and our budget constraint, we need to order 73 monitors, 21 laptops, and 125 keyboards. And this makes our cost $14,975, which is $15 below our budget, and we achieve a maximum profit of $8,730. So we purchased 73 out of 75 monitors, and then we only purchased 21 out of 50 laptops, but then we bought all the keyboards. So based on the unit profit and cost of each product, The solver tool knew how many of each product that we should order to maximize our profit while staying within our budget and our warehouse constraint. And if we click OK, Excel will place those values in there, and if you click cancel, it will go back to the original values. I'm just going to press OK for now. Now that we have our solver tool all set up with the constraints, we can always change these constraints and run the solver again. For example, if I change our budget to $30,000 and then come back up to the solver tool, everything is still in place, and then all we have to do is click solve. And if we click OK, now our budget allows us to purchase all the stock, which has a total cost of $28,125 with a maximum profit of $13,875. So the solver tool is one of the best what-if analysis tools within Excel, because unlike the goal seek tool where we could only change one variable, the solver tool allows us to change multiple variables while staying within the constraints that we set. So I strongly suggest utilizing the solver tool any chance you get, because it's a very powerful tool. It can save you tons of time and you can achieve the result that you're looking for. So for this section of the course, we will be going over Excel VBA. Now this is one of the areas of Excel that is really exciting to learn, but it's also in a whole different ballpark. And sometimes it can get a little overwhelming. So I want to make sure to take the time to explain what Excel VBA is and what it's used for. So VBA stands for Visual Basic of Applications, which is the programming language of Excel and other Office programs, meaning that all Office programs share this Visual Basic of Applications programming language. So code that is written in Excel can initiate commands in other Office programs like PowerPoint, Word, Outlook, and so on. Essentially, VBA is all about automation. With VBA, we can automate almost any task that we do inside of Excel by writing lines of code that are called macros. And macros is a term that you will hear a lot once you start working with VBA. And VBA is great for automating repetitive tasks, such as weekly reports, exporting files, data cleansing, and the list just goes on and on. There is just so much that you can do with VBA. So sadly, we can't cover all of its abilities in one course. But we will definitely look into some of the most popular uses of VBA, and hopefully you gain enough understanding of what VBA is and what it can do to where you can be creative and apply it to different areas within your workbook, and also be able to read some other lines of code that you might not have seen before and still be able to understand what that piece of code is trying to do. So all in all, VBA is such a powerful tool for automating any task within Excel that can definitely increase your efficiency. So like I said before, it could be a little bit overwhelming because we are actually learning a programming language, but I will try my best to take it slow and explain the steps in detail. And please, feel free to ask any questions if you're fully not understanding something, and I will be more than happier to help you. So without further ado, let's get to it. Alright, so for this video, I will be going over different areas of the Visual Basic Editor interface. And inside the Visual Basic Editor is where we will be actually writing the VBA code. And to access the Visual Basic Editor, we need to activate the Developer tab. If you haven't already done so, please download the VBA practice file from the resources. Once you have this file opened, we need to come up to the File tab, click Options, Customize Ribbon, And then we need to check the developer box. Click OK. Now our developer tab up here in our ribbon is now visible. And within this tab, we can access the VB editor, record macros, add buttons and other controls, which we will cover all those things later in the course. But to access the VB editor, we need to click on Visual Basic, or use the shortcut Alt F11 on your keyboard. And what we are viewing now is the Visual Basic editor. And the Excel application has to be open for us to view this VB editor. Now up here at the top is our menu bar and our toolbar. And this is where we can insert modules, procedures, user forms, run our macros, debug and comment out our code. I know that it looks like a lot, but later in the course we will actually start using these commands and you will get more familiar with them. If you don't see this toolbar down below, you can come up to the View tab, click Toolbars, and then click Edit. And this Edit toolbar will be very helpful later in the course. So that's our menu bar and toolbar. Next, we have the project window. And if you don't see this window, you can come up to the View tab and click Project Explorer. And within this project window, we have the project name, which is the name of the file. Yours should say VBA Practice. And then we have all the sheets within this workbook and the workbook itself. And also, if you had any other workbooks open, you would see them here as well. And within this project window, we will also see user forms and modules that we will be adding later in the course. And down below is the Properties window. If you don't see this Properties window, you can come up to the View tab and click Properties window. And the Properties window comes in handy when we start adjusting properties of different buttons and controls within the Developer tab. When we start working with user forms, we will be using this Properties window a lot more. And lastly, this big white area is our Code window. And this is where we will start to write and edit our VBA code. And this window will include all the procedures and functions that we use in our code. So that's basically all the areas of the Visual Basic Editor. I just wanted to get you familiar with the interface first, so you can be more comfortable working inside the VB editor. Okay, so we are about to create our very first Excel macro. And the way that we are going to create this macro is using the macro recorder, which can be located underneath the Developer tab. And within the code section, there is a command called record macro. Now the macro recorder is a very useful VBA tool because it records every task that you perform in Excel. And while it's recording, it writes down and saves everything that we do inside of our VB editor. And then we can execute that task over and over again with just a click of a button. So let's start simple. Let's click inside cell A1. And to start recording our macro, we need to select Record Macro. And we can give our macro a name, a shortcut key on your keyboard, but be careful with this because you don't want to overwrite another Excel shortcut. And we can tell it which workbook to save this macro in. We can just keep it for this workbook, and then give it a description. I'm just going to leave all this blank for now, and click OK. Now up here in our ribbon, we can see that Excel is recording our macro because our button changed to Stop Recording. So now it's recording everything we do inside of Excel. So let's type hello into cell A1. and click enter. And that's all that we are going to do. So let's stop the recording. Now let's go inside of our VB editor and see what it recorded. If we click Visual Basic, we can see in our project window a new folder has appeared called Modules. And if we click the plus sign to expand this folder, and if we give this module a double click, we can see all the steps that Excel recorded within our code window. I know that this code might look a little foreign to you, but we can try to decipher it as best we can. So within this macro, it says that in the active cell, .formula R1C1 equals hello. And then the next line says range A2 dot select. So basically, for any cell that we select and run this macro, it will insert hello into our active cell and then select cell A2. Let's try it out. For example, if I click in a random cell, let's say H5, and then I come back to our VB editor, click inside the macro, and in order to run this macro, we can click this green play button or F5 on your keyboard, and this will run the macro. So if we click play, our macro inserted hello into our active cell and then selected A2. Well, let's say that we don't want this macro to select A2 after it inserts hello. Well, we can come over here to our code and then delete this line that says range A2 dot select. Now if we click in a different cell in our worksheet, let's say cell E8, and come back over to our code and click play, now our code has inserted hello, but keeps our active cell selected instead of selecting cell A2. So now let's try to record a little bit more complex macro. In our workbook, let's select the Record Format Sheet tab. And let's say that our daily task was to import this file into Excel, and one of the things that we always do is format our headers. Well, we can just record a macro of how we format our headers, and then we can just run the code every time we import a new file, so we don't have to repeat the format process manually. So let's record another macro. So we need to click on Record Macro. And for this macro name, I'm going to name it Format Headers and click OK. Now Excel is recording every task that we do. So let's say that we want to format our headers with bold text, a dark blue fill color, and then change the color of the text to white. And that's it. So if we come back to the Developer tab and click Stop Recording, and over here in our VB editor, we see our macro name, which is Format Headers, and then everything that it recorded. Now at first glance, reading this code can be very complex, and you might not even know what certain things mean. But if we look closely, we can see that this code selects the range of A1 to J1, which is our header row, and with our selection, it changed the font to bold. And then with the interior of those cells, we changed the color to this accent color. Well, even if you don't know what this code means, you can still run the code and get the results that you're looking for. So if we go back into our workbook and undo those actions, now we are back to plain column headers. Well, we can go to our Format Headers macro and click play. Now our headers have the format that we want. Now there is one thing that I cannot stress enough about running VBA code, is that once you run a macro, there's no undo. For example, we just ran the macro to format these headers. If we look at our undo button at the top of our workbook, it's grayed out. And sometimes your macros can be really complex and make a lot of changes inside your workbook. So if you're worried about messing something up, or your code can be stuck in an infinite loop and cause Excel to crash, what I strongly suggest doing is saving your workbook before you run a macro. So once again, if you run a macro, there is no undo. So that's how you can record macros. And the macro recorder is great, especially if you don't know how to write a piece of code just off memory. You can just use the macro recorder and then try to decipher the code and then pick out the different lines to use in your own code. So even though that the macro recorder is a great tool, unfortunately, the macro recorder limits to what you can actually do inside of VBA. For starters, it's not very versatile, meaning that it always does the same thing no matter what. For example, let's say we imported another file that we wanted to format the column headers for, but let's say that this file only has 4 column headers. Well, if we run this format headers macro, it's still going to select the range A1 to J1 and format all those cells, even though that we only want to format columns A through D, not all the way from A through J. And the programming term for this is called hard-coded, meaning that your code will do the same thing every time, regardless. Another con using the macro recorder is that it writes down a lot of unnecessary lines of code that could potentially slow down the speed at which the code can run. And plus, it just makes our code unorganized and harder to read. But once again, the macro recorder is very useful to start out with, and you can start recording macros to automate tasks. Alright, so now that we have VBA code written inside of this workbook, we have to save this workbook as a different file type. So if we click Save, we get a message saying, the following features cannot be saved in a macro-free workbook. So if we want to save this workbook with no VBA code in it, we can select Yes. But if we want to keep these macros inside of this workbook, we need to click No, and then choose a macro-enabled file type in the file type list. So let's click No, and then we can select the drop-down for the file type, and then we have to select the macro-enabled workbook, which is a .xlsm. So let's give this a click and click Save. I already have a copy of this file, so I'm just going to replace it. So now our workbook is saved as a macro-enabled workbook that contains VBA code. Now I'm going to close out of this workbook and show you what happens when you open up a macro-enabled workbook. So I'm going to close out of Excel and then open up the VBA practice macro-enabled workbook. Well, usually you will get a security warning that looks something like this. And to enable the macros to run, you have to select Enabled Content. And you also might get another warning asking if you want to trust this document. And this is because some viruses can be stored in VBA code. So make sure that you are getting your macro-enabled workbooks from a trusted source. So that's how you save and open a macro-enabled workbook to make sure it runs properly. Okay, so for this video, I will be discussing how we can organize and store our VBA code. So inside of the Visual Basic Editor within our VBA practice file, over here on our left inside of our project window, what we have here are called modules. And the most common place that we store macros is inside the code module. And code modules can be located within the modules folder. And currently we have one code module inside this folder, which is called module 1. And inside this module, what we have are called procedures. And procedures are the building blocks of modules. They are sets of commands or line of code that are used to perform a certain task. So within this module, we have two sets of procedures. We have our macro 1 procedure, and then we have our format headers procedure. There are two different types of procedures. The first one is called a sub procedure, which are just lines of code that get executed. So that's why our format headers macro has the word sub in front of it. This is stating that this macro is a sub procedure. And within the sub and in sub are the lines of code that get executed. So if we wanted to add a new sub procedure inside of this module, we could come down here and start typing sub and then give this procedure a name. I'll just use test for now. And if we click enter, it automatically puts in sub. And then we can start writing lines of code between the sub and in sub. Another way to insert a sub procedure is to come up to our menu bar and click insert, click procedure, and then we can give it a name. I'll just put test 2. And then we can make sure to select sub. And I will talk about the public and private scope here in a minute. But if we click OK, now we have inserted our test 2 sub. The other type of procedure is called a function. And a function is a group of reusable code that returns a value, which then we can use that value inside of our sub procedures. So to insert a function, we can either type function out or come up to the insert tab, click procedure. I'm just going to name it test 3. And then we can select function. And if we click OK, now instead of sub and in sub, we have function and in function. So the lines of code that we write inside of this function will produce a value. And then we can use that value inside of one of our sub procedures and execute a certain task using that value. So you may be wondering, what is a public sub and a public function? Well, for public subs and functions, we can call or use these procedures across different modules. For example, currently we are in module 1. If we come up and click insert and add a new module, now we are in module 2. And you can see that there is no code inside of this module. But if we state that our sub procedures or functions to be public, we can use those procedures inside of this module. Now if I go back to module 1 and we insert a private procedure, I'm just going to name it priv sub. And just letting you know, anytime that you're naming modules or procedures, you are not allowed to have any spaces within the name. So if I put a space between priv and sub, this won't work. So you have to make sure there are no spaces. And this time, instead of making this procedure public, I'm going to make it private. And click OK. Now we can see that this procedure is labeled private. And this means is that we can only use this procedure within this module. So if we came to module 2 and try to call or use that private procedure that we just made, we wouldn't be able to, because private procedures can only be used within the same module. So these are code modules. Well, within our Microsoft Excel Objects folder, where we see all the different sheets within this workbook, these are called sheet modules. So if we double click on one of these modules, it will open up the code module for this specific sheet. And we can trigger the macros written inside of this sheet module with using worksheet change events. Meaning that if we change something on this worksheet, we can make a macro within this worksheet module run. Same thing goes for the workbook module. If we double click this workbook, now we can write macros within this workbook module, and we can trigger these macros if we make a change to the workbook. We will touch on this more later in the course when we actually start working with these worksheet and workbook change events. But for now, I just wanted to give you a good idea on how VBA code is stored and explain the structure of different public and private procedures that make up modules. So before we actually start writing lines of VBA code, it is important to understand what the VBA language consists of. The VBA language consists of many different things, but the three main elements are objects, methods, and properties. So let's start with objects. Objects are an element of the Excel application. So a few examples of objects could be a workbook, a worksheet, a chart or a shape, and the list goes on. And every object has properties and methods associated to it. A method is an action that the object can perform. Let's say that we had the worksheet object. Well, the actions that we can do with this object is either copy the worksheet, select the worksheet, or delete the worksheet. So those are methods, because that's what the worksheets object can perform. And lastly, we have properties. And properties are attributes of an object. So let's take the worksheet object again. A property of the worksheets object would be the worksheet name. Another property would be a range of cells within that worksheet. Well, properties actually hold values. So we can change those values to alter a property of an object. And like I said before, there are so many objects, methods, and properties within Excel that it's almost impossible to remember them all. But if you want to take a look at all the objects within Excel and see what methods and properties are associated to those objects, inside of our Visual Basic editor, we can come up to our toolbar and click this box that says Object Browser. And here we are provided a list of all the objects within Excel. So let's go find that Worksheets object that I mentioned in the previous examples. We can scroll down our list all the way to the W's and click on our Worksheet object. Now inside of this Worksheet object, we have a list of all its methods and properties. The lightning bolt symbolizes an event, and this green symbol is a method, and the gray symbol is a property. So one of the methods that I mentioned before for the worksheet object was copy, because this is an action that we can perform on the worksheet object. Same thing goes for the delete method. Now, one of the properties that I mentioned for the worksheet object were the cells on the worksheet. And you can see if I click this property, down below it says property cells. And we can keep scrolling. And another property is the name of the worksheet or a range of cells on a worksheet. Now within this worksheet object, we have the range property. But I do want to mention that properties can also be objects. For example, if I scroll to the R's in our object list, we can see that range is an object as well. And these are all the properties and methods that the range object consists of. Now I know this looks like a lot, but once you start writing code over and over again, all these objects, methods, and properties will almost start to come naturally to you. It just takes a lot of practice to know which methods and properties go with which object. So before we move on to the next video, let me show you a simple line of code that includes objects, methods, and properties. So let's start with the worksheets object. And then we can specify the name of the worksheet that we are dealing with. So let's say the name of this worksheet was called test. And we have to surround the worksheet name with parentheses and quotation marks. So that's our object. And then one of the properties for the worksheets object is the range. So we can put dot range, and then we need to specify the range that we are dealing with. So let's say that we are trying to change cell A1. Once again, we have to surround our cell address with parentheses and double quotes. Now, one of the properties of this range is the value. And remember, properties hold values, but we can change those values. So if we type in equals hello, now we are giving this range property a new value. So basically, this line of code reads, on the test worksheet, in cell A1, insert the value of hello. And that's it. Like I said before, it just takes a lot of practice to get the hang of it, but throughout the rest of this course, we will see a lot of lines of code similar to this one. So for the rest of this course, once we start writing more and more code, we will start using variables. And variables are used to store values. And then we can start to use these variables within our code, and we're able to change these variables as our code runs. When writing VBA code, you will see how useful and important variables are to your code. By using variables, we can make our code a lot more dynamic and efficient. And before we actually start using variables inside of our code, I wanted to point out a few of the most common variable types inside of VBA. So currently in the VBA practice file, I'm on the variable types worksheet, and here I have listed a few different variable types. And depending on what you declare your variable types as, will affect what values you can store inside these variables. Let's start with integer. So if we declare our variable as an integer, that means we can only store a value from negative 32,768 to 32,767. So any number below that range or above that range cannot be stored as an integer variable. But if we declare the variable as long, we can see the number range increase significantly, with a low of negative 2 billion something to positive 2 billion. But if your value has decimals, you would need to use the double variable, because the integer and the long variables only store whole numbers. And next we have Boolean, which means that this variable type can only store true or false values. And next we have string, and this variable is used to store text values. A good example for a value that you would store as a string variable would be a worksheet name or a file name of your workbook. And lastly, we have variant. And this variable can contain any type of value. So if your value is numeric, true or false, a text value, you can store all these values inside the variant variable. Now there's definitely more variable types, but these are some of the more commonly used variable types. And really quickly, I'm going to show you how we can declare our variables. So if we go back to our VB editor, and I'm just going to do this inside the test sub procedure. So to start declaring our variable, we have to type in dim, D-I-M. And then we have to name our variable. It can just be a letter, such as X, or any name that you want to give it. I'm just going to stick with X for now. And then we need to type as, and then we need to decide what variable type do we want to store this variable as. Is this X variable going to be an integer, a double, boolean, or even a string? It just depends what you're using this variable as. But let's say that we are storing this variable as an integer. All we have to type is integer. And you can see that our dim turned blue and as integer turned blue. And that's it. And if we know that our variable is going to be a text value, we can just type in dim, and let's say our variable name is text, txt, and then we can type as string. Now we have declared that text variable as a string variable type. So declaring variables is simply letting Excel know what type of variable you are using and what kind of value we are storing inside these variables. You may not understand the importance of these variables yet, but once we start using these variables inside of our code, you will see how useful it is to store values inside of these variables and then use these variables anywhere in our code. Alright, so now that we kind of have a basic understanding of what the VBA language consists of, it's finally time to start writing some VBA code. And the first few lines of code that we will be writing is on how to reference a range. So we will be using the range object to represent a range within a worksheet. And this range could be a single cell, or rows of columns of cells, or even a selection of cells. So the range object can represent a variety of cells within the worksheet. I will be showing you many different ways on how to reference a range, because depending on your needs, one way might be more useful than the other. So for this video, we will be working inside the Range Object Sheet tab. So make sure you have this sheet selected. Now inside of our VB editor, the code within our Module 1 is a little bit messy. So I'm going to start fresh with a new module, which is Module 2. And if you don't have another module, you can come up to Insert and then select Module. And for clarity purposes, I'm going to click on Module 2, and down in the Properties window, I'm going to change the name of this module to Writing VBA Code, which is the name of the section of this course. And if I click Enter, now our module is named Writing VBA Code. So inside of this module, in order to start writing lines of code, we need to insert a sub-procedure. So I'm just going to click inside this code window and type sub, and then give it a name. I'm just going to call it ref range, short for referencing ranges, and click Enter. Now over here in our workbook, we will be inserting values in each one of these cells, using a variety of different ways on how to reference a range. So let's start with the first one, selection. Currently, the cell B2 is the cell that we have selected. So if we come over to our code window, and if our goal is to insert a value into that B2 cell, we can type selection dot value and then tell Excel what we want to insert inside of this cell. So we can type in equals, and I'm just going to put in a text value saying select. And anytime you use text values inside of your code, you have to make sure to surround it with quotes. So if I run this sub by pressing the green play button, Let's see what happens. Excel inserted select in cell B2 because that was the cell that we had selected. Let's move on to active cell. So if we select cell B3, this is now our active cell. And if we come over here to our code window and type in active cell dot value equals, I'll just put active. And before we run this sub procedure again, I'm going to comment out this first line. And to comment out a line of code, you can either put an apostrophe at the beginning of the line, and if you select somewhere else, you can see that this line turned green, which means if we run this sub, Excel will not execute this line. Another way to comment and uncomment lines of code is to select the line that you want to comment out, and up here in this toolbar, you can click uncomment block, and it uncomments that line, or you can click the comment block, and it will comment out that line. If you don't see this toolbar, you can click View, Toolbars, and make sure to select Edit. Now let's run this sub and see what happens. Excel inserted active because this is the active cell that we have selected. So selection and active cell are very similar, but active cell is only one cell. A selection could be a range of cells. Now let's do cell B4. But for this one, we don't actually have to have this cell selected. So I'm just going to select cell C1, come over to our code, and this time we will use the range object. So first we need to type in this workbook, because the cell that we want to insert a value in is inside our VBA practice workbook. And since we have multiple sheets inside this workbook, we need to tell it which sheet is this cell on. So we can type in worksheets, open parentheses, open quotes, and then we can type in the name of the worksheet, which is range object, close quotes, and then close parentheses. Now we need to tell it which cell that we want to change the value of on this worksheet. So we can type in range, open parentheses, open quotes, and the cell that we want is B4. So we can type in B4, close quotes, close parentheses, and then access the value property equals, and I will just type in cell B4. So what this code is saying is that inside of this workbook, on the range object worksheet, for cell of B4, input the value of this text. So let me comment out this line of code and then run our sub. And we can see that this text value was inserted into cell B4. So this was the long way of writing out this piece of code. For example, let me show you the quick way for cell B5. Let's comment out this piece of code, and beneath it, we can just type in range, open parentheses, open quotes, B5, close quotes, close parentheses, dot value equals cell B5. And that's it. So if we click play, it inserted that text value into cell B5. So you might be wondering why we just didn't do that the first time. Well, I wanted to show you this hierarchy because inside of VBA, you might want to reference a range that's on another worksheet or even in another workbook. So we could change this workbook to a name of a different workbook, and then we could change the sheet name to a different sheet as well. But if you are just wanting to reference a range on the active sheet that you have open, you can just start with the range object and insert a value. So now instead of just doing one cell, let's do a range of cells. So over here in our workbook, we need to write a line of code that can insert a value from cell B6 to cell C7. So now we have multiple cells. Let me click out of this, then comment out this line, and start adding a new line. We can start with range, open parentheses, open quotes, and then we can type in a range similar to what you would see when you're selecting a range of cells when building a formula. So here we can type in B6, colon, then C7, close quotes, then close parentheses, dot value, equals, and I'll just put B6 through C7. And if we run this sub, it has entered this text value in this whole range of cells. We can also reference a named range using the ranged object. For example, up here in our name box, there's a name range called inRange. And if we select it, it selects both of these cells. So these are the cells within our named range. Well, if we click out of this, come back over to our code, comment out this line. This time we can type in range, open parentheses, and then type in the name of our named range, which was in, then RNG, close quotes, close parentheses, dot value, equals, and I will just type in our name range, which is in RNG, close quotes, and if we click play, now that text value was inserted into all the cells within our named range. Another way to reference a range is by providing the row number and the column number of the cell that you want to insert a value in. For example, let's come back to our code window, comment out this line, and this time instead of using range, we are going to use cells. And then we can put open parentheses, and here we are trying to insert a value into cell B9. Well, for cells, it's asking for a row number and a column number. So for this cell, we know it's in row number 9 because it's the 9th row down. Then we can put comma, and for our column number, we can put 2 because column B is the second column in our worksheet. Then we can put close parentheses, dot value, equals, and I'll just put cell 9, comma 2, close parentheses, close quotes, and if we run our sub, that text value was inserted into cell B9 because it was the 9th row down and the second column over. Now let's do one more. So let's comment out this line, and let's use cells again, open parentheses. So for our row index number, we need to put 10 because the cell that we want to insert a value in is in row 10, comma, and now for the column number, instead of putting 2, we can actually just put the column letter, which in this case is column B. So we can put open quotes, B, close quotes, close parentheses. And I know that we've been putting dot value at the end of our range objects, but by default, if you don't put anything after the object, it automatically assumes value. So technically, you don't have to use value if you're inserting a value. We can just put equals, and I will just put cell 10B, close parentheses, close quotes. And if we click play, it inserted that text value into cell B10. Now the reason why I wanted to show you this last one, because let's say your cell was all the way over to column AD. You would have to count each column to get a number. So instead of counting, you can just put the column letter. So those are some common ways of how you can reference a range using VBA. So for this video, I will be going over two very common yet powerful tools inside of VBA. The first one is an input box, and the other one is a message box. Now the input box is a great way to prompt users to enter a value. And a message box is a great way to inform users anything about your program. For this example, we will be working inside the Boxes Sheet tab, so make sure you have this sheet selected. Our goal is to prompt users to enter a value and have the VBA code insert that value in cell C2. So within our Writing VBA Code module, let's insert a new sub. So we can click inside the code window, type sub, and give it a name. I'm just going to type in user IB, short for input box. Enter. So the code to prompt users with an input box, we need to type in input box. Then open parentheses. And for our first argument inside of our input box, we can provide a prompt. So if we put open quotes, we can tell users to please enter a value, period. Close quotes, and then close parentheses. Now to tell Excel where to insert this value that the user inputs into this input box, we need to specify the range before the input box. So before this input box, we can type in range, open parentheses, open quotes, and we are trying to insert this value in cell C2. Then we can put close quotes and then close parentheses. And lastly, we can put the equal sign, because we want this range to equal whatever the user puts inside the input box. So if we click inside this sub and click play, we are prompted with the input box, and it shows our description of please enter a value. So if I insert 10 and click OK, that value that I inserted into the input box got inserted into the range C2. Now let me show you what a message box is. So if I add a new line, and to create a message box, we have to type in MSG box. And then we can put open parentheses, and then we can type in a prompt. So we can put open quotes, and I'm just going to say, this is a message box, period, close quotes, then close parentheses. So now if we run this sub, it's going to prompt us with the input box because that's the first line in our sub. So this time I can enter a value of 15, click OK, and then our message box pops up saying this is a message box, and we can click OK. Now let's try to combine the input box with the message box. So just for an easy example, let's say that we want to inform users what they entered into the input box. So within our message box, we can type in the value that you entered is, and then from here, we can reference our C2 range to get the value. So we can put space, close quotes, and to combine our range reference, we can put space, ampersand sign, space, and then we can type in range, open parentheses, open quotes, C2, because that's the cell that our value's in, close quotes, then close parentheses. And then we can delete the period and the quotes at the end of this line. So now if we run this sub, we get prompted with the input box, and let's say I put 20, and when I click OK, now we get our message box saying the value that you entered is 20. So even though that we didn't put 20 in our message box, with combining this message box with our range object, we were able to get the value inside of our message box. And we can just click OK. So that was a little intro for an input box and a message box. And these are great tools to help guide users through your program. And later in the course, we will learn how we can control what the user can input into the input box. So for this video, I will be showing how we can use variables inside of our VBA code. And as I stated before, variables are used to store values, and then we can use those variables in different lines of our code. So for this example, we are basically going to do the same thing in the previous video, but this time use variables. So let's create a new sub and call it use var, which is short for variable. So remember, when we are using variables, it's good practice to declare your variables. So to declare a variable, we have to type in dim and then give our variable a name. I'm just going to put my var, and then we need to specify what we want to declare this variable as. Well, for this example, let's declare it as variant. And by declaring this variable as a variant, that means our variable can store many different values. It could be an integer, it can be a number that contains decimal places, a date value, a string of text, and so on. So instead of using range C2 like we did up here in our user IB sub, we are now going to use a variable. So we can type in my var equals, and I will just come up here and copy. You can just select OK for now and copy this part of the code using Control C, then Control V to paste. And now our variable equals whatever we put inside the input box. And then let's create a message box displaying what we inserted into the input box. So I'm going to come back up here and copy this line of code, Control C, then Control V to paste. And instead of retrieving the value from cell C2, we are going to use our variable. So we can delete range C2 and just type in our variable, which is my var, then close parentheses. So now if we run this sub, it's going to prompt us for our input box. Let's put 25, and if we click OK, now our message box says the value that you entered is 25. So this is how you use variables inside of your VBA code. Because what we inserted into our input box, our variable stored and saved that value, and then we were able to use that value in a different part of our VBA code by using our variable. Now really quickly, let me show you why it's important to declare your variables correctly. So let's click OK. And let's say that we declare my var as date. So that means our variable can only store date values. So if we try to run this sub again, and instead of a date value, we enter a text value, just saying hello, if we click OK, we get an error saying type mismatch. And if we click debug, it highlights the line of code where our code is breaking, so we know that there is something wrong with this line. And because our error said type mismatch, is because whatever we typed in the input box didn't match the value type that we declared our variable as. So if we change this back to variant, we should be good to go. And we will get into more proper ways on how to debug our code. But for this video, I mainly wanted to show you how we could declare a variable and then use that variable inside of our code. So for this lecture, we will be learning how to write a if-then statement inside of VBA. And as for the logic, it's very similar to the if function inside of Excel. For this video, we will be working inside the if-then sheet tab. So make sure you have this sheet selected. So for this example, our goal is to insert a grade in cell C2 and then use a if-then statement inside of VBA and display a message box saying if this grade is a passing grade or a failing grade. So within our writing VBA code module, let's add a new sub procedure. I'm just going to come down to the bottom here and type in sub and then give this sub a name. I'm just going to call it grade score and press enter. Now, like I said before, using variables inside of our code is very useful and it's good practice. So let's create a variable that will store the value that we enter in cell C2. Well, the first thing that we have to do is declare our variable. So we need to type in dim, then give the variable a name. I'm just going to call it my cell. And then we need to specify what we want to declare this variable type as. Well, for our grade, we know that we are going to enter anywhere between 0 and 100. So we can just declare this variable as an integer. So now that we have declared our variable, we need to set our variable equal to something. So we can type in my cell equals, and then we can put range C2. So the value that we insert into cell C2, our variable myCell will store that value. Now it's time for the if statement. Now the if statement is great for performing certain lines of code based on if a condition is met or not. So let's say for our if statement, if the grade that we insert into cell C2 is greater than or equal to 65, we want to display a message box saying that this is a passing grade. So the way to type that out within our code, we need to type in if, and then we can use our variable, which is my cell, because my cell equals to the range C2, and then we can put greater than or equal to 65. And now we have to tell Excel if this condition is met, then what happens? So we need to type in then press enter. And I'm going to indent this line of code by pressing the tab key on my keyboard because it gives our code a little bit of a cleaner look, and we can easily tell that this line is inside of our if statement. So if my cell is greater than or equal to 65, then we want to display a message box, open quotes, and then we can have it say, you passed, close quotes. And to close out this if statement, we have to press enter, and then I'm going to outdent using shift tab on my keyboard, and we have to put end if, and that's it. So if we come over here to our workbook and type 80 in cell C2, and then come back over to our grade score sub procedure and run this sub, we get a message box saying you passed. So we can click OK. But now if I change this score to a 60, which is below the 65, and we run this sub again, nothing happens. So now let's expand our if statement to a if-else statement. So within our code, any value that's greater than or equal to 65, we get a message box displaying you passed. So if the value is anything else, we can put a message box saying, sorry, you failed. So what we can do is add a new line underneath the message box, and we can type in else. So anything that's not greater than or equal to 65, we can display a message box saying, sorry, you failed. Sad face. Then close quotes. And that's it. So basically, like the if function, if the value in our cell is greater than or equal to 65, then return true, which is the message box saying you passed. And if it's false or else, display the message box saying, sorry, you failed. So currently we have 60 in cell C2. So if we run this sub, we get our message box saying, sorry, you failed. We can click OK. And now if we change this grade to an 85, run our sub, we get the message box saying, you passed. So that's the if-else statement. Well, currently, we only have one condition, which is greater than or equal to 65 or not. Well, inside this if-else statement, we can add an else if, which will allow us to have multiple conditions. For example, if we put 90 into cell C2, we will just get the message box saying, you passed. But let's say anything that is greater than or equal to 90, we want a message box saying, congrats on the A. And that's where the else if will come in handy. So right below the line that says message box you passed, we can insert else if, and then state another condition. So else if my cell is greater than or equal to 90, then add a new line, then have a message box saying, congrats on the A. But we are not quite done. For example, if I put 92 in this cell and run our sub, we still get the message box saying you passed. Because our first if statement says anything greater than or equal to 65 produce the message box saying you passed. So what we really need to do is add a and if to this first line. We just want this message box you passed to display if our grade is greater than or equal to 65 and less than and equal to 89. And then anything greater than or equal to 90 produce the message box saying congrats on the A. So in the first line of our if statement, right after my cell is greater than or equal to 65, we can type in and my cell is less than or equal to 89, then show the message box saying you passed. So let's try this out. If we run our sub, now we get the message box saying congrats on the A, because inside of our cell we have 92, which is greater than or equal to 90. And if we change this to a 75, run our sub, we get the message box saying you passed. And anything else that doesn't fit those conditions, which is anything below 65, so if you type in 58 and run our sub, we get the message box saying, sorry, you failed. I know this was kind of a lot, but hopefully breaking up this if statement piece by piece helped you understand the logic a little bit better. And before we move on to the next video, I do want to point out why using a variable in this case is so useful. For example, anywhere in our code where we used myCell, we could have just put range C2 and not even declare a variable. But let's say in our workbook, the cell that we entered our grade changed to B5. Well, if we use range C2 in different parts of our code, we would have to change that range to B5. We can just change our variable to equal range B5. So it's a lot easier to change it once instead of going into your code and changing everywhere where you use that range. Okay, so throughout this whole course, we have discussed many functions inside of Excel, such as the sum function, average, if, VLOOKUP, and so on. Well, we can actually use those functions inside of VBA. And this can actually save you a lot of time because you don't have to manually write your own functions. For example, within the WS function worksheet, we have an identical setup from earlier in the course when we were working with the VLOOKUP function. So if I put an ID number in cell G2, let's say 112, the VLOOKUP function should return the name associated to this ID number. So if we click enter, the VLOOKUP function returned Ryan, because over here in our list, Ryan has an ID number of 112. So our goal for this video is to reproduce this VLOOKUP function, but inside of VBA. So within our writing VBA code module, let's add a new sub procedure. I'm going to come down to the bottom here, add some space, and for this sub, I'm going to call it find name. And what we are trying to do is have our code look up the ID number that's in cell G2 and then return the name associated to that ID number in a message box. So the first thing that we need to do is declare our variable. So we can type in dim. I'm going to name the variable fName, and we can either declare it as a string or a variant, because the value that we are trying to return is the name within the name column. So either variable type will work. Now we need to make our variable equal something. So we can type in fName equals, and this is where we will insert the VLOOKUP function inside of VBA. And to do that, we can type in application dot worksheet function dot, and then we can type in the function that we want to insert, which is VLOOKUP. Now from here, it's pretty straightforward, because the arguments required for this function to work is the exact same if you were just using the VLOOKUP function within your spreadsheet. So we can put open parentheses, and the first argument is the lookup value. And our lookup value is our ID number in cell G2. So we can type in range G2. And that's our first argument. And our next argument is our table array. So we need to specify the range of cells that include our table. So we can type in range, and our table goes from A1 all the way to D14, which is this range of cells on our worksheet, A1 to D14. And for our last argument, we need to specify the column where our value that we want to return is located. So we are trying to return the name, which is in column 2. And since we are trying to find an exact match, for our last argument, we can put comma 0, close parentheses. Now we have successfully inserted the VLOOKUP function inside of VBA. We have the lookup value, our table array, the column number which our value that we want to return is in, and then the exact match. So now let's try to display a message box saying what ID number that we search for and the name that it returns. So we can type in message box, open quotes, and we can put ID number space close quotes, and then combine it with the ID number that we searched, which is in cell G2. So we can put the ampersand sign and then type in range G2. And then from here, let's display the name of the ID number in a new line inside the message box. So to add a new line within the message box, we can type in ampersand sign, VB new line. And once we run this sub, you will have a better idea what this expression VB new line does inside the message box. And lastly, we need to put the ID number that the VLOOKUP function returns. So once again, we can type in the ampersand sign. And for our ID number, we can just type in our variable, which is fName. Because fName equals this VLOOKUP function. And that's it. So if we run this sub, we currently have the ID number 112 inside of G2. And if we click play, our message box displays the ID number that we searched for was 112, and the name associated to that number is Ryan. Let's do another one. So if we change this ID number to 119, our VLOOKUP function returned Jack inside the worksheet. And if we run our sub, once again, it showed us the ID number that we searched for was 119, and the name associated to that number is Jack. So that's how you can use worksheet functions inside of VBA. All you need to do is type in application.worksheetFunction and then insert the function that you want. And that function will require the same arguments as it would if you were just using that function inside the Excel workbook. And the advantages of using worksheet functions inside of VBA is that you can change these function arguments to be more dynamic by using variables. So if you wanted, you can change these arguments using variables based on a value that a user puts in an input box, or based off an if statement that you use in your code. Meaning that if this condition is true, use this variable for this argument, but if it's false, use this other variable for one of the arguments. So hopefully you can see, utilizing VBA, you are able to create a lot more dynamic functionality inside of your spreadsheets. So at the beginning of this VBA section of this course, we discussed two types of procedures. We have sub-procedures, which we have been doing to execute lines of code, and then we also have functions. And as I mentioned before, functions is a group of reusable code that we can use in other sub-procedures, or we can insert this function into our worksheet just like all the other functions that we have been working with, like the sum function, VLOOKUP functions, and other conditional functions. So since we are familiar with worksheet functions, let's see how we can build a custom function inside of VBA that we can use inside of our worksheets. So inside the user-defined function sheet tab, our goal is to create a function that calculates the new student's test score, but with a curve added to their score. So within our Writing VBA code module, let's insert our first function. So we can type in function, and I'm going to call this function fGrade. And we know with functions is that they require arguments to calculate a value. So we need to specify the arguments needed for this function. But before we do that, we need to know how many points the curve will add to the student's score. So to calculate a curve, we need to take the highest grade in the class and then subtract that grade from 100. So if we take a look at our list here, we can see that the highest grade is 95. So 100 minus 95 is 5 points. So this function will add 5 points to each student's grade. So this function is going to require two arguments: the student's score and the range of scores, so we can figure out the highest score in the class. So for our first argument, we can type in open parentheses, and let's name this argument score. So this argument is the student's score, and then we need to declare this argument like we do with variables. So is this score value an integer, double, boolean, what? Well, if we don't declare it as anything, it automatically assumes variant. But since we know our score is between 0 and 100, we can declare score as an integer. And then for our second argument, we can put comma, and let's name this argument score underscore range. And for this argument, we will be selecting the score column, so we can declare it as a range. Close parentheses. So now we have created the fgrade function with its two required arguments, the score and the score range. So now we need to calculate the curve, which is finding the highest score in the class and then subtracting that score from 100. So let's think about this. What ways do we know on how to find the max value in a range of cells? Well, we can use the max function, right? Because if we use the max function for the score column, it should return 95, because that's the highest score within that column. So to calculate how many points the curve will add, we can type in C for curve equals 100 minus worksheet function, and then the function that we are going to use, which is max, so we can put dot max, open parentheses, and the max function just requires a range of cells, and it will produce the max value within that range. So since we are building a function that users can use inside their spreadsheets, we don't just want to specify this range of cells, C1 to C14. We want to allow them to select their own range of cells, which will be the score underscore range. Because once they entered the fgrade function into their worksheet, this function will require the user to insert a score argument and a score range argument. And this is where the user can select the range of cells to get the maximum value. So we got C, as in curve, equals 100 minus the maximum value within the range that they select. Now we need to tell Excel how this function should calculate. So we can put fgrade equals our score argument, which is the student's score, plus the curve, which is just C. Because 100 minus the max, which is 95, C will equal 5. And this function will take the student's score and add 5. So we are actually done creating this fgrade function inside of VBA. But now let's see how we can insert this function into our spreadsheet. So within the with curve column, how do we insert the fgrade function? Well, it's just like any other function. So we can come up to our formula bar, type in equals, and if we start typing in our function name, fgrade, we can see that our custom function has popped up. If we give this a double click, and then open up our function arguments window to see what arguments are required for this function, our first argument is the student's score, so we can select cell C2. And then for our second argument is the score range, which is all the scores within the score column. And I'm going to make this range an absolute reference by pressing F4 on my keyboard. So when we copy down this formula, this range will remain constant. And if we click OK, now our F grade function returned 94, because 89 plus our curve, which is 5, equals 94. And we can double click our fill handle to copy this formula down. And now our function has added 5 points to each student's score. And that's how you can create a user-defined function. Now you might have to do this a few times to get it down, but as you can see, we can create these user-defined functions and use them in our spreadsheet like any other function, but in the back end inside of VBA, we can write lines of code to tell this function how to calculate. Now everything I just showed you could be done inside of Excel with basic formulas and functions. For example, if I come into F2 and I try to recreate the same value that our fgrade function returned, I would have to type in equals 100 minus max of the score range, close parentheses, plus the student's score, equals 94. Now even though to create that formula, it was pretty simple to do, but sometimes these calculations will get a lot more complex. And instead of building out formulas like this, we can build functions inside of VBA so that users can just insert their arguments and our function will calculate it for them. And by just filling out the arguments looks a lot cleaner and easier to do than building out formulas. Now sometimes there might not be functions inside of Excel that can get you the answer that you're looking for. And if that's the case, you can just create your own function with your own calculations depending on your needs. Alright, so now that we have learned how to create user-defined functions and insert those functions directly into our worksheets, now let's try to create a function to produce a value and then use that value within another sub-procedure. As I mentioned before, creating user-defined functions is very useful, especially if that function doesn't exist inside of Excel. So for this example, we will be creating a function that converts miles to feet and then use that function within another sub-procedure. So within our writing VBA code module, let's add another function. So we can type in function, and I'm going to name this converter. And remember, with functions, we need to specify the arguments required for this function. So let's put open parentheses, and for this argument, I'm just going to name it x. Then close parentheses, and then let's declare the value that this function will produce as long. Because what this function is going to do is take the amount of miles that the user inputs and convert it into feet. So this number could potentially be a large value. So instead of using integer that only goes to a value from negative 32,000 to positive 32,000, we will use long because the value that this function could produce might be larger than that 32,000 mark. So to create our converter, we can type in converter, which is our function name, equals our argument x, which is going to be the amount of miles that the user inputs, times 5,280, which is how many feet are in 1 mile. And that's it for our function. So now let's create a sub-procedure that prompts the user with the input box to enter the amount of miles that they want to convert, and then display a message box saying blank miles is equal to blank feet. So down below, let's insert sub, and let's call it total feet. And we will be using a variable for this example, so let's declare our variable. So we need to type in dim. Our variable name could be mi, which is short for miles, and we can just declare it as an integer. Now we need to make our variable equal to something. So we can put mi equals, and this is where we are going to prompt the user with the input box. So we can type in input box, open parentheses, open quotes, and have it say enter miles, close quotes, close parentheses, and then have our message box say blank miles is equal to blank feet. So we can use our variable mi, which is going to be the amount of miles that the user inputs, ampersand sign, open quotes, space, miles is equal to, close quotes, ampersand sign, and this is where we will specify the amount of feet that's in how many miles of the user's input. So this is where we need to use our function to convert the amount of miles into feet. So we can type in our function name, which is converter, open parentheses, and our converter function only needs one argument. So we can use our variable mi, close parentheses, and what that's going to do is take the amount of miles that the user inputs and then take that value up to our converter function and use it as the x argument. So our function will read converter equals mi times 5,280. So back in our message box, we can type in ampersand sign, open quotes, space, feet, close quotes. So let's run this sub and see what we get. We get our input box that says enter miles. So if I put 10 and click OK, we get a message box saying 10 miles, and 10 is our mi variable. So 10 miles is equal to 52,800 feet. So in our message box, it used our converter function, plugged in the miles for x, and multiplied it by 5,280. So that's an example of how you can use functions inside of your sub procedures. And this is very helpful because we can reuse our function anywhere at any time. So if we had multiple sub procedures that converted miles to feet, we wouldn't want to have to rewrite that converter equation in every sub. Instead, we can just write our function once and then get that value to use in our different sub procedures. And also, this helps with the organization of our code. Okay, so I want to take the time to go over some very important and useful VBA lines of code. And the first one is how to find the last row of your dataset. So for this example, we will be working inside the last row sheet tab within our workbook, and our goal is to write a line of code that returns the last row of our dataset. And since that we are in a new section of the course, and our current writing VBA code module is getting a little bit cluttered, let's insert a new module. So we can come up to Insert and select Module. And I'll name it Important VBA Logic. So within this module, let's add a new sub procedure. So we need to type in sub, and then I'll call it last row. Okay, so there are many different ways to find the last row in your data set. And depending on how your data is set up, can determine which method is best to use for your situation. But for this example, we will be using one of the more common methods to find the last row. So I'm going to write out the whole line of code first, and then I will go back and explain each section of the code. So I'm going to type in LR for last row equals cells, open parentheses, rows dot count, comma 1, close parentheses, dot end, open parentheses, XL up, close parentheses, dot row. And this is the line of code that will return the last row of your data set. Now let me explain what this code is doing. Let's start with cells. We have seen cells before when we were referencing a range. And cells accepts a row number and a column number. So if we were trying to reference cell A1, we can use cells 1, 1 because A1 is in the first row and A is in the first column. But for our row number, we used rows.count. And what this does is count the total amount of rows that's in the Excel worksheet, which is 1 million something, right? And then for the column number, we are specifying the first column, which is column A. So this whole section right here is equivalent to the last cell that's in column A. So if we come over to our worksheet and press the shortcut key Control down, this cell is the exact same as cells rows.count, comma 1. Now the next section is end XL up. And this is equivalent to the shortcut key of Control up. So first, it takes us to this last row in column A, and then uses Control up arrow, which takes us to the last row in column A that has data in it. And the last part of this line of code is dot row. And this just returns the row number of the cell that end Excel up or Control up arrow takes us to. So if we add message box LR for last row and run this sub, our last row in our data set is 14, which is correct. And if I click OK and add a new ID number and run our sub again, now our sub returns 15 as our last row. Now if we put John in cell B16 and we run our sub still only returns row 15, even though 16 is the last row within our data set. Well, if we take a look at our code, we are only referring to the cells in column 1. So if we wanted this code to account for John in row 16 of column B, we would have to change this column number to 2. So this is definitely something that you would want to watch out for. But I can't stress enough how important and useful this line of code is. I personally use it almost every time I work inside of VBA. So this is definitely something that you want to remember. And later in the course, you will see how useful this line of code is when we start talking about loops and how we can do something to each cell until we get to the last row of our data. Another example would be if you needed to automatically insert a formula in the last row of a column. But we will get into all that later, so for now, just try to remember this line of code. So very similar to the code on how to find the last row of data, now we are going to go over how to find the last column of data. So within our VBA logic module, let's add a new sub and name it last, COL, short for column. Now once again, I'm just going to write out this line of code, and then I will go back and explain each section of the code. So let's type in LC for last column equals cells, open parentheses, 1, comma, columns, dot count, close parentheses, dot end, open parentheses, XL to left, close parentheses, dot column. So we should be familiar on how cells references a range, which takes a row number and a column number. So this piece of the code is counting all the columns in the Excel worksheet on row 1. So if we click in cell F1 and use the shortcut key Control right arrow, this takes us to the last cell in row 1. And end XL to the left is equivalent to the shortcut Control left arrow. So from this cell and then Control left arrow, it takes us to the last column with data in it on row 1. And then dot column returns the column number of the cell that end XL to the left takes us to. So if we add a message box returning the last column and run our sub, let's see what we get. Our last column returned 5, because on our worksheet, within row 1, the last column with data in it is 1, 2, 3, 4, 5. And if we add data to cell F1, our sub would return 6, and so on. But if we added data to cell F2, and we wanted to find the last column with data in it, we need to change our code to cells row 2 columns.count. So it will look in row 2 instead of row 1. So this is how you can find the last column of your data set. And this could be very useful to loop through your columns and add or change your header names, or add a formula to the right of the last column. So the lines of code for finding the last row and the last column are very powerful codes to know how to use inside of VBA, and I strongly recommend remembering them and putting them to use when possible. So for this video, I want to introduce the with statement. And what the with statement allows us to do is to perform a series of statements on a specified object without requalifying the name of the object. Now I will show you what I mean by that, but I'm going to show you the long way first, and then I will show you the short way with using the with statement, so you can get a better understanding on what the with statement does and how it can benefit us. For this example, we will be working inside the with sheet tab, and our goal is to change some of the properties of this value in cell A1. So inside of our VBA logic module, let's add a new sub. And I'm going to name it sub with EX, for example. So let's say that we want to make that text value in cell A1 bold. We would have to type in range A1. So now we are referencing that cell. And if we want to change the properties of the font object, we need to type in dot font. And one of the font properties is bold. So we can type in dot bold. And to make this text bold, we need to type in equals true. Now let's change the color of this font. Well, once again, we need to type in range A1 dot font, and now we can choose color. Now there's multiple ways to change the color property, but if we wanted to make this text blue, one of the ways is to type in equals VB blue. And lastly, let's change the font size. So range A1 dot font dot size equals, and let's say we want to increase the font size to 18. So let's run our sub and see what happens to our text value. Well, it made the font bold, it changed the color to blue, and increased the font size to 18. But this is the long way, because we had to reference the same range A1.font object 3 times. By using the with statement, we only need to reference that object once. But first, let's change our text value back to how it previously was. So I'm going to click in cell A1, deselect bold, change the font back to 11, and change the color back to automatic. And then let's comment out these lines of code and start to create our with statement. So what we need to do is type in with, and then the object that we want to reference, which is range A1 dot font. Now from here, all we have to do is type in the properties that we want to change for the font object. So let's click tab. And for the first one, we could put dot bold equals true. Then dot color equals VB blue. And lastly, dot size equals 18. And to close a with statement, we need to click enter. Then I'm going to press shift tab, and we have to type in end with. And that's it. And if we run our sub, it does the exact same thing. But you can see how our code is more organized and how much faster it took us to change the font properties using the with statement instead of writing out range A1.font multiple times. And you can use the with statement for any object within Excel. So instead of range A1.font, it could be with this shape or with this table and so on. And it's a lot more efficient to use the with statement to change properties of an object. So when you start writing VBA code, it is inevitable that you will run into errors. And Excel will give you some pop-up error notifications, but sometimes these notifications don't give you the best explanation as to why your code is breaking. So I want to take the time and give you some useful tips on how to debug your code, how to step through your code so you can have a better understanding how your code is performing, and how to handle VBA errors. And the way that I'm going to present these useful tips is to write a piece of code that prompts the user with the input box to enter their date of birth and have a message box display their current age. But throughout the process, I'm going to show you some potential errors that could happen, and that's where we will cover how to add more code to our sub procedure to make our sub bulletproof from errors. For this video, we will be working directly inside the important VBA logic module. So to start off, let's add a new sub, and I'm going to name it debug tips. And remember, our goal is to prompt the user for an input box to allow them to enter their date of birth. So the first thing we have to do is declare our variable. So we can type in dim. I'm going to name the variable DOB for date of birth, and let's declare it as date. Now let's give this variable a value to store. So we can type in the variable name equals input box and have it say, please enter your date of birth. So now we need to figure out how to calculate the user's age. So we can type in age equals, and we need to take the year of the date value that the user put in the input box and subtract it from the current year. Well, you know how Excel has many different functions, right? Well, VBA has its own list of functions too. And one of its functions is to grab the current date and time, which is the now function. So we can type in now, open parentheses, close parentheses, minus the user's date value, which is stored in the variable DOB. And then let's display a message box that says, you are space, close quotes, and then grab the age variable by using the ampersand sign, typing in age, ampersand sign, open quotes, space, years, young, close quotes. And let's run this sub and see what happens. We get our input box saying, please enter your date of birth. So if I put 06, 08, 1996, click OK. Whoa, our message box says you are 8,920.700 and so on years young. Well, if you're ever not sure how your VBA code is calculating, you can go through the process of stepping through your code and see the values that your variables hold. For example, if we click OK, and inside of our sub, we can press F8 on our keyboard to step through our code line by line. So if I press F8, it highlights the line that it's currently on, and we can keep on pressing F8 to go line by line. And when you are stepping through your code, the line that is highlighted is saying this is the line that's going to be executed next. So if I press F8 again, it will run this input box line. We are prompted with the input box, so we can put in the date value again. Click OK or enter. Now we are able to see what value our variables store. So if we move our cursor over DOB, it says DOB equals 6/8/1996. So we know that this variable stored the correct value. And we can press F8 again. Now if we hover over age, we get that 8,920 figure. So why is it getting that figure? Well, if we hover over now, we get the date and the time. We just want to get the current year and then subtract the year of our DOB variable. And we can use another function within VBA to get the current year of a date value, which is called year. So right before the now function, we can type in year, open parentheses, and then at the end of the now function, we can put close parentheses. And that will get the current year of this now value. Let's do the same to our DOB variable. We can type in year, open parentheses, and then close parentheses. So now let's stop this sub and start stepping through this sub again. So if we click F8, enter our date value. So our DOB variable equals 6/8/1996, F8 again. Now our age value equals 24, because we are just taking the year of the DOB variable and we are subtracting it from the current year of this now value. So if we press F8 again, we get the message box saying you are 24 years young. So that's how you can step through your code to get a better understanding on what values are getting stored in your variables and how your code is actually performing. Now let's see how we can handle errors. So if we click OK, stop this sub, and play it. Now instead of entering a date value, what if the user put in a string value? I'll just put hi, and click OK. We get an error message saying type mismatch. Well, if a user gets prompted with this error, they don't know if they should press end, debug, or help. And we want to make sure that users can easily use our spreadsheets, So we need to add some more code to prevent errors like this. Well, the reason why we got this error is because we declared our DOB variable as a date value, and we entered a string. So let's click end. Well, one of the things that we can do to prevent this error is change how we declare our variable. So that way the users can enter a date value or a string value. So if we change DOB as date to variant, now the input box can accept any type of value. So if we click play and we enter hi and click OK, we still get that type mismatch error. But this time let's click debug to see which line of code is breaking. So the line that calculates the age is not working. And the reason why is that if we hover over the DOB variable, the value for that variable is high, and we can't take the year of a string of text. So now we need to put code in place to only allow users to enter date values. And we can do that by writing a if statement. So let's stop this sub. And right after we insert a value into our input box, we need to put the if statement. So we can put if, and we need to tell Excel to check the DOB value to see if it's a date value. And one of the ways is using another VBA function, which is called isDate. And within this function, we can put in our DOB variable. So let's type open parentheses, DOB, close parentheses. And this will check to see if the DOB value is a date. So if DOB is date, then calculate the age, and then show the message box. But if it's not a date value, we need to tell the user what format to enter the value in. So if our DOB value is date, then do this, else message box, and have it say, please enter a value in date format. Then end if. So now if we run this sub and we type in a string, click OK. Now we get a message box saying, please enter a value in date format instead of an error. And if we click OK, the sub ends because that's our last line of code, and we would have to run this sub again. Well, this would be a good time to automatically restart the sub procedure so the user can enter the value in the correct format. So one of the ways to do this to restart a sub is to define a point where you want to restart this sub, which is right before the input box. So right before this line, you can type in whatever you want, but I'm going to type in start, and then we have to put a colon. So right after the message box, please enter a value in date format, we need to tell Excel to go back to our starting point. So we can put a new line and type in go to start. So now if we run our sub and type in a string of text, click OK, we get our message box saying please enter a value in date format. And this time, once we click OK, it will come back to this starting point and restart the sub. And then we can put in our date value. And since this time our value was a date, it will calculate our age and then prompt us with the message box saying you are 24 years young. And one more tip that I want to share with you is that sometimes pressing F8 to step through your code can be time consuming, especially if you have a lot of lines in your code. And if you are trying to see what values your variables are storing at the end of your code, instead of stepping all the way down, you can add a stop to make your code run all the way until that stop. Let me show you. If we click OK, And let's say that we want to stop at the beginning of the if statement. So if we come over to the if line and right to the left inside this column, we can give this a click and it adds a red circle and highlights that line red. So this is where the code will stop. So if we click play, we can enter our date value, and then our sub stops, and then we can start stepping through our code from this starting point. So if we press F8, we can see what our code is doing, and this way we didn't have to keep on pressing F8 to get to this point, which can save us a lot of time. So this is a few ways on how you can debug your code and how we have control over user inputs to prevent any errors. So hopefully using these tools will help you understand on how your code is performing and open up the idea of how utilizing VBA can make your Excel spreadsheets a lot more user-friendly. Alright, so looping is one of the most powerful coding techniques that you can use inside of VBA. And these loops allows us to go through a set of objects such as worksheets, cells, and so on, and analyze them one by one. And inside of these loops, we can write code to perform specific tasks for these objects. Now there are many different types of loops inside of VBA, but the first one that we will be going over is one of the more common loops, which is the for next loop. And before we start writing the code for the loop, let's go ahead and insert a new module for this section. So inside of our VB editor, we can click Insert, Module, and let's name it Loops. Alright, so inside of the Loops module, let's insert a new sub and name it For Next. And the For Next loop is used to execute VBA code a certain amount of times. For example, let's say that we wanted to loop through a certain amount of cells and insert a value into those cells. Well, we can use the for next loop to loop through those cells. We will be using a variable for this example, so let's declare our variable first. So we can type in dim and call our variable x as integer. And let's say inside of our loops and controls worksheet, we want to loop through a certain amount of cells and insert a value into those cells. So let's insert a new column before column A by selecting the column and then use the shortcut key Ctrl+ or Command+ if you're on Mac to insert a column. And let's say that we want to insert a value into the first 5 cells of this column. So to start writing our for next loop, we have to start the code with for, and then our variable name, which is x, equals to 1, 2, and since we want to make this loop run 5 times, we need to put 5. And to close the for next loop, we need to put next x. So in order for this loop to work, we need to set our variable equal to something, which is 1, and this is the starting position for this loop, and then it's going to run this loop 5 times. So between the for x and the next x is where we can write the lines of code that we want to execute each time. So if we are trying to insert a value into cells A1, A2, all the way down to A5, we can reference those cells by putting cells, open parentheses, and for our row index number, we can use our variable x, because we want our row number to change each time we go through this loop. And since column A is the first column, we can put comma 1, close parentheses, and we can just insert the value of 100. And that's it. So for x is equal to 1, cells 1, 1 will equal 100, go to the next x, which is 2, so cells 2, 1 will equal 100, next x, 3, 1 to 100, and so on. So if we click play, cells A1 to A5 received the value of 100. So that's the basics of the for next loop. But now let's apply the last row and an if statement inside of this loop to make this loop more dynamic. So let's delete column A and comment out these lines of code and create a new for next loop. So first, let's declare our variables. So we can type dim x as integer and dim lr for last row as integer as well. And then we need to make our last row variable equal to something. And like I said before, we would be using the last row code when we start working with loops. And if you remember, the code is last row equals cells rows dot count comma 1 dot end xl up dot row. And for this example, let's say that we want to loop through all the cells within the width curve column. And if the student's score is greater than 90, then fill that cell with the color green. So the first thing that we have to do is create our for next loop. So for x equals 1, 2, and instead of hard coding a number of times to repeat this loop, we can use our variable last row. So this loop will only repeat until it gets to the last row of our data. And then we can put next x. So inside of this loop, we need to create a if statement to determine if the score is greater than 90, so we can highlight that cell green. So we can type in if cells, use our variable x, comma, and for our column index number, since we want to look in the width curve column, we need to put 5, because the width curve column is in the 5th column of our worksheet. Then we can put close parentheses, then greater than or equal to 90. So if cells x, 5 is greater than or equal to 90, then cells x, 5 dot interior dot color equals to VB green. And then we need to close this if statement by typing in end if. So we got for x is equal to 1 to the last row of our data if cells 1, 5, which is cell E1, is greater than or equal to 90, then for cells 1, 5, change the color of the interior of the cell to green. And then go to the next x, which is 2, and then place 2 inside of the x variable. Before we play this sub fully, let's step through this code to get a better understanding how this for next loop works. So if we press F8 on our keyboard, and we hover over the last row variable, we can see that last row equals to 14. So that means for x is equal to 1 to 14. Next line. So if cells 1, 5 is greater than or equal to 90, then fill the cell with a green color. And if you hover over cells, it will show you what's already in that cell, which is width curve. So if we press F8 again, one more time, well, it actually filled the column heading with the green color because it thinks that text value is greater than 90. So let's stop this sub and then change the E1 cell back to no fill. And then instead of starting from 1, we can change this to start from row 2. Alright, so now let's fully run our sub and see what happens. It highlighted all the cells green that had a value that was greater than or equal to 90. So that's how you can use the for next loop. Now for this example, it could have been achieved by using conditional formatting, but you will come across a time where conditional formatting won't do it for you, but then you can use VBA to expand all the options that you can do and make your processes a lot more dynamic. So the next loop that we will be going over is the do until loop. And this loop is used for when you want to repeat a set of statements as long as a condition is false. I will explain more about that condition once we start writing the code for the do until loop. So for this example, we will be doing something very similar that we did in the for next loop, but this time around, we will loop through the cells within the width curve column and highlight the cells that have a value that's less than or equal to 70 red. So within our loops module, we need to add a new sub. And I will call it do until. Once again, we will be using a variable inside of this loop. So let's go ahead and declare our variable x as integer. And unlike the for next loop, where we put for x is equal to something to whatever number of how many times we want to repeat the loop, for the do until loop, we need to set x equal to something before we start writing the loop. So we can type in x equals 1, and now we can start writing the loop. So we need to type in do until, and we want to loop through the cells within the width curve column. So we can type in cells, open parentheses, x comma 5, close parentheses, equals, and here's where we need to state our condition. And basically, we are trying to tell this loop when to stop. Well, we want to stop this loop when it gets to the last row of data. Well, instead of using last row, we could put blank, which is open quotes and close quotes. So as x increases and goes down these cells within the width curve column, once it gets to a cell that's blank, which is this row right here, the loop will stop. And to close this loop, we can put loop. And for any statements that we put between these two lines of code, we'll keep on getting executed until it gets to that blank cell. And here we are going to use another if statement so we can find the cells that are less than or equal to 70. So we can type in if cells x comma 5, since we want to highlight the cells that are in the fifth column of this worksheet, close parentheses, is less than or equal to 70, then cells x comma 5 dot interior dot color equals VB red, and then end the if. Now this next line of code is very important, and unlike the for next loop, it automatically increased x by 1 every time it completed one cycle of the loop. Well, inside the do until loop, we need to specify of how much we want to increase x by per loop. So we need to type in x equals x plus 1, because we want to go down one cell each time. And that's it. So for our condition of the loop, it says do until cells x comma 5 is blank. So it's going to keep running this loop as long as there's a value within the cell that's in the width curve column. And if one of the cells is less than or equal to 70, then we are going to highlight that cell red. And then we are going to increase x by 1 and then loop back up to the top and repeat the process. And one of the main reasons why this line is so important is because if you don't increase x by anything, that means x will always be 1 for each loop. And that will cause this loop to run forever. Because if our x value remains 1, that cell will never be empty, because that has our column heading. So it would just keep on looping and looping, causing Excel to crash. And one more thing before we run this sub, let's change our X value to 2. So it starts on row 2 instead of row 1. So if we click play, it highlighted the cells that have a value of 67 and 63, which is less than or equal to 70. So that's how you can use the do until loop. You can also change this loop up a little bit to make it a do loop until, meaning that we can take this condition right here and move it down here to make it say loop until cells x comma 5 is blank. So you can state your condition at the beginning of the loop or at the end of the loop. And before we move on to the next video, I want to make sure you understand that this line of code right here prevents us getting stuck in a never-ending loop, and it increases the x value by 1 every time we go through this loop. So this loop started out as cells 2, 5, and then once we got down here, it increased x by 1, so now this is 3, 5, and then it goes to 4, 5, and so on. So the next loop that we are about to cover is called the for each loop. And the for each loop executes VBA statements for each object within a collection of objects. For example, we can execute lines of code for each cell within a range of cells, or for each shape that's on a worksheet, or do something for every sheet that's within a workbook. Since we have been dealing with writing code to change cells that's on a worksheet, now we are going to try to do something for every worksheet within a workbook. And one of the most common things that we do to a worksheet is to protect the sheet. Earlier in the course, we learned how to add protection within Excel, but we can do the same thing inside of VBA, but just in a lot more efficient manner. Instead of having to go through each sheet and protecting that sheet, with the use of VBA, we can protect all the sheets at once. So within our loops module, let's add a new sub and call it for each. And this time around, since we will be looping through each sheet within the workbook, we need to declare our variable as a worksheet. So we can type in dim and call it ws, which is short for worksheet, as worksheet. And now we can create the for each loop. So we need to type in for each, and we want to loop through all the worksheets inside of this workbook. So for each worksheet in the worksheets object, we want to protect each worksheet. So we can type in ws.protect, and if you want to, you can either leave it as that or add a password. So let's type in password equals open quotes and then type in any password. I'm just going to type in 1, 2, 3, 4 and then close quotes. And to close this for each loop, we need to put next worksheet. And that's it. So for each worksheet inside the worksheets object, protect the worksheet with this password. So if we run this sub, and if we try to change a cell within any worksheet, we get a pop-up message saying that this cell is on a protected worksheet. And if we go to a different worksheet, we get the same message because it protected all the worksheets inside of this workbook. And if you wanted to unprotect all the worksheets, instead of worksheet.protect, we can type in worksheet.unprotect. And if we run this sub, now we are able to go back into any worksheet and we can start to type in any cell that's on the worksheet. And you can use this for each loop, not just for worksheets, but for any collection of objects that you want to loop through. Okay, so now that we have all these functioning macros inside of our code modules, we need to be able to allow users to run these macros without having to come inside the VB editor and clicking play to perform the task that they want. Now there are many different ways to trigger a macro, but the first way that I'm going to show you is how we can assign a macro to a shape. And once the user clicks on that shape, it will initiate the macro. So let's say that we want to have a shape that if a user clicks on it, it will highlight all the A's within the width curve column. Well, the first thing that we have to do is insert the shape. So we can come up to our Insert tab, go to Illustrations, Shapes, and you can select any shape that you want. I'm going to use this rounded rectangle right here. Click and drag to insert our shape. And then you can start to format this shape however you would like. The first thing that I'm going to do is insert a text value into the shape so this user knows what this shape will do. So I'm going to double click inside this shape and type in highlight A's. And I need to make this shape a little bit bigger to fit it all in one line. And then I will go back to the Home tab and center this text. And maybe make it bold. And then maybe I can add a shape effect to make it look more like a button that you can press. So I'm going to go to Shape Format, Shape Effects, and within Presets, I'm going to select this second option. So now our shape has a little bit of that bevel effect, making it look like you can click on this shape. Now the next step is to assign a macro to this shape. So what we need to do is right-click on the shape and select Assign Macro. And this will give us a list of all the macros that we have created inside the VB editor. Well, for our example, anytime a user clicks this button, we want to highlight all the A's within the width curve column. And we did that by creating the for next loop. So we can find this sub's name, which is for next, and click OK. Then let's clear the fill colors within this range of cells, come up to the paint bucket, select no fill. Now, if we click this shape, it should highlight all the A's green. So let's give this a click. And sure enough, it did what we expected it to do. So by assigning macros to shapes, provides a more user-friendly environment for the users because they can see a button that says highlight A's and they should know what's going to happen once they click on this shape. So this is a great way to trigger macros and provide a sense of direction for users working inside of your spreadsheets. So with having the Developer tab activated, we now have access to Form Controls and ActiveX controls. And these controls can be located underneath the Developer tab, and within the Controls group, we can select Insert. And here we can see the different options for both types of controls. So underneath Form Controls, we have a command button, a combo box, checkbox, option buttons, scroll bars, and so on. And the ActiveX controls share similar options, but just a few more. Form controls are geared more towards working just inside of Excel, and ActiveX controls lean more towards VBA. So I will reveal a few differences between both of these controls, and depending on what you're trying to achieve inside of your spreadsheet, one may be suited better depending on your situation. So for this video, we will be adding a Form button and then an ActiveX button. So that way we can walk through a few of the key differences between the two. So first, let's add a Form Control button, which is this icon here in the top left. If we give this a click, and click and drag to insert our button, it automatically prompts us to choose which macro that we want to assign to this button. We can just choose the for next macro to highlight the A's like we did in the previous video. So we can select for next and click OK. Unlike shapes, form controls don't allow us to change many properties of this button. For example, we can come in and change the text of this button and type in highlight A's. And then if we get out of the text box and right click this button and we come up to the shape format tab, you can see that shape fill, shape outline, shape effects is all grayed out. Even if we come to the home tab, you can see that a lot of these commands are grayed out. So really, the only properties that we can change for this button is the font property. And we can do that by giving this button a right click and go to Format Control. And underneath the Font tab, we can select the font that we want to use, the font style, so if we want to make it bold, we can. Change the font size, and we can also change the font color. So if we wanted to, we can choose blue and click OK. And that's pretty much it for changing the properties of this button. But if we come over to our with curve column and clear the fill color for these cells, now if we give our form control button a click, it still executes our for next macro. Now let me show you what we can do with the ActiveX command button. So if we come up to the Developer tab, click Insert, select our button, click and drag, and if we come up here within the Controls group and click Properties, now we have access to all these properties that we can change. So within these properties, we can change the name of this command button. And currently it's called Command Button 1, and this is the name that we would use in our code if we wanted to refer to this button. So if we wanted to have this button highlight the failing grades within the with curve column, we could give this button a more distinct name. So instead of Command Button 1, we can type in Fail CB, short for Command Button. And if you noticed, that doesn't change the actual text that's on the button. It still says Command Button 1. If we want to change this text, we have to go to the Caption property and change this to Highlight Fs. And unlike the form control, we can actually change the background color of this button. So if we come up to the back color property and select this dropdown, we have a few options here, or we can select this other tab and select a color of your liking. So let's say that we want to make this button red. We can do that. And we also have access to change the font properties, change how our mouse pointer looks once we hover over this button, or even insert a picture inside the button. So you can tell there's a lot more properties that we can change for the ActiveX control over the form control. Now to assign a macro for this ActiveX control, we have a few options. So if we double click this control, it opens up the code module for this control. You can see that it inserted a sub called FailCB, which is the name of our control, _click, meaning that if a user clicks on this control, it will execute all the lines of code within this sub. So we could write all the code over again to highlight all the failing grades within the with curve column, which was our do until loop, or since we already have the code written inside of our loops module, we can just call that sub. And all we have to do is type in call and the name of our sub, which is do until. So when a user clicks on this control, it's going to call the do until sub, which is located within the loops module, and it will execute these lines of code. So let's try it out. If we come over to our workbook, click out of the control, we have to get out of the design mode in order to click this control. And then I will also close out of properties. And now if we click this control, it calls our do until sub and highlights all the failing grades within the width curve column. So even though we can assign a macro to a shape, form control, or ActiveX control, all of them have their differences. Shapes and form controls are a little bit easier to work with, especially if you're just working inside of Excel. But ActiveX controls have a little bit more flexibility due to all the properties that we can change, and they can be used as objects inside of your code. But one very important thing to keep in mind about ActiveX controls is that they are not available for Mac users. So if you were building an Excel project for someone, it's a smart idea to ask what operating system they are using, because you don't want to create this whole project using ActiveX controls and then find out that they're on a Mac, and then you would have to go back in, delete all the ActiveX controls, and either use shapes or form controls to trigger your macros. So we saw how we can trigger macros by assigning a macro to a shape, form control, or ActiveX control. Well, another way to trigger macros is by using events. And before we dive into different types of events, let me explain what an event is. Events are actions that users can perform inside of Excel that can trigger macros. The first type of event that we will be going over are worksheet events. And worksheet events are actions that users can perform on a specific worksheet. So instead of inserting a code module and creating procedures inside that module, we can access these worksheet events by double-clicking one of these worksheets within the Microsoft Excel objects. So let's say that we want to trigger a macro when a certain event gets taken place on the Loops and Controls worksheet. Well, what we need to do is double-click Loops and Controls, and currently we already have one sub, which is if the user clicks on the Highlight Fs button, it will call the do until loop. Well, if we want to access the worksheet events, we can come up here and click this drop-down and select Worksheet. And automatically, it inserted a new sub called Worksheet _ selection change. And this right here is an event that can be taken place on the worksheet. So anytime a user selects a different cell, we are changing selections, and it will execute any code within this sub. To change the worksheet event that triggers the macro, what we need to do is come up here to the second drop-down, and here we have a list of all the worksheet events. So if the worksheet gets activated, we can trigger a macro, or if a calculation happens, or a table update. So we have a lot of options to trigger a macro. For this example, let's trigger a macro when this sheet gets activated. So we can select Activate, and let's say that we want a message box that says, "Welcome to this sheet's name." So we can type in the ampersand sign, and to get the sheet name of the active sheet, we can type in active sheet.name. And that's it. So let's click a different sheet. And once we select the Loops and Controls sheet, we get our message box saying, "Welcome to Loops and Controls." So those are worksheet events. And like we just saw, we have many options to trigger a macro when an action gets taken place on this specific worksheet. And each one of these worksheets has their own worksheet events associated to them. So we saw how we can trigger macros by using worksheet events. Well, another very similar type of event are workbook events. And these events are basically the same thing, but one triggers macros for actions that get taken place on a worksheet, and the other triggers macros for actions that get taken place for the workbook. And to access these workbook events, we need to double-click this workbook inside the Microsoft Excel objects. So now we are inside this workbook's code module. And the first thing that we have to do is select this dropdown and select Workbook. And the first sub that it automatically inserts is the Workbook Open event. So anytime a user opens this workbook, it will execute the lines of code within this sub. To see all the other events that can trigger macros for this workbook, we can select this second dropdown. And you can tell there are a lot more events for the workbook than the worksheet. So we have already discussed the open event, but there's other events such as when a new sheet is activated, when a user inserts a new chart, or after saving the workbook, or before closing a workbook. So there are many different options that we can choose from. But for this example, let's say that we want a message box to appear when we add a new sheet to this workbook. So we need to select New Sheet, and inside this sub, we need to type in message box, and we can just say, you have created a new worksheet. And that's it. So if we come back over to our Excel workbook and we insert a new sheet by clicking this plus icon, a new sheet gets created and our message box pops up saying, you have created a new worksheet. So those are workbook events. And they're very similar to worksheet events, but one just deals with events that happen on a worksheet, and the other deals with events that happen to the workbook. So with these types of events, we are able to get really creative and produce very dynamic spreadsheets. As I mentioned before in the previous video, that by using worksheet and workbook events, we can get really creative with VBA and start making our spreadsheets a lot more dynamic. And for this video, I will be showing you a trick that you can do with worksheet events, and hopefully it will open up your mind to new ideas that you can do with VBA. Plus, we are also getting more practice with writing VBA code. So sometimes Excel spreadsheets can get really cluttered, making it hard to read the data. For example, within the Fun Events Sheet tab, we have item numbers for our row labels, and then the months for our column headers. Well, if we are trying to point out a specific piece of data within this spreadsheet, for example, if I just click in I-18, the cell that gets selected does have the green border around it. And sometimes it's still hard to read which row or column that this piece of data is in, and you might end up looking at the wrong value. Well, let's say that we want the row and the column of this active cell to be highlighted for readability purposes. So for any cell that we select in this worksheet, it will highlight this column and this row that this cell is on. Well, we can do that by using worksheet events. So the first thing that we have to do is select the Fun Events worksheet inside our Microsoft Excel objects. And then to access the worksheet events, we need to select this dropdown and select Worksheet. Now there is no need to change the event because the selection change event is the event that we want. Because every time we make a new selection on this worksheet, we want to highlight that column and that row. So inside of this sub, we can start writing our lines of code. So what we need to start off with is a with statement. And remember, with the with statement, we can easily change the values of properties of a certain object. And the object that we will be changing is the active cell. And we can also go ahead and close the with statement. So now let's write the piece of code that will change the fill color of all the cells in this row that the active cell is in. So with active cell dot entire row dot interior dot color equals, and one of the ways to change the color property is by setting values for RGB, which is red, green, and blue. So for the red value, we can put 255, comma, 230 for the green, comma, and 153 for the blue. Then close parentheses. And the reason why I'm using these figures is because if we come up to the Home tab and we select our paint bucket and go to More Colors and then select the Custom tab, you can specify a color that you want and then get the values for that color. So we have red, green, and blue. And then you can use these values inside of your VBA code. So let's cancel out of this and continue with our sub. Okay, so we have the row color. Now let's change the column color. So with active cell dot entire column dot interior dot color equals RGB open parentheses 189 comma 215 comma and 238 close parentheses. So as of right now, if we select a cell, it will fill the entire row of that active cell one color and then the entire column with another color. But let's say for the cell that we select, we want to keep the interior of that cell blank, so it has no color. So we can type in with active cell dot interior dot color index equals 0. And that's it. So now let's go over to our workbook and select any cell and see what happens. So it highlighted the entire row with this orange color and then highlighted this entire column with this blue color and left our active cell with no fill color, so it's easy to see which cell that we have selected. Now if we select another cell, well, our sub performed correctly, but now we're left with 2 columns highlighted and 2 rows highlighted. So we need to go back into our sub and add a new line of code that clears out all the fill colors first and then fill in the row and column. So right before our with statement, we can add a line of code saying cells, which reference all the cells on this worksheet, dot interior, dot color index equals XL none. So this will make all the cells on this spreadsheet have no fill color, and then it will proceed to the with statement and highlight the row and column. So now if we select a new cell on this worksheet, it clears out those other rows and columns that were highlighted and only highlights the row and column of our active cell. And if we keep clicking around, now that row and column fill color will follow our active cell. So once again, this was just a neat little trick to show you to get some more practice with VBA, and hopefully it will open up your mind to new ideas that you can do with VBA. So we have seen a lot of neat features and tools that we can use inside of VBA. And one of the best tools that you can use with VBA are user forms. And user forms are a great way to create a user-friendly environment for users to input data into the spreadsheet. Some of the advantages that we get with using user forms is that users can input data into the spreadsheet without actually having to type directly into the cells. And they give us more control of what we can allow the users to input and not having to worry about our format or functionality of our spreadsheet being compromised. Inside of these user forms, we can add many controls such as text boxes, command buttons, combo boxes, option buttons, and so on. And this will give the users a more personalized experience, feeling like they have a program written tailored to their needs. So for the rest of this section of the course, we will be working inside the User Form Sheet tab, and we are going to create a user form that allows us to input data inside of these columns. So the first thing that we have to do is create the user form. And we can do that by going inside the VB editor, clicking Insert, and select User Form. I can move this toolbox for now. And you can see inside of our project window, we have a new folder called Forms with our new user form called User Form 1. And over here to our right is a little preview of our form. And the first thing that we are going to do with this form is change the name of our form. And to do this, we need to open up the properties for this user form. So we can come up to View and select Properties window. Now within our Properties window, we have all the properties that we can change for this user form. And the first property is the name. So instead of User Form 1, we can refer to this form in our code as Add Form. And within our Forms folder, our name changed to Add Form. So this is a little bit more descriptive than just User Form 1. Now up here in our user form, our caption still says User Form 1. Well, we can come down to the properties and change the caption property to Add Item. And now up here in our user form, Add Item is our caption. So that's how you can create a user form. Now we are ready to start adding controls into this user form, which we will get into the next video, but this will help guide users to know what data to input into the spreadsheet. Alright, so now that we have our user form inserted, we are going to start inserting some controls so that users can insert data into the user form, and then later we will talk about how we can pass that data into the spreadsheet itself. So the first control that we are going to add is a text box. And text boxes allow users to type within the text box, and then we can use that value that they inserted and pass it to our spreadsheet. So let's create a text box for the item number column. So inside of this toolbox within our VB editor, we can insert this text box control. And if you don't see this toolbox, you can come up to the toolbar and click this toolbox icon. So if we give this a click, the toolbox goes away, give it another click, and the toolbox reappears. So let's select the text box control and click and drag to insert our text box. And as we start inserting these controls, we will be naming each control so it's easier to refer to these controls within our VBA code. So with the text box selected, we can come down to the Properties window and change text box 1 to Item TB, which is short for text box. Alright, so now that we gave this text box a name, we need a way to help guide users what to insert into this text box. Well, this text box is going to be used to insert an item number. So we can add a label to help direct the users. So if we click back inside our user form, and the label control is this A icon right here. So we can give this a click, and click and drag. And if we click inside this label, we can change the caption of what this label says. So instead of label 1, we can type in item number. And the font is a little bit small inside this label, but we can change this in the properties window. So with this label selected, we can come down to properties and change the font property to increase the font to 11. Click OK. And to make this label box fit automatically to the size of your text inside of this label, we can come down to the properties window and give the auto size property a double click. So our label automatically adjusts to the size of the text. And we can rearrange these controls by just clicking and dragging the controls around. Alright, well, I think that looks good. And the next control that we want to add is the type column. So the first thing that we can do is create our label. Well, instead of starting a whole new label from scratch, we can just select our item number label and hold down Control or Command on your keyboard and click and drag this label to create a copy. And then let's change the caption of this label to type. And we can just resize this and then double click auto size twice to resize the label box. Now instead of a text box, there are only going to be two different types of items, either type 1 or type 2. So this would be a good opportunity to use option buttons, so the user can choose either type 1 or type 2. So we can select our user form, and then click this target symbol for our option button control, and click and drag to insert the control. And let's rename this option button to type 1 OB for option button. And then change the caption to type 1. And then we can auto size. And then from here, all we have to do is create a copy of this option button. So we can hold Control or Command on our keyboard and click and drag this option button. And let's rename this to type 2 OB, and then change the caption to type 2. And then I'm going to move things around so everything lines up properly. And that looks good. Now for the size column, we will have multiple sizes to choose from. So this would be a good time to use a combo box. And you can think of a combo box as a drop-down list like we created with data validation. So let's come over to our toolbox and select Combo Box. Click and drag. And you can see that it has a drop-down arrow that we can select to view a list of items within this combo box. And we can change this name to Size CBB for combo box. And then we need to make another label. Control drag. Change the caption to size. And for the color column, we will have multiple options to choose from as well. So we can just create another copy of this combo box. But first, let's select our user form and click and drag this endpoint to give us more room. So we can select our combo box, and this time I'm going to hold down Control and select size as well. Now if we use Control drag, it will copy both the label and the combo box. And let's change the name of this combo box to Color CBB, and then change the label to make it say color. adjust the size, and there we go. I'm going to move these up a little bit so it's evenly spread out. And then for the price column, we want the users to be able to input any price that they want. So here we are going to use another text box. So we can just come up to our first text box and control click our label as well. Then control drag and change the text box name to price TB, and then change the caption for our label to price. And the last control that we need to add are command buttons. So after the user gets done filling out all these details for an item, we need them to be able to click a button to add this item to our worksheet and a cancel button to exit out of the user form. So within our toolbox, we can select command button. And then we can click and drag. And we can change the name of this button to add CB for command button and change the caption to add. And also let's increase the font size to 11. And then we can create a copy of this button by pressing Control and drag. And let's name this button Cancel CB and change the caption to Cancel. Also, you can select multiple controls within your user form by either clicking Control on your keyboard and then selecting each control, or you can click and drag over the controls that you want to select. And now you are able to move these controls around or change the properties of them. So I'm going to move these command buttons down a little bit. And now I think we put together a pretty good looking user form that's very descriptive and easy to follow. We can click this play button to see what the user form looks like. So within our user form, in our text box, we can start typing the text that we want, select the option buttons, click the drop downs, even though there are no items yet, and then we can click add and cancel. But notice how none of these controls do anything yet. So in the next few lectures, we will start adding code to these controls to execute tasks. But before we move on, really quickly, let's change the font size of these controls because this text is a little bit small. So we can exit out of our form and we can select our text box, hold down Control, select both combo boxes and our other text box, come down to the font property, and we can increase the size to 10. Alright, so now we are ready to move forward with this user form. So as of right now, we have created this user form with all these different controls on it, which is great. But in order to show this user form, we have to come inside the VB editor, select our user form, and click play. Well, we don't want the user to have to go through this process because it's not very user-friendly. Well, what we can do is add code to a new sub-procedure to show this user form. So let's exit out of this, and you can either insert a new module or use one of these existing modules that we have created and insert our new sub-procedure. So I'm just going to click on Important VBA Logic, and down at the bottom here, I'm going to insert a new sub called Add Item Form. And the line of code needed to show a user form is very simple. All we have to do is type in the name of our form, which is add form, then dot show. And that's it. So if we run this sub, our user form pops up. So now that we have this sub created, we can assign this macro to a shape on the worksheet so the user can just click on that shape to open up the user form. So really quickly, let's close out of this. Come up to the Insert tab, Illustrations, shapes. I'm just going to use the rounded rectangle, click and drag. And within this shape, I'm going to insert some text that says add item, then center this text and make it bold. And now that we have our shape inserted and formatted the way that we want, we can give the shape a right click and select Assign Macro, and then find the macro that we just created to show the user form, which is Add Item Form, and click OK. So now, if a user comes to this worksheet and they need to add an item to this list, well, they can easily see this button that says Add Item, and if they give this a click, it will open up the user form. So this way is a lot more user-friendly than having to go inside the VB editor and clicking play on our user form to show the form. So now that we have provided a way to open up the user form, in the next lecture we will talk about how we can pass the values inside of these controls to the worksheet itself. Alright, so now it's finally time to start adding code to this user form so we can pass the values inside of these controls to the desired cells on our worksheet. So after the user inserts all the details for an item, we want the values inside of these controls to be passed over to our worksheet once the user clicks the Add button inside the user form. So we need to execute lines of code once this Add button is clicked. Well, to access the code module for this button, all we have to do is double-click on the button, and automatically a click event gets added inside of this module. The first values that we are going to pass over to our worksheet are the values inside the text box controls. So our first text box inside of our user form is the item number text box. And we want that value to be placed inside cell A2 that's within the item number column. So inside of our sub, we know a few options on how to reference a range. For this example, I'm just going to use cells. And for the row number, let's put 2. And for the column number, we can put 1. So in row 2 in column 1, which is column A, equals, and to get the item number text box value, we have to put the name of our text box, which is item TB, which is short for text box, dot value. So if we click the Add Item button on our worksheet, it opens up our user form, and then if we add an item number inside the text box, let's just say A101, and if we click this Add button, it will execute all the lines of code within this sub-procedure for the Add Command button click event. So if we click Add, A101 gets inserted into cell A2. And if we want to add another item, we can come inside this text box, change the item number, and click Add. Well, we can see that in cell A2, our first item got overwritten. Because within our sub, our code is always referencing cells 2, 1. Well, every time the user wants to add a new item, we want to expand the list. So this would be a perfect time to incorporate the code on how to get the last row. So first, let's exit out of our user form and get back inside of our Add button code module, and let's declare our last row variable. So we can type in dim LR as integer, and we can make LR equal to cells, open parentheses, rows dot count, comma 1, close parentheses, dot end Excel up dot row, and this will get us the last row of our item list. So instead of cells 2, 1, we can replace the row number with last row. Now if we step through this code by pressing F8 on our keyboard, our user form will pop up and we can type in a new item number, A103 for example, and if I click add, it takes us to our add button click event, and then we can press F8, F8 again, and it says that our last row is equal to 2, which is correct. But since last row equals 2, we will still be overwriting cell A2 because cells 2, 1 is still referencing the range that we don't want to overwrite. So instead of using last row, we need to use last row plus 1. So inside of our sub, we can either add 1 to our last row variable or add 1 to LR inside of our cell reference. I will just add it to the variable by typing in plus 1. So now if the user clicks on add item and types in a new item number and clicks add, since we added 1 to the last row, this item number gets inserted 1 row below the last row, allowing users to expand on this list. Now really quickly, let's do the same thing for our price text box. So let's exit out of the form, double click our add button, and down at the bottom here, we can add a new line and type in cells, last row, comma, 5, because price is the 5th column within our spreadsheet, close parentheses, equals the name of our text box, which is price tb.value. So now when we go back to add an item, we can enter the item number, and if we enter a price of $5 and click add, we can see that the item number got placed inside the item number column, and then our price got placed within the price column. So that's how you can pass values from your text boxes to your worksheet. And then in the next video, we will talk about how we can pass values for these option buttons. Okay, so we saw how we could pass the values inside the text boxes to the worksheet itself. Now we are going to discuss how we can pass values to the worksheet by using option buttons. Option buttons are a little bit different. Instead of a user inserting a value, they are either clicking option button 1 or option button 2. So our goal for this video is that if the user selects the type 1 option button, we want a text value that says type 1 to be inserted into the type column. And if the user selects type 2, then we want a text value saying type 2 to be inserted into the type column. Now we could double click on one of these option buttons to open up the code module and then execute lines of code when one of these option buttons is clicked. But for this example, it would be better to add the code for the option buttons inside the add button module. This is because we don't want to execute lines of code as soon as the user clicks on one of these option buttons. So instead, once the user clicks on the add button, our code will enter all the values within these controls at the same time. So let's go ahead and double click this add button. And I'm going to create some space between the item text box line and the price text box line so our code can go in order of our columns. Now this is not critical, it just organizes our code a little bit more to go in the same order of our columns. So like I said before, users cannot insert values into option buttons. They can only click on the option button. But these option buttons do store values. And let me show you what I mean by that first, so you can get a better understanding on what values these option buttons store. So just like our item text box and price text box, we are going to write the same line of code that says cells, last row, and this time for column 2, because type is in the second column of our worksheet, equals, and the name of our option button is type 1 OB. And sometimes you might not remember what you named your control. And instead of going back into your form and looking at the properties window to figure out the name, what we could do is type in me, which is referring to the user form, dot, and we can either scroll down this list, or if we just start typing in our option button name, which is type 1, we can see in our list that it says type 1 OB, and that's the name of the option button. I will leave the me in front of our button if you need to remember how to view all the control names within the user form. And then lastly, we can put dot value. Okay, so for cells last row, column 2 equals type 1 option button. Now let's see what value gets placed if we select the option button. So if we come over here and click add item, and we can just type in another item number, and if we select type 1 option button and then click add, exit out of this, that option button passed the value of true. So this means if the option button is clicked, it stores the value of true. And if it's not clicked, it stores the value as false. So in our code, we can write if the option button is true, then pass this text value. So let's go back inside the add button code module, and I will just comment out this line. So once we run this sub again, this line does not get executed. And right below that, we can start writing the code to pass the values that we want if the option buttons are clicked or not. So what we need to do here is create a if statement. So if type 1 OB equals true, then cells last row, column 2 equals, and we want to specify the type of this item number. So if the option button for type 1 is selected, we want to insert type 1. Now we need to expand this if statement to pass a value if the option 2 button is clicked. So here we can add an else if. So if type 1 option button is clicked, pass type 1, else if type 2 option button equals true, then cells last row, column 2 equals type 2. And then we need to close out our if statement by putting end if. So once again, if type 1 option button is clicked, which is true, then pass type 1, and if the type 2 option button is clicked, pass type 2. So let's run our user form and see what we get. If we click add item, add a new item number, and if we select type 1, click add, we get A107 type 1. And then if we add another item and make this one type 2, click add, then it inserted type 2. So that's how we can pass values if one of the option buttons is clicked. So we are making really good progress with this user form. Now in the next video, we will see what these combo boxes are all about. So the last controls that we need to write code for to pass their values over to the worksheet are the combo boxes. Combo boxes allow users to easily select a value from a drop-down list. And this helps keeping our worksheets consistent. And we should know by now that consistency is very important to reporting accuracy. The question now is, how are we going to fill these combo boxes with the values that we want? Well, when a user opens up this user form, we want those values already inside of the combo box. So we need some type of event that executes lines of code to insert values into these combo boxes upon opening the user form. Well, we have talked about worksheet, workbook, and button events. Well, there's also user form events. So if we double click on our user form, a new sub automatically gets created with the click event. So one of the user form events is that if a user clicks on the user form, it will execute code. Well, that's not really what we're looking for. We want an event that executes code upon opening the user form. So we are currently inside the user form code module, and we can select this right drop-down, and the event that we are looking for is called the initialize event. So when the user form gets opened, aka initialized, it will execute the code within this sub. So if we give this a click, it has inserted a new sub procedure, and we can go ahead and delete the user form click event. And within this sub, we can write the lines of code to add values to our combo boxes. And we can do this by using a with statement. So we can type in with, and the first combo box that we will be adding items to is the size combo box. And we named that size CBB for combo box. So with size combo box, we can type in dot add item and then specify the item that we want to add. So for the size combo box, we are going to add 3 different items. The first one will be small, and then the next one will be medium, and the last one we can put large. And then we need to close this with statement by putting end with. Now let's do the same thing with the color combo box. So we can type in with the name of our combo box, which is color CBB dot add item, and we can put green, then yellow, and lastly red. And then we need to close the with statement, and that's it. So when this user form gets initialized, it will add these items to the size combo box and these items to the color combo box. And one thing that I want to point out is that for this example, we are only adding 3 items to these combo boxes. Well, sometimes you might have to add 50 or 100 items to a combo box, and it would be very time consuming to type all of that out. So let's say that you had 50 items on a worksheet somewhere within the workbook. Well, you could write a for next or a do until loop that loops through all the items on that worksheet and adds them to the combo box one by one. So just keep that in mind if you ever find yourself having to add a lot of items to a combo box. Now let's go check out our user form to see if these items got added to our combo boxes. So we can click Add Item, and if we select the drop down for size, we have small, medium, large. And if we select the drop down for color, we have green, yellow, and red. So all that looks good. Now we have to go back inside of our Add Button module and write the code to pass these values within the combo boxes to our worksheet. So we can exit out of our user form, double-click the Add button, and right underneath our if statement, we can type in cells, last row, column 3, equals size, CBB, and then cells, last row, column 4, equals color, CBB. So now let's go add a full line item to our list. So let's click Add Item, put in the item number, select whatever type, choose a size, then choose a color, and then put in a price. And if we click Add, we can see that each control passed the values to the correct columns within our list. Now remember, if you are using combo boxes to help with consistency, there is one more thing that we have to change. For example, if I click inside the color combo box, I can actually change what's inside this combo box. So instead of green, yellow, and red, I can type in blue. And if I click Add, the color blue got inserted into our list. So if you want to prevent users from inserting values that are not within your combo box, we need to change one of the properties for this combo box. So let's exit out of our user form, select both combo boxes, and within our properties window, there's a property called Match Required, and currently it's set to false, and if we give this a double click, we change it to true. So now if we click Add Item, and then try to insert a color that's not within this list, such as blue, and we click Add, we get a message box saying invalid property value. So that's one thing to keep in mind if you are trying to prevent users from inserting values inside of the combo boxes that are not within the list. So that's how you can add items to your combo boxes by using the initialize event for your user form. So within our user form, things are looking really good. Everything looks nice and organized, and we have all the controls functioning properly. For example, if we put in a new item number, specify the type, choose the size, choose the color, set a price, and click Add, everything works as it should. But if we wanted to add a new item, we would have to go back inside each of these controls and change the values. Well, to prevent manually having to clear each control every time we add a new item, we can add some more code to our Add Button module that clears all the values within these controls after inserting a new item. So let's exit out of our user form, double-click the Add button, and at the very end of this sub, after it inserts all the values into each column, we can clear the control values. So we need to type in the name of each control and set it equal to blank. So the first control was the item text box, and we can make this equal to open quotes, close quotes, which is blank. And then for the option buttons, we can type in type 1 OB equals, well, we can't put blank for the option buttons because the option buttons only store values that are true or false. So if we want these option buttons to be unchecked after adding a new item, we need to set these equal to false. Same thing for type 2 option button. And then the size combo box equals blank. Color combo box equals blank. And lastly, the price text box equals blank. And that's it. So now if we go back to our user form, fill out the controls, and click Add, it added our new item, but then it cleared out all of our controls. And then we can start the process all over again, but starting from a blank user form. So that's how you can clear values of controls within your user form. So if you noticed, if we click Add Item, and we fill out this user form to add a new item to our list, and click Add, it adds the item to our list, all the controls get cleared out, but our user form stays opened. And to close out of this user form, we have to press this X. Well, sometimes you might want to have the user form close automatically after it gets done executing a sub procedure. Well, we can use VBA code to tell this user form to close. And let's say that we want to allow the users to close this user form if they select the cancel button. Notice how it doesn't do anything at the moment. So if we close out of this, and then this time double click our cancel button, it adds a new sub with the click event, and the line of code to close a user form is very simple. All we have to type is unload me. And that's it. So now if we open our user form and click cancel, it will close our form. So this was a very simple code to add if you want your user form to close automatically after it gets done performing a certain task. So really quickly, I want to share a very useful and beneficial tip that you can use inside of your VBA code regarding protected workbooks and worksheets. We know that the structure of our spreadsheets are very important to the performance and functionality of our spreadsheet. This is why we discussed earlier in the course on how to protect Excel workbooks and Excel worksheets. But sometimes protected worksheets get in the way of our VBA code. For example, over here in our worksheet, if we come up to the Review tab and select Protect Sheet and just leave password blank and click OK, now our sheet is protected. And if we open up our user form and try to add a new item, we get an error message saying the cell or chart that you are trying to change is on a protected sheet. So to prevent this error, we have to figure out inside of our VBA code to unprotect the sheet first, run our code, and then protect the sheet again. So let's go ahead and click End. And within our Add Button module, at the very beginning of this sub, we can type in active sheet dot unprotect. And this will unprotect the sheet, allowing our code to insert values within the spreadsheet. And then after our code is completed, at the very end of this sub, we can protect the sheet. And this time, instead of using active sheet, I'm going to refer to the actual sheet name. So I can type in sheets, open parentheses, open quotes, and then type in the sheet name that we want to protect, which is user forms. Close quotes, close parentheses, dot protect. And we could add a password if we wanted to. But for now, if we go in and try to add a new item and click add, it adds our item. And if we get out of this and then try to change one of the cells on the worksheet is now protected again. And one more thing that I found really useful when it comes to writing code that protects and unprotects worksheets is that inside of our VB editor, somewhere within these modules or add a new module, I create two sub-procedures, one for unprotecting worksheets and one for protecting worksheets. And within those procedures, I write code that loops through all the worksheets in the workbook, and it either unprotects the worksheets or protects the worksheets. And what this allows me to do is that anywhere I create a new sub-procedure, for example, this add command button click, instead of writing the active sheet.unprotect or sheets userforms.protect, I can just call my unprotect procedure and then call my protect procedure. So that way I don't have to keep rewriting the code to unprotect and protect worksheets. And this is especially useful when you are protecting or unprotecting multiple worksheets. And just as a refresher, to call another sub, all you have to do is type in call and then type in the sub's name. So if I named the sub unprotect, I could just write that. But currently, I don't have a sub called unprotect inside of this workbook. So that's how you can protect the structure of your worksheets in workbook by adding code to unprotect the worksheet at the beginning of your sub and then adding code at the end of your sub to protect the worksheet.
In this video, we're going to go over creating an Excel resume, or really just creating a resume for you to be able to go out there and get a job with your newly developed skills that you learned and you developed through this particular course. So let's go ahead and jump into how to create a resume using your newly developed skills. Okay, so now depending on where your experience is at, if you came into this course with a previous background in Excel and perhaps you've worked with it before and you previously were kind of a beginner, and now that you've gone through the course, you're now an expert and you have that expertise of being able to utilize different shortcuts, different tips, different tricks, right? Different strategies within the actual Excel dashboard, right? So depending on all of that is how you're going to put together your resume. So what you always want to do when you're creating your resume is that you always want to be accomplishment focused or end results focused. You always want to talk about what you did, how you went about it, right? Any type of, personal contributions that you've done to lead to successful completion of a particular project, or whatever that may be. But it needs to be things where you did XYZ, you accomplished XYZ, you improved this and that, or whatever that may be, right? That's going to be the biggest thing. Now, what you can also do to get some experience, if you don't have really any experience and you're just kind of starting out from scratch, but you've taken this course and so you have those skills, you just don't have that experience, is go out there and get some freelance jobs that we're going to walk through here in the next lessons here in this particular section. Go out there, get some freelance gigs, get some work under your belt, even though the job that you may get may be $10, $50, very low cost that you're going to get paid. However, that experience is going to be invaluable and you'll be able to put that on your resume, right? That you were a freelancer. So very important here to be able to position yourself accordingly so that you have the best opportunity to separate yourself from the competition and to position yourself as that expert in your field. This is pretty much where you are selling yourself. And so think of it as creating a certain perception of who you are, what you're able to accomplish, of the value that you bring to the team or to an organization or whatever that may be, right? Because hiring managers ultimately don't just want to see a list of job duties or what you're responsible for, I mean, I've seen this all the time. People don't do the proper research on how to be able to put together a resume, and they end up just listing a bunch of responsibilities or duties that they had, right? When nobody wants to see that. People want to see, X accomplishments, X results were because of what I did and how I went about it, and, X, Y, Z, and ABC, right? Because they want to see how you can make a difference in the new position at their organization. And we're going to go into, in the next lessons here, we're going to go into some of the other things you can do that you can add into your resume, as far as being able to, create a personal brand, create a website, right? And do all these different things that are really going to help you set yourself apart. And so a lot of different things you can do to be able to position yourself as that, expert in your field, and really as somebody who isn't just, another person with a resume with experience. You actually have a lot more to offer because, you are active on social media, because you have a website, because you have some personal branding, right? That's what companies, what businesses, employers are looking for, that are going to be outside the box, right? Because pretty much anybody out there can have a resume and just have, the experience on there, and, that's going to be it. And then they're just going to get thrown into a pile of, a ton of other candidates out there that are pretty much the same. But when you can really position yourself as, yes, you have the experience, yes, you have, XYZ, you have these accomplishments, but also you have all of these other things that set you apart, which is that personal brand, that online presence, right? So really think about some of the different things that you can do to really set yourself apart from the competition, and understand that we're going to go through also, like I said in the next lessons, a variety of different things that you can do to really build your perception and position yourself as that expert and really set yourself apart from your competition. So that's going to be it here for this one, and we'll see you on the next one. In this video, we're going to walk through how you can get started with freelancing. So one of the things that you're able to do through going through this course and developing all the different skills that you've developed with Excel and learning all the tips, all the tricks, all the different shortcuts, right? You've now become an expert, and you're able to go out there and either get a job or start freelancing, or even start your own company doing Excel or working within Excel for different companies. In this particular lesson here, we're going to go through the options that you have as far as getting started with freelancing. How does it work? Where to find different freelance gigs, the different websites, which we're going to cover in the next lesson. However, with this particular lesson here, what we're really just going to go over is how to get started with freelancing, giving you foundational understanding, and really letting you know that this is going to be probably the best thing that you can do right out of the gate. Instead of going out there and trying to look for a full-time job or full-time gig, if you don't have any experience, then this is going to be probably your best bet, so you can get that experience and then even go out there and be able to put this experience on your resume and be able to go out there and get a full-time job if that's what you want to do. So let's go ahead and jump into getting started with freelancing. So with freelancing, essentially what you are is you are self-employed and you take on work for other companies. You're pretty much doing the work of a subcontractor, and you're not actually your own company. You're just somebody that's out there who's self-employed, who is, taking on the contract work to work on a specific project, on a project basis pretty much, right? So it's nothing full-time. They're pretty much saying, hey, I need XYZ job done or XYZ project done. I need it completed within this amount of time. Here's the deadlines. This is what I need to be done, right? And then you take the project and you run with it and you complete it. And so one of the best ways to get started with freelancing is to apply for small Excel jobs on freelance websites. So let's say that you're starting out, you don't have any, background as far as, getting a career started or doing anything as far as Excel, right? What I recommend you do is you set up a profile on these various freelance websites that we're going to walk through in the next lesson, and you start out slow. You start out with these jobs that are $10, $15, $20, right? Something super simple. But the biggest thing here is that you want to be able to get that experience under your belt. You want to get the reviews. You want to get testimonials, right? You You want to get some case studies that will tremendously help you with being able to position yourself as a valuable expert in the Excel field, right? Because that's what a lot of people nowadays struggle with, because they're not able to really sell themselves on the resume and position themselves as being a true valuable asset to an organization. So that's what you're going to be able to, do with, getting started with freelancing and taking on these small jobs. And if you want to continue to freelance, then you can slowly build up your profile and slowly be able to raise up your rates. And just like I mentioned, right, the objective is to get some experience, get some testimonials, so you can increase your profile score and be able to increase your hourly rates. And then when applying to various freelance jobs, one of the key things here that is very important that I see a lot of people dropping the ball on is not making sure that they're catering their specific application to that specific project that they're applying for. So what ends up happening is that you'll have a lot of people that will just literally create these boilerplate templates. They'll send them out to all of the different job offers out there, and that's how they'll bid on the projects. They'll just send out a boilerplate template. It doesn't look like they've actually read the actual project description, and clients, right, are going to get turned off by this because they want to see that your application is unique and specific. Your bid there, right, is unique and specific to that particular job, that particular project, because if it's not, you're going to turn away a lot of clients, even though you may have the experience, even though you may have, the knowledge or whatever that may be, because clients want to see people who are taking initiative, who are reading the job description, and who can, put something together that is custom and specific to what that project is about, right? It can even be something as simple as, hey, I read your job description. I read, what you're looking for, what you're looking to accomplish. I believe my skills and my background will be able to help you accomplish X, Y, and Z. And even if you have some sort of recommendation as to, hey, this is what I think you can do to improve the project, or just simply giving a simple recommendation as to what they can do to make the project run a whole lot more smooth, right? And if you really want to set yourself apart from the competition here and really be able to differentiate yourself, is I recommend that you put together or create a video off using a simple software such as Loom. And what it does, it creates your screen, and you can do like a screen share and just walk through their particular project and their description, and just walk through the project there with a screen share video, not necessarily having to show your face, but just showing them, hey, I looked at your project description here. This is what I'm recommending, because more often than not, people do not send videos. And if you want to really set yourself apart, send the video that's custom, that's specific to that application or to that job that, people are looking for, that client is looking to get accomplished. And that will really set you apart from the competition. So this is how you can get started with freelancing. Understand that ultimately you're not an employee, you're not a company, you're self-employed, and you're taking on project work, right? Contract work for other companies, and you're getting paid on an hourly basis, or you're getting paid on a project base by base. So that's going to be here for getting started with freelancing, and we'll see you on the next one.
So after I learned a lot about Excel and started doing more and more projects for personal reasons and business reasons, I found myself liking it so much that it occurred to me that potentially this could be a way that I can generate some revenue. Because after working at multiple companies and I saw how they were using Excel, I knew that there had to be other companies out there looking for the same type of assistance. So as I was still working my day job, I decided to try to make some side revenue by offering Excel services. Well, luckily, it's pretty easy to start looking for business. There's a bunch of popular freelancer websites such as Upwork, People Per Hour, Freelancer, Fiverr, and so on. And all you have to do is create a profile and start bidding on jobs. And eventually you will land your first client. But for me personally, I knew I wanted to do this type of work as a career. So I did a little bit more than just creating a profile on a freelancer website. I decided to form an actual business. Now this is totally up to you. You don't have to form a business to start making money freelancing. But if starting a business appeals to you, I will tell you what I did so you kind of have an idea where to start. I formed a single member LLC. Now, I won't go into the details of all the different types of businesses that you can form and how they differentiate between each other, but in summary, by forming a single member LLC, I was able to create a separate entity, but was still able to file my business taxes on my personal tax return. So even though that I own a separate business, this made it really easy when it came to filing taxes. Plus, the cost of starting up this business was so low that I didn't find it very risky. But there is a lot of pros and cons of owning your own business, so I strongly suggest doing a lot of research before you just go out and start your own business. One of the main reasons why I wanted to form a business is, like I said before, I saw myself doing this as a career, and I wanted to open up a business bank account so that I can separate my business income and expenses from my personal income and expenses. So once again, forming a business to start freelancing is optional, but if you want to, I strongly recommend having a plan in place and doing a lot of research beforehand. Another step that I took before going out and looking for business was creating a website. Now, you don't need a website to start making money freelancing, but it could definitely help with your branding. Now, I know there's a lot of different website builders out there, and there's pros and cons of each of them, so I strongly recommend doing research to find the website that best fits your needs. After doing my research, I chose Wix. And for me personally, I had a really good experience using Wix to build my website. I thought it had low cost, it was very user-friendly to create the website, it helped with my brand legitimacy, and I was actually able to invoice my clients through Wix that allowed them to pay with credit card, which I found very useful. Now really quickly, let me show you what I was able to create using Wix. Here's my website, skyexcel.com. And this is the logo that I created to help me build my brand. But what you are seeing now is everything that I created from scratch from using Wix. And like I said before, the Wix creator was very user-friendly, and it didn't take me too long to create a professional-looking website. The main reasons why I wanted to create a website was to help with branding, and it's a good place to show off what you can do. For example, underneath my sample work tab, I have a bunch of different projects that I have worked on that I can showcase my clients if they are wanting to see of what I'm capable of. This type of evidence is very reassuring to the client, and it helps build that trust, making the client feel more comfortable with their decision on hiring you. So in summary, you don't have to form a business or create a website to start freelancing, but down the road, if you find yourself getting more serious about your freelancing work, having a business or a website can definitely help with your branding and legitimacy.
In this video, we're going to go over some of the top freelance websites that you can get started with in your Excel career. So these are a list here of some of the recommended freelance websites out there that you can get started with, which ones I recommend that you get started with, and then also some other job sources that you can look for, various jobs, getting started in the Excel industry, right? And so let's go ahead and jump into some of the top freelance websites. Okay, so the top 3 freelance websites that I recommend are going to be Upwork.com, Fiverr.com, Freelancer.com, and we're going to go into these in a lot more detail. However, I recommend Upwork probably number 1 because you're going to be able to get started very quickly, very easily, and you get to bid on a variety of different jobs, a lot of times even getting started for $10, $15 on these small gigs, so you can really build up that experience, build up that track record, and slowly build up your actual profile. And then here we have some additional freelance and job source websites. People Per Hour, I believe that's a freelance site. Same thing with Guru. And I believe that's it for this list here. You have ziprecruiter.com. That's going to be for a job board site. Same with Indeed, Glassdoor, Simply Hired, flexjobs.com. Obviously LinkedIn. LinkedIn's massive, right? You can look for a ton of jobs there all across the world. That's highly recommended. And then also Angel List here. This is a great site to be able to look for jobs for up and coming startups or even companies that just recently got funding, right? So think about companies that just got funded, they got millions of dollars, and oftentimes they're on a hiring spree. And so those can be great opportunities as well. So let's go ahead and jump into some of the top freelance websites. Okay, so number one here is the upwork.com, right? This is what I recommended here as far as number one, because this is super easy for you to get started with. They have a very simple screening process. They have fixed and hourly contracts. If you want to do on a project by project basis, or you want to do, hey, hourly base, where depending on how many hours a project is worth, you'll literally be able to track your hours and be able to get compensated accordingly. And then there's a variety of different projects with different scale of size. And then also you have the hourly contract protection. And what this essentially does is it protects you as a freelancer, even though for whatever reason, the contract work that you're doing, based on the hourly that you're getting paid, for whatever reason, it wasn't up to par with the client or whatever that may be, or something didn't get finished, right? You needed more hours. That always gets protected on your end, right? You're always going to get paid for that no matter, based off of your production, right? That's a big deal there with a freelance website, that you as a freelancer, your hours are protected. And then some of the cons here is that it's challenging to get your first project. You have to, like I said, bid very low on these small projects and do them for very, very inexpensive. But ultimately, again, it's for your benefit to get that experience, to get those, different feedbacks from people, right? And then there's a lot of competitors with lower rates, right? And we walked through kind of what you can do to really set yourself apart in the previous lesson when it comes to freelancing. And then the job score goes down automatically if you don't work on Upwork for a while. So if you, let's say, are on Upwork, you have a perfect score, and for whatever reason you decide to go out there and get a job, well, just understand that your score, if you're not doing anything on Upwork anymore, is going to go down if you don't work for a while. So that's kind of a downfall there. It's a con, but still there's a ton of pros that outweigh the cons. So just want to give you kind of an understanding here of the Upwork.com. And then we have freelancer.com. This is going to be number 2 here. They also have a screening process. They have a process here where you can also get verified. And then they have also the fixed and the hourly contract types. And they also have many projects from different sizes and different scales. And then they also have a preferred freelancer program. So this is something unique to freelancer, where you can sign up and you go through this verification process, and they look through all your different skills and all this stuff, and it really gets you to where you are setting yourself apart on the marketplace, right, on the platform, because you have this preferred qualification and employers and clients can see that, right? And then some of the cons here: challenging to get your first project. Same thing with Upwork, right? You got to bid on these jobs that are very low, very inexpensive, just to get your feet wet. And then also many competitors with lower rates, and you must be on top of new jobs. But overall, highly recommend. Okay, and so that's going to be it here for this one, and we'll see you on the next one.
So for this video, I will be talking about how you can land your first client, whether it's through your own source or through a freelancer website such as Upwork. From my personal experience, the first few jobs that I worked on, I did them completely for free. And the reason why I did that is because even though I had some Excel skills, I truly didn't have any real experiences yet applying those skills to real life situations. So I thought it would be a good idea to reach out to friends, family, and other colleagues and see if they did any work inside of Excel. And based on what they said, I told them that I could potentially enhance those processes, but I wouldn't charge them for it. That way they would feel like they had nothing to lose. But once I did the job and they saw how more efficient it was, they could see that I could actually be beneficial for them, and then for future projects, I can start charging them. So even though that you're not making money right off the bat, doing free work is a great way to gain experience, build up your portfolio, and increase word of mouth. So like I mentioned before, having a stunning portfolio is really important to showcase your skills. And you can either have that showcased on your website or build your portfolio on a freelancer website such as Upwork. Now you can choose whichever freelancer website to help you find potential clients. And depending on what services you are offering, one freelancer website might be more geared towards that service than the other. For me personally, I've had a pretty good experience using Upwork. And for the rest of this video, I will be talking about my Upwork profile and strategies that I use to gain clients. So first, we are going to discuss what clients look for in freelancers. The three main aspects that make up a legit freelancer is the amount of hours you worked, the total earnings you have made from projects, and your job success score and reviews. So really quickly, we are going to jump over to my Upwork profile, and I will show you what I mean by all these. So here's my Upwork profile. So just solely on Upwork, I have earned over $10,000 with just 7 jobs with a total of 277 hours. Now granted, I don't solely work through Upwork. I also have a lot of personal clients through my Sky Excel business. But this right here alone can show clients that I've done quite a bit of work through Upwork. And if we take a look up here right underneath my name, I have a 100% job success score. Now when a client sees this statistic, this makes them feel really comfortable that I could complete the job successfully and provide a positive experience. Because more than likely, once you bid on a job, the person hiring you for that job will take a look at your profile and the reviews that you have gotten on previous jobs. And if we take a quick look at my work history, they will see 5-star reviews and reviews such as Skylar was very knowledgeable and communicative and accomplished exactly what I needed in a very efficient manner. Will absolutely hire him again if I need more work. Highly recommended. Or did everything I needed him to. Great with Excel VBA, and so on. So reviews like these are very important to receive because it really makes you stand out and it makes people feel more comfortable with their decision on hiring you. So in order to get those amount of hours worked, total earnings, and increase your job success score, you have to get jobs to work on. Now bidding on jobs on freelancer websites is very competitive. You might have 50 different freelancers applying for the same job. And some of those freelancers are already well established on that website. They have hundreds of hours worked and their earnings are really high, and it looks very appealing to the person that is hiring. So it's really easy to choose the well-experienced freelancer. Well, most of the time, those high-quality freelancers will charge anywhere from $60 to $100 an hour. And some people will not be willing to pay that much. So you might have to charge a lower rate to get the job. A lower rate doesn't mean that you are bad at what you do. So be honest with your client, tell them your story, and they might end up choosing to work with you because you have told them that you have the skills required to complete this job, and your rate looks a lot more appealing to that $100 per hour rate. I will say it took me quite some time to land my first job on Upwork, just because my profile was so empty. But I promise you, if you keep on bidding, mix up your strategies, be honest of what you can and cannot do, you will eventually land your first client. But once you get that client, you have to do everything in your power to create the most positive experience for that client. This means being communicative, responsive, going above and beyond the job requirements that they listed, because if you do all of those things, this will lead to good reviews and a good job success score. And these are some of the key factors that clients look for in freelancers. And once you get your first client, it's easier to get your second client. Then it's easier to get your third, fourth, fifth, and so on. And as long as you keep on providing a good experience for that client, you start to build up your profile, and then you can finally start charging more. Because now you are able to showcase your skills, establish that trust between you and your client, and earn the top rated badge on your profile. And really quickly, if we go back to my Upwork profile, right here underneath my name, I have the top rated badge. And this is a huge advantage to have over other freelancers, because once you have this badge, clients will start inviting you to jobs, so you don't have to spend so much time bidding on other jobs. And like I said before, I don't solely get clients through Upwork. So I am still in the process of building my Upwork profile. Although freelancer websites are very competitive, they still provide a great way to gain access to potential jobs. So I hope some of the things that I've said in the past few videos sparked a few ideas inside of your mind and gave you a good starting point on how you can start making money with Excel or any other freelance service that you want to provide.
In this video, we're going to go over personal branding. This is something here that you can do to really be able to set yourself apart from the competition, right? Because there's a lot of people out there who have a resume, who have the experience. However, the big thing that they're missing is the personal branding element. And this is where you're going to be able to set yourself apart from the competition, because you're not only going to have a really well laid out resume and have that experience behind you, but you're going to be able to have that personal branding element and factor to really set yourself apart in the competition between you landing a job or even landing a particular project if you're starting out with freelancing or whatever that may be. But personal branding is going to help you position yourself as the go-to expert in your field. So let's go ahead and jump into personal branding. Okay, so what exactly is a brand, first and foremost, right? A brand is the way a company, organization, or individual is perceived by those who experience it. So it's essentially how somebody perceives you. It's that perception that you build, right? And so we want to be able to build a perception of ourselves that we are somebody who is not just your average candidate. We are somebody who thinks outside the box. We're somebody who is unique, who is talented, who's multifaceted, right? Who has all these different things going for them. And we're not just a name and experience, right, on a resume. And so personal branding, this is where you are the brand, right? You as an individual. And so it's your online persona. It could be through LinkedIn, through your website, through your blog, through Twitter, or any other relevant online platform. And essentially how you are positioning yourself, the content that you're putting out there, the material, right? How you're positioning yourself as the go-to expert in your field. And all of this can be done very quickly, very easily, all through social media. And we're going to walk through how you can do that here in this lesson. And so it essentially allows the outside world to directly perceive your skills, personality, and experiences through the online digital type of media, right? So very important there to understand you're really putting on a show, you're putting on a persona, which is telling the world, hey, I'm an expert in my field. I know what I'm talking about. I know what I'm doing. I'm extremely valuable, and I would make a great fit or be a good fit for any organization out there. And then the active personal branding is putting yourself in a strategic position to broadcast the value that you bring as an expert Excel user, right? I just mentioned that. It's pretty much you positioning yourself as that go-to expert in your field and broadcasting that to the world, right? So whenever somebody's landing on your Facebook page, on your Twitter page, on your Instagram, on your LinkedIn, which LinkedIn should probably be your number one platform, but you should be positioning yourself all the time as, hey, I'm the expert, I'm the go-to, person in my field, and this is why. And we're going to show you here in a moment how you can either put together your own content or be able to get content out there that is related to your field and be able to post that on your social media profiles to position yourself and broadcast to the world that you are an Excel expert. Okay, so what you can do here to really position yourself as that go-to expert is having a social media presence, right? Obviously, you want to have a website. We're going to walk through that in another lesson as well. But having a social media presence is really going to make you create that perception that you are somebody who isn't just an expert, but you are someone who doesn't just have a resume with experience. You have a lot more that's to you, right? And then at a minimum, you should have profiles on LinkedIn, Facebook, and Instagram. And you don't have to post every day on, your profiles here as far as different content. However, maybe posting, once a week, couple times a week, right? Just really showing the world and, your subscribers and your followers that you know what you're doing, right? That you know what you're talking about. You have the expertise, you have the credibility. And if you don't want to go through all of that, what you can do as far as, creating your own content is you can go out there and get a service through Buffer and Q and spend about $20, $30 a month and be able to automate posts on your social media. So let's say you sign up with Instagram, Facebook, LinkedIn, right? And you are on there, you're active, you're maybe making some posts here and there, and you're creating all this content, from scratch. Well, what you can do is go to Buffer, connect all of your social medias to it, right? And then what that tool does is it automatically posts all of your different content to your profiles at any given time. So you're able to schedule out posts weeks, months in advance. And so what you're able to do with Q is Q allows you to go out there and find content that's already been created, all different sources of online, and you're able to find the ones that make the most sense for your background, for your expertise, right? So if you're looking for, content and information on Excel, on how to be able to visualize data, or information on data analysis or business analysis, things like that, where they're going to be related to your field, right? And you're able to post these automatically on your Buffer, right? And so what ends up happening is you find this content on Q, you program it and you automate it through Buffer so that it's scheduled out for weeks, months in advance. However many times you choose to post per week, it's posting automatically to your profiles and it's showing the world that, hey, you know what you're talking about. I mean, this is something that I used previously when I was really heavy going into client acquisition. I was, using LinkedIn a lot for a lot of my social media posting, a lot of articles that I would be sharing. And this wasn't information that I was putting together. It was just articles that I was sourcing and I was posting them on my LinkedIn profile to my audience. And I would have people contact me and say, hey, Juan, I'm interested in what you have going on. It looks like you know what you're talking about. I can tell you know what you're talking about because you're obviously posting valuable information. And so never underestimate that, the ability to be able to position yourself through social media, through personal branding, and be able to position yourself right as that go-to expert in your field and be able to ultimately set yourself apart from the competition. So that's going to be here for this one, and we'll see you on the next one. In this video, we're going to go over networking do's and don'ts. So this is also a very important lesson here because I see time and time again a lot of people going about networking in the wrong way. A lot of people will typically use networking and they'll, go after individuals and talk to people with selfish type of interest. Well, that isn't going to necessarily work in the networking world. You have to be able to know how to go about it properly and some of the things to do and some of the things to not do so that you're not turned away, you're not turning people off, and they're actually looking to try to help you any way they can, so they can connect you with different people, they can connect you with different opportunities, and you can, always have people and backing you that, are able to, be in your best interest. So let's go ahead and jump into the networking do's and don'ts. So building a network is one of the most important things that you can do for your career. And it's best for you to get started right away where you're able to connect with people, where you're able to, message them and just really get your name out there in the marketplace. And one of the best places that you can go out there and do this is on LinkedIn, where you can connect with different people in your network, out of your network. You can connect with people who are, connected within your network. You can go to second connections. third tier connections. And so you really are able to build a nice network on LinkedIn and be able to take advantage of that for your particular career, because as the old saying goes, it's not what you know, it's who you know. So the more opportunities that you have, right, the more people that you know that are in your field that can point you in certain directions, that can introduce you to certain peoples, right, is really going to make the difference in your career. And like I mentioned, most people go about networking the wrong way. What they're typically looking to do is go out there and talk about themselves and talk about what I've done, and this is what I'm about and this is what I can do, versus coming across trying to just be genuinely interested in the other person, looking to add some value, seeing how you can be of service to that individual. And even if you're not doing whatever it is that you are recommending, and you're just saying, hey, I'd like to help you out and do XYZ for you, even if you don't ultimately do that, just the fact that you are offering that will get people to want to actually help you out, because nobody likes people just coming in and asking for help or asking for, hey, can you do this favor for me? Can you do that for me? But then offering nothing in return, right? So be very mindful of that when you're talking to people. Instead of going to, an opportunity here or a scenario where you have a connection or you're looking to build a connection with somebody, don't go in there with your own self-generated interest, right? What you can do is go in there and be able to acknowledge them, saying, hey, John Smith, I was looking at your profile, looking at your background, I'm really impressed by what you've done at XYZ. Hey, listen, I'm interested in seeing if there may be an opportunity, or you may know somebody who is looking for XYZ, whatever that may be. If you can keep an eye out, I'd really appreciate that. And then also the same thing for you on my end, where if something comes up, I'll keep an eye out for you, right? Something like that, or just really acknowledging them, their background, their history, their expertise, right? And seeing if there's an opportunity there, if they know somebody. But just coming in and saying, hey, can you do me a favor? Can you do this for me, right? Is not going to get people to respond to you, and it's going to turn a lot of people off. So make sure you're at least acknowledging them. You're, giving them praise as far as their background, their, expertise, their accomplishments, and then seeing if, like, hey, there's an opportunity here for you to recommend somebody, or if you know somebody who may be looking for, XYZ type of, workers or individuals, right? So that's how you want to go about networking. You want to remember to always lead with acknowledgement or value, and never just go in there trying to ask for a favor with your own self-interest. So that's going to be here for the networking do's and don'ts, and we'll see you on the next one. In this video, we're going to go over the importance of having a website and a blog. So in the previous lessons, we talked about personal branding, getting started with freelancing, and being able to create your own resume. And so in this particular lesson here, we're going to go through why it's important for you to also have a website and a blog as well, so that you can really set yourself apart with your personal branding, so that you can really set yourself apart from the competition, right? Because you're going to have the personal branding element, you're going to have a very unique resume, you're going to have social media, right? And then having a website, having a blog is really going to take your game to the next level, because it's going to be essentially your online resume, your online persona, right? And believe it or not, a lot of people out there don't even have their own personal website or have any kind of personal branding. And so this is why it's important to be able to have your own website and be able to position yourself as that go-to expert in your field. So let's go ahead and jump into the importance of having a website. Okay, so having a website will add the extra credibility to your personal brand, right? We talked about how you can get everything set up with your social media, why it's important for you to have like LinkedIn, Instagram, and also like, Facebook, and be able to post different content. If you have a website as well, along with your personal brand, right, that's just going to go to the next level. So being able to have a website will really add that extra credibility for your personal brand, or for, being able to build that perception of you being an expert in your field, right? And then for a website, all you really need is a simple $10 domain, and then $5 a month hosting plan, and WordPress CMS, which is a content management solution, and then an SSL. And then all of this can be set up through Namecheap.com. Very inexpensive, like I said, $10 for a domain, which could be, yourname.com, and then the $5 a month, hosting plan there to host a website, and then building it on WordPress, and then the SSL is the security certificate as well. And then what you can do is you can purchase a website theme or template from themeforest.net. So you can go on there and look for a template that you like and then purchase that for $30, $40. And then you can go to Fiverr and get them to set up your website just like the demo, and you'll be able to make the different customizations according to how you want to set it up. Or you can just have them quickly install the website and do some minor customizations. Altogether, it probably cost you about $100. However, it would be a investment that is well worth your time, energy, and resources, because it'll allow you to have that extra element to your personal branding, right? And really being able to set yourself apart from the competition out there who just has a resume with experience with nothing else, right? Another recommendation here is that you can also just go to Wix.com and also create a simple website there. That's going to be a very simple drag and drop website builder. And then if you want to also add in a blog, this allows you to write content, to write articles, and really position yourself as that expert. Like, hey, I know what I'm talking about. Here's this great piece of content. Here's this great piece of information, valuable content to the user base or anybody who's on my website. And it also gets the ability to get picked up by Google, and it shows that credibility and expertise to your visitors, right? And so just imagine that you are able to submit your application, right, your resume, to a particular job, and you have on there all your social media profiles, you have your personal website, right? Think about what that does in terms of separating yourself from the competition versus just somebody out there who has a resume with experience, right? You're really going to set yourself apart and position yourself as somebody who's not just your regular, particular individual or candidate, right? You're going to be a candidate that's one of a kind. So that's going to be here for the website and the blog lesson, and we'll see you on the next one.